In this video, I will be taking you through the complete process of structural framing, modeling, analysis, and design of this paint house. A paint house is a partial floor or projection built above the roof level, and by the end of this video, you will fully understand how to approach its design from start to finish. We will begin with structural framing, where you will learn how to properly position your columns, beams, and slab to achieve both safety and economy in design. I will walk you through the governing principles in column placement, how to ensure efficient load transfer, and how your framing decisions affect the overall stability and cost of the structure. We will also discuss about floating columns, which many engineers and architects often misunderstand. Floating columns are columns that do not start from the foundation level. They rest on beam or slab instead of transferring load directly to the foundation. I will explain what they are, when to use them, when to avoid them, and how to design them properly to prevent failure. Next, we will move into modeling, where I will show you how to model and properly understand ProtaStructure interface. You will learn how to model a floating column, cantilever beams, hinged beams, as well as the concept of primary and secondary beams. This is a detailed step-by-step guide that will help you model any structure accurately and comfortably. After modeling, we will proceed to analysis and design. These two goes hand in hand. In analysis, we determine the internal forces acting on our structural members, that is columns, beams, slab, and foundation. And in design, we provide reinforcement to counter those forces that we have seen in our analysis to ensure safety and economy. I will show you how to carry out interactive design so that you don't just consume what the software gives you blindly, but learn how to verify your output using fundamental engineering principles. Don't forget, all these are well detailed in my paid course, which come with a lot of bonuses. That is free CV template, free software installation, free detailing template that I personally use, and finally, you will have access to me and my online community. Invest in the paid course, you will gain a lot from it. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering. In this channel, I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. This is the architectural plan we'll be working with, and if you can see, this is the ground floor layout, and if you can see, this is the first floor layout, and then we have the second floor layout, which serves as the penthouse. So this is the 3D view of the architectural plan we'll be working with. If you see, this is it, and also this for this one, this is from one side, this from this side, and then this is the back view. Yeah, so this is the architectural plan we'll be working with in the course of this video. And in this video, we are going to go from the structural framing, then to modeling, then to analysis and design. All this will be done in ProtaStructure. After that, we'll enter into foundation detailing, part-based detailing, column detailing, slab detailing, beam detailing, even staircase detailing, and I will show you how to print your drawing to make it look professional, so it will not be like what an amateur did. So first things first, I've already said this. If you have been watching my videos, I'll say that first thing first, when you get an architectural plan, is to make a copy of that architectural plan. That's the first thing you must do, to make a copy. So this is the architectural plan. This is the architectural plan we'll be working with. So first thing that we must do is to first of all make a copy. So I'll just highlight it. You know, in this channel we use multiple shortcuts. So the shortcut for copy is CO. Just type CO on your keyboard or CP on your keyboard. You click on enter. So I'll copy it out. That is the first thing that you do once you get any architectural plan. First, to copy it out, I will escape. Then after escaping, the next thing that you do after getting your architectural plan is that you study that architectural plan. That's the next thing. After making a copy of that architectural plan, reason why we do make the copy of that architectural plan is because in case we make mistake doing the structural framing or at any point, we can easily reference back the original drawing. Remember, as I copy this one up, I'll be working on this. So if I make any mistake on this, I can just easily come here and refer back or reference back to my original drawing. But if you don't copy out this drawing, that means if you make any mistake, you have to get back to your architect to send you back this floor plan. But that's why it's always advisable, please make a copy of it whenever you are doing your structural framing. Then after making a copy of it, the next thing we are going to do is to study our structural plan. Yeah, to study it. Reasons why we do study our architectural plan: one is to know whether it is a residential building or a commercial building. Remember, the loading in a commercial building is far different from the loading in a residential building. That is why we are much better than all these artisans on site. You know, all these artisans on site, after they have finished working on more of residential building, they will now start boasting that they have known how to construct or design a building. But if you give them the commercial building, they will use the experience they have in a residential building, and work in that commercial building, which will cause and result to the failure of that building. Why? Because the loadings are different. For example, in a family house, the maximum loading that you can get can be highest 30, 20. But in a commercial building, you'll be talking about 50, 100, 60. That means the loading is far different. So in studying your architectural plan, you check, is this a commercial building or is this a residential building? And as you all know, this is a residential building. Then the next thing is that you check is that, is there any gym area? Is there any gym area in this structure? Is there any gym area? For example, this is the ground floor plan. In this first floor plan, assuming you are having a gym area here, assuming here is a gym area, that means the loading of this slab will be different from the loading of other slab. Yeah, why? Because the equipment, all the gym equipment, they will have high load, and for that they will now insert high load on the slab. That means if you're not designing the slab, you have to input a very high load on the slab to be able to counter those load it will carry from. That means the loading on this slab will be far different. So that's the thing you are going to check. Do you have any gym area in your structure or area that is carrying any heavy load? It will not necessarily be a gym area. It can be an area carrying a heavy load. For example, there is a structure, some of the structure, you see that they will be having their generator, that's their gen house, at the roof level. In that type of situation, that means in that slab, you have to load that slab well, because that not just only a gen will be sitting on that slab, vibration, that gen will be causing vibrations on that slab. That means you have to load it very well. So these are the things you study in your architectural plan. Is there any gym area, or is there any slab carrying a very heavy equipment? So you know how you're going to load it, do your modeling. Do you want to master structural design in just 10 days? I created a course where I carried out the full structural design of this residential building step by step. In this course, I broke down everything you need to know about structural design, starting from the fundamental engineering principle all the way to the practical detailing. Honestly, it is far more in-depth than anything you will find for free on YouTube. And think about it, if my free lessons are already this good, just imagine my paid courses where I poured out all my knowledge and real-life experiences. This 10-day structural design masterclass is all you need to become a confident and competent structural engineer. And the best part is, it is affordable, because I consider that most of you are still students. So click the first link in this video description and access the course. And also after that, you check, is there any cantilever in your structure? For example, if I come over to this point, yeah, I am seeing, that means I'm having a cantilever. Yeah, this is a cantilever. That means there might be a column at this point. Yeah, that's what it means. There might be a column at this column. A column might project outward. We might have a floating column. What is called a floating column? Don't worry, I will still get to explain the meaning of a floating column. Okay, a floating column is just any column that does not start from the foundation level. That's just a floating column. Any column that starts from the first floor, second floor, third floor, and above, it doesn't start from the foundation level. It is called a floating column. So you check whether is there if you're having a cantilever, that means we'll be having a floating column. So you know, doing your modeling, you know how you go about it. Then finally, the thing that you're going to check is that is this structure, is it a basement structure or not? Because if it is a basement structure, please take note, your structural framing or your GA, that's general arrangement drawing, will not be done in your, it won't be carried out on your basement floor. All the structural framing must be done on the ground floor. Yeah, it must be done on the ground floor. If don't be tempted to carry out your structural framing on the basement floor. It must be done on your ground floor. So these are the reasons why we do study our architectural plan. There are also many other reasons why we do study architectural plan. That's why I will advise you, if you want to learn everything, you can get my course. That's my 10 days intensive structural design and detailing masterclass. Get that course. That course will really help you, because this YouTube video, I'm not really diving in depth in structural analysis and design. But if you get that course, I went in depth in everything you need to know. So I'll advise you, get that paid course. It's very affordable, because I consider the fact that most of you watching this video are all students. So it's advisable that you get that course. Okay, still continue on what I'm saying. After studying your architectural plan, next thing to do is to delete anything that is not necessary to you as a structural engineer. Many things are not necessary to us here as a structural engineer. For example, these dimensions, they are not necessary to us. If we need our own dimension, we input it by ourselves. And another thing that is not necessary to us as a structural engineer. Okay, in some of the buildings, you'll be seeing all this bed furniture, chair furniture, and all these let me say WC furnitures and all these things. Delete all those things. They are not necessary to us as a structural engineer. We will not be using it, because we'll be inserting our columns and beams. And Please, if you are deleting things that are not necessary to you as a structural engineer, please don't be tempted to delete your windows. Please don't be tempted to delete your windows, because during your structural framing, if you delete windows, you might mistakenly place a column at a window position. For example, let me give you an example. For look at this point now. Assuming I come and delete all my windows, I might mistakenly place a column at this point because this is an edge. Yeah, this is an edge, but this is a window position. I should not be having any column at this point. So if you are doing your structural framing, please don't be tempted to delete any window. Yeah, don't be tempted to delete your windows, because you might mistakenly place a column at that window positions. So delete everything that is not necessary to you as a structural engineer. So in this case, this is not necessary to me as a structural engineer, and two, this is not so necessary to me as a structural engineer. So what I'll do is I will like click on what, select similar. Everything has been selected. Then I'll move back and then hold my shift key. Once I hold my shift key, I'll deselect this and then click on E, enter. So this is what I'm having right now. Also, another thing I'll advise you is that get this start file and practice. Yes, get this start file and practice. Look at, I've done almost everything. This is the foundation layout, because if you get the start file, you also get this. You get the foundation layout, you get the path base, that the detailing, and you also get the column detailing. Look at, we have several types of column, but we'll still go into this once we start our modeling. You get to understand all these things. You also get the first floor beam and column layout. You also get the slab layout, the slab detailing. I'll advise you get the CAD file, and practice. If you watch 100 videos without practicing any, but another person just watches only 10 and practice those 10, I bet you that person that watched 10 and practice 10 will be far better than you at the end of the day. That person will be far better than you. So get the CAD file and practice. The CAD file is very, very cheap. I don't think it is more than $2. Yes, it is not more than $2. Yeah, it is not more than $2. So it is very, very cheap. It's very, very affordable. Get the CAD file on your own and practice well, because practice makes you perfect. If you see consistency, that's what they call consistency beats intensity, in the sense that I'll advise you to be practicing almost every day, because you'll be far better than, if you practice every day, you'll be far better than someone that practice once in a week. For example, if you practice 30 minutes per day, this is how I got good. Yeah, this is how I got good in structural design. So if you practice 30 minutes every day, and another person practice for 7 hours only on Saturdays, let me tell you the truth, at the end of the year, you'll be, that person that practice 30 minutes every single day will be far better than that person that practice 7 hours on Saturdays. Yeah, because consistency beats intensity. So I'll advise you, be consistent. If you are still in your university, be consistent in this social design, so that once you come out, you know what to do at all points in time. So practice, get the CAD file and practice, because practice makes what perfect. So after deleting the things that are not necessary to us, I would not like to delete all these things. I'll still leave them. Okay, look at, I would like to delete this. Yeah, I would like to delete this. So I'll do E, enter. I like to delete this. So after deleting things that are not necessary to us as a structural engineer, so we'll be creating our grid line layer and our column layer, because the next thing we are up to do now is to place our columns and our grids. Yes, to place our column, we'll place our column at various intervals. Don't worry, I'll still get to explain the governing principles in column placement, because column placement is totally dependent on the engineer, but the engineer has to follow the governing principles. And two, since you are watching this video, you are going to learn the governing principles in column placement. So right now, what we'll be doing is that we'll be creating our column layer and our grid layer. So remember, I told you in this video we deal mostly with shortcuts. I'll type layer. So I'll just type layer and click on what, enter. So a dialog box will appear. So this is the dialog box. So I'll come over and click on this layer property. If you can see, it's called new layer. I'll click on this new layer. So I would like to do YouTube. I'll just do YT. That stands for YouTube. I'll not do column. Yeah, I'll do column. Remember, I told you we are creating 2 layers. I'll not do column. So this is my first layer, but I would like the color. I would like the color to be, the color of my column to be green. I'll click on OK, and I would like the line thickness. I would like the line thickness to be 0.5. Yes, I'll click on OK. I'll click on OK. So this is my first layer, which is the column layer. Then I'll create another layer, which is my grid line layer. So I'll also type YouTube, because this is a YouTube video, and then I'll now type grid. Yes, I'll not type grid. So this is it. But I'll now like the color now. I like the color to be, let me go with blue. I'll click on OK. Then I'll change the line width to by layer. Yes, or to default, any of them. And then click on OK. So right now I've created these 2 layers, which is the grid layer and the column layer. So I'll come over to this my layer point now and select my grid layer, which is Y, which is, look at it here. This is my grid layer. So I'll select it. So once I select my grid layer, I'll come and locate the center of this block wall. Okay, I'll I'll do L, enter. L stands for line. Remember, I told you I'm using shortcut. So I want to turn on my auto key. You can either come to this point and turn on your auto key, or I'll just do Control F8. Control F8. My auto key will just turn automatically. So I'll draw a straight line from here to here. I will escape L, enter again. I'll also draw a straight line from this point to this point. So this is what I'm having. The reason for this straight line is that so that I'll be able to locate the center of this block wall. Okay, let's check the dimension of our block wall. The dimension of our block wall is 225. Yes, and I'm also sure if I also check here, I'll be having 225. So this is the dimension of our block wall. So I drew this line to be able to locate the center of this block wall. So I'll do SL. SL stands for construction line. Remember, I told you we'll be using mostly shortcuts in this video. SL stands for construction line. Enter. I'll then do V. Enter. I'll click on this. Then I'll escape. Then I'll do SL. Enter. I will then do H. H stands for horizontal. V stands for vertical. Then I'll locate the center. So at this point, I don't need this again. At this point, I don't need this again. Remember, you can get my 10 days structural design 10 days structural design masterclass. That's 10 days intensive structural design and detailing masterclass. It is the first thing you see in this YouTube video. Yes, it is the first thing you see. Yeah, it's the first thing you see in the description of this video. Yeah, it is the first thing. Once you get it, I explain everything. In fact, all the practical knowledge, all my practical experience, I explain everything you need to know about structural design and detailing in that course video. Yeah, you have to pay for it, but it's cheap. Yeah, because I consider the fact that most of you are students. So if you are placing this, make sure you place it in all your wall intersections. Please place it in all your wall intersections. Place it, don't miss out anyone. Yeah, at the end, anyone that we are not needing, we will delete it. Anyone that we don't need at the end, we will delete it. But please place it at all your wall intersections. So right now, I've placed it at all my horizontal walls intersections. So I will escape. I'll come over and copy this vertical one. CO, enter. Please place it at all your wall intersections. I'll copy it from this point. I'll place it at this wall intersection, and also I'll place it. Okay, I'll place this one at this point. Remember, get the CAD file and practice. Get the CAD file and practice. Practice makes perfect. I'll also place it at this point. I'll also place it at this point, and then I think I've not placed it here. I'll place it at this point. Just place it at all the wall intersect at all your walls. And at the end, anyone that we don't need, we'll just delete it. I'll also place it at this point. Anyone that we don't need, we'll just delete it. So I've placed all my grid line. If you see, this line is running throughout this whole AutoCAD interface. Reason is because this is a construction line. Yes, it's a construction line. So to delete all these excessive lines, what I'll do is that I'll come and click on rectangle. You can come and click on your rectangle, or you just type REC. REC stands for rectangle. You can click on it or type it, enter. Remember, I told you we are using mostly shortcut. Then I will have a rectangle around this. I want to have a rectangle around. Hey, I don't like this. Let me delete this. E, enter. E stands for erase. E stands for erase. So I would like to extend. Okay, let me just delete it. E, enter again. Then I'll click on my rectangle. So I want to have rectangle around this. So I'm having it here. So you then click on highlight this your rectangle. Then do TR. Please. Sorry, escape. Control Z. Control Z is to undo. Control Z to undo. So you now highlight this your rectangle. Then type ETR. Enter. Please make sure you highlight this rectangle, because if you not highlight this rectangle and then trim off this, everything will not be trimmed off. But please make sure you highlight the rectangle before you start trimming off. So I'll also trim off this. Yes, I'll trim off this, and then finally I'll trim off this. So I'll escape. If you see that those construction line is nowhere to be found again. But if you not highlight your rectangle, you still see it at the end. So I'll click on this and then do E, enter. Do you want to master structural design and detailing in just 10 days? I created a course where I carried out the full structural design of this residential building from start to finish. In this 10-day structural design masterclass of this residential building, we carried out the structural framing, modeling, analysis, and design every structural members. We analyze the forces acting on them and design reinforcement to counter those forces. From there, we move into foundation detailing, part-based detailing, column detailing, slab detailing, even staircase detailing. We also sectioned and detailed our staircase and slab. And finally, I showed how to print and present your drawing professionally. This course is highly in-depth because I poured out my knowledge about structural design into it. Honestly, it's more in-depth than all the free structural design videos on YouTube. And think about it, if my free lessons here on YouTube are already this good, just imagine my paid courses. This is all you need to become a confident, competent structural engineer. It is an investment you will never regret in this life, because remember, the greatest investment with the highest return is the one you make on yourself. And the good thing is, this course is highly affordable, because I consider the fact that most of you are still students. The link to this course is in this video description. It is the first link you will see. Go and enjoy every bit of the lesson. Do you want to master structural design in 10 days? This course will get you there. So this is what I'm having right now. Then next thing now is to place our columns. Yeah, Next thing now is to place our columns. That's the next thing. So I'll come over to this point. I'll click on this. I'll come and select my column layer, which is YouTube column. That's my column layer. I'll click on it. Then you also come and click on you can just type, you can type rectangle, REC, or you come and click on it. Enter. Then remember, I want to explain something. Remember, I told you, before I explain something, if you want to learn more about all these things, I want to explain that. Please get this 10 days intensive structural design and detailing masterclass, because I really explained everything there. But let me start, because everything I will explain on this YouTube is I will not really go in depth, but in that course I went in depth. So let me explain something now. Column placement is totally dependent on the engineer. That's one thing you have to know. It is totally dependent on the engineer. For example, I might place my column, and another engineer might still place his own column, but my column position and his own column position will not be the same. But the thing is that all the engineers, they must follow the governing principles in column placement. You must follow the governing principles. So first of all, our column dimension, I want to use the column dimension of 225 by 225, because the minimum column size you should use, the minimum is 225 by 225. Please don't go below 225 by 225. The minimum column size you should use is 225 by 225. But if you are having 150 block wall, that is 6 inches block wall, you can use a column size of 150 by 450. But the lowest you should use, our advice, the lowest you should use is 150 by 350. That's the lowest. Don't go beyond that. Don't go below that. So I'll have my minimum column size. So I can just come over to this point and just type I'll do at. Once you type at, you now do 225 comma 225. You click on enter. Yeah, you can do your column like this, or you can just come to this point. We have done here, we have measured this and measured this. So you saw that our broker is 225 by 225. You can just come and place it here. So this thing now, let me click on my dimension. So this now, from here to here, you see that it is 225 by 225. Look at it, 225 by 225. If you shake this one, if you also shake this, you'll be having 225 by 225. Yeah, so anyhow you want to place it, you will place it. So right now, remember, I've told you that the minimum column size you should be using is what? 225 by 225. So I'll do CO, enter. So I'll do CO, that's to copy, enter. So I'll copy it from the center. I'll remove my auto key by clicking on Ctrl F8. So my auto key is gone. So I'll press here. So I like to place it at all my, in your column placement, please place it at all your wall intersections. So I like to place at all intersection. Then after, I'll now start checking whether I will delete some columns or whether I will leave the whole columns. Let me explain something now. Please make sure, let me escape. Please make sure that the, remember, the if is for beam now. For beam, it is column that connects beam. Do you understand? It is column. For example, this is my column and this is my column. So there will be a beam running here, and to this beam now is being connected by this column and this hot column. So it is your column that connects beam. So in your column placement, please make sure that the spacing is no more than 6 meters. Because if the spacing is more than 6 meters, that means the beam itself will be more than 6 meters. Yes, and if the beam is more than 6 meters, that means there will be high moment on that beam. And if there is high moment on that beam, it will result to higher reinforcement or you increasing your depth. I hope you're understanding. So in your beam, in your column placement, please make sure that your column placement is limited to this column of it is limited to the spacing of 6 meters. Let me give you the maximum moment for a simply supported beam. The maximum moment for a simply supported beam is WL square over 8. W is the uniform distributed load acting on that beam. L is the length of that beam. Square, and if you can see, you're having L square all over 8. That means moment is directly proportional to length. That means the more, and in that formula, length is L square. That means the more the length, the far more the moment, because length is L square. So that is why we are advising you that in your we don't mean that, okay, in your column placement, please don't go beyond 6 meters. Don't go beyond. It's not that your beam cannot go beyond 6 meters. That's not what I said though. Your beam can go beyond 6 meters, but as a young structural engineer, I'll advise you limit your column spacing to 6 meters so that your beam will not go beyond 6 meters. Because if your beam goes beyond 6 meters, that means we'll be having a depth of beam above 450, or we'll be having a higher reinforcement. For example, if it goes beyond 6 meters, we might now start having 4y20, 3y25, and if your client see 4y20, 3y25, they might not start asking you, I build so building, but look at this, they use 4y16. So to avoid all those things, as a young structural engineer, limit your column spacing to 2y16. Is an advice that I will give to every young structural engineer. Reason is because we want to have a beam depth of 450. Yes, a beam depth of 450. It's not that your column, it's not that your beam length, it's not that your beam length cannot go beyond 6 meters. It can go, but if it goes beyond 6 meters, there are things involved. It's either you have more depth or you have a higher reinforcement. So it is just advisable. But if you want to learn more about this, get my course, which is the 10 days structural design, 10 days intensive structural design and detailing masterclass. Get that course. I really explained everything there. So I hope I've explained this. I'll do CO enter. Okay, let me escape again. I'll CO enter. Then I'll copy this from the center. Then after, I'll now come and start checking, is it more than 6 meters or is it less than 6 meters? Don't worry, by you watching this video, you get to learn a lot of things. So I would like to press it. I'll do Ctrl Z. Remember, I told you to be pressing your codes at all your wall intersections. Yeah. I also like to place it here at the end. Anyone that we don't need, I will delete it. Anyone that we don't need, we will delete it. At the end, anyone that we don't need, we delete it. Yes, at the end, anyone that we don't need, we will delete it. So I can have, we not place a grid line at this point. We not place a grid line at this point, and we should have a grid line at this point. So let me. I would like to escape. Let me just escape. I'll do SL enter. I'll do V enter. V is for vertical, so I would like to place it at this point. Then I'll copy this. I'll do MA is to match property, enter. Then I'll come and match the property of this. So I've gotten a grid line at this point. So I'll like to copy this. I'll do CO enter. CO stands for copy. I'll copy from the center. Then I'll like to place it at this point and also place it at this point. Don't worry, after we delete the ones that we don't need. Yeah, after we delete everything, I'll place it at this point. Remember, get the cat file and practice. Get the cat file and practice. Get the cat file and practice. So at this point, I will not place column at this point yet. Yeah, after I'll explain some things here, I will not place column at this point yet. Then I'll place a column at this point, and then I'll place a column at this point, and I would like to place a column at this point, and I also like to place a column at this point. After we delete the ones that we don't need, I'll also like to place a column at this point, and I'll also like to place a column at this point. I'll also like to place a column at this point, and I would like to place a column at this point. I would also like to place a column at this point. Let me zoom where to place a column at this point, and I would also like to place a column at this point, and then finally I would like to place a column at this. Okay, let me place it. Where should I place it? Okay, no, remember, there is no beam will not be running here. Beam will run across this. Yeah, across this block wall. So I would like to place a column here. Yeah, beam will run under this block wall. So I think I'm through with my column placement. So right now, I will now start checking, is any of my column above 6 meters? Like the spacing, is there any column that is above 6 meters? Based on the things that I've explained. Remember, if you want to learn more of it, you can get my course, cat file. You can get my course, 10 days social. Is the first link you see in this video description. So I'm having 3.75. So it's below 6 meters. So I'll leave this beam. This beam is okay for me. I'll also repeat linear. I click to repeat linear. I'll check from here to here. 1.36 meters is okay. I'll leave this. I'll leave this two columns. Then okay, don't forget. Let me tell you something. Please, if you're having a staircase, it is advisable. To have for you to place a column at the edges of your staircase. That's here and here. It is advisable to place a column at the edges of your staircase so that it will be able to carry your step. Yeah, it will be able to carry the staircase. So I'll leave this column, even if it's shorter than, even if it's 1.2 meters, I'll leave it so it will be able to carry my staircase. So I'll still click to repeat linear. This one we agree that I'll leave it. Then okay, I would like to check from here to here. Then having 1.6, I'll click again to linear to shake from here to here 3.6. I'll then right click again to shake from this point to the center. Yes, to the center, I'm having 5.1. 5.1, I'll leave it like this. Yes, I would like to leave it like this. I would like to leave this like this. I will not remove it, even though it is less than 6 meters. I would like to leave it like this. Reason why I would like to leave it like this is because I know I've studied this. Remember, I told you, if you are studying, to check whether you are having any cantilever. So at this point, I'm having cantilever. Yeah, I'm having cantilever. So don't worry, you still see the usefulness of this column that I have here, because at this second floor, I'm having cantilever. Yeah, this thing pulled out. If you check, okay, let's check from here to here is 760, and also let's come over to this point and check from here to here. That's 1.36. That means we're having a cantilever. So we're having a cantilever. That means this thing is pulling out. So for that reason, don't worry, you see, understand, but for that reason, I would like to leave this column, even though it is still less than 6 meters. Remember, I told you your column spacing should be less than 6 meters, and if it is less than 6 meters, please delete the intermediate columns. Yeah, because they are not really useful. But in this case, I would like to leave it because of this cantilever at this top here. You still get to understand the things I will explain about it as we progress. Yeah, so I would like to leave this. So I will delete this dimension because I don't need it again. Enter. Then I'll also come and click on my dimension again. At this point, I'm having, okay, I would like to check the distance from here to here, and also I will click again, repeat linear, the distance from this point to this point. Okay, I have from this point to this point. Okay, 4 point and 1.2. I'll then click repeat linear to check my whole length. This is 5.2, 5.2, but I'll still like to leave this thing like this because of this cantilever I'm having here. Yeah, here is the cantilever. If you see, look at the offset here. From here to here, look at the offset. But if you check my second floor, look at the offset is more. That means there is a cantilever. So for that reason, I'll still like to leave this column at this point because of that cantilever. So I'll still like to leave it. Then I'll come and delete this. And also I'll come and delete this E. Enter. Then at this point, this column, they are too close. Yeah, these two columns are too close. I would not like to be having a very close column at this point. So what I will do is that I will delete this column. I'll do E. Enter. Then this one, a beam will now project here as a cantilever to carry this long beam. Do you understand? I will not make it that a beam will now project from here. A very short beam will project, and then carry this long beam. Then means we'll be having a cantilever beam carrying this long beam. So that's what we'll be having. Then I'll click again. I'll come again and click on my dimension again. I'll check the dimension from this point to this point. I'm having 2.225. So I'm okay with it. I'm okay with it. Then I click again. I'll check the dimension from here to here. 1.25 is very short, but I'll still leave it because this is an edge. Yeah, this is an edge, and to this is an outer edge. So I'll still like to leave it the way it is. We should be having a column at this point, and also we should also be having a column at this point. So I'll just copy one of the columns. So I'll do CO, enter. I'll copy from this edge, from this bottom edge. So I can decide to place my column at this point, or I'll create a new grid line. I'll place it at this extreme point, one of them. But I would like to be having a column at this point. I would like to have a column at this point and not at this point. Let's check the length first of all. So from here to here, I'm having this to be 2 meters. Yes, 2 meters. Okay, let's check. Okay, if you can see at the second floor, this is also another reason why I say you must study your architectural plan. At the second floor, here is a void. That means there is no slab at this point. Yes, there is no slab at this point. So for that reason, I could assuming at the second floor, assuming at this floor now, we're having a slab. That means I will place this column. Wait, let me copy a column. I'll do CO, enter. I'll copy from here. So assuming there is a slab at that first floor, that means I would like to place a column here. Yeah, because the slab will transfer its load to the beam. But since there is no slab at the first floor, I will place my column at this point, even though it is 2 meters. Reason is because there is no slab. That means the only thing this beam will be carrying is just the wall load. And at this point, it is not even carrying anything. It's carrying only the beam. It's carrying only the grass, only the window load, because there is no wall here and there is no wall here. So that means it is not carrying much load. And the reason why I place it here is for ease of construction. Remember, at site plan is already all this column, they are all already in alignment. Yeah, this column, they are all in alignment, so it will be easy to place this column aside than placing it here. Because if I place it here, that means none of them is in alignment. That means they need to create a new grid doing the foundation for this column. So I want to leave this column here for two good reasons. One is for ease of construction, because all these columns are already in alignment. Second is because there is no slab load coming to this beam. That means it is not carrying much load. Yeah, that means this beam now there's no slab load coming to it, and also we're having a window here. That means it is not carrying any wall load. The wall load is carrying just from here to here. So for that reason, I'll leave my column at this point. So this is how engineers make their decisions. Yeah, this is how we make our decision. We don't just do guesswork. We make decisions using engineering principle and many things. So in this case now, yeah, I would have said let me place a column at this point. But if I place a column at this point, that means it will be obstructing the window position. So I will not do that. So look at what I'll do now. I'll just do CO, enter. I'll copy this from this point. And I'll place it at this point. Yes, I'll place it at this point. So once I place it at this point, I'll come and copy this. I'll do CO, enter. I'll copy this grid line and then place it at the center of this. That means we are now having two grid. I'm now having a grid line on this column position. Yeah, remember, if I don't place a grid line here in ProtaStructure, I'll not be able to locate this column. Yeah, I'll not be able to locate this column because every column must come out with a grid line. So that's it. So this is what I'm having right now. Then at this point now, the next thing that I'll be doing is that, okay, I'll come again. I'll click on my linear again. Check the dimension from here to here. You see it to be less than 6 meters. Yeah, 2.9. So I'm still okay with it. I'll come again and right click again, linear. I'll change dimension from this point to this point. Yeah, 2.2 meter is okay. I'll right click again. I'll check the dimension from here to, okay, let me check from here to here. I'm having 2.62. I'll right click again, repeat linear again. I'll check the dimension from this point to this point. I'm having 1.22. I'll put it, and then let me check the whole length from here to here. So I'm having 3.8. So if you see, I'm having, okay, I would like to explain something here. Please pay attention. What I would like to explain here now is that look at it. I'm having this here. Most people now, if it's all these artisans on site, they will place a column here, and place a column here. But for the fact you are watching this video now to upgrade yourself, but if you want to upgrade yourself more, please get my 10 days intensive structural design and detailing masterclass, because you learn everything you need to know about structural design in that course. And so the link is the first link you see in this course video, in this video description. So if it's all these artisans on site, they will place a column here and place a column here and also place a column here. Do you understand? That means, okay, and if they do all these things now, their reinforcement will not be 2y16, 2y16, 2y16. Do you understand? But for us now, if we press a code, but for us now, we are seeing that this thing is less than 6 meters. That means we have to delete this E, enter, because it is less than 6 meters. But in a case, for example, assuming I'm having a beam length of 5 meters, and I delete this column, assuming I'm having a beam length of 5 meters, and I delete this column now, that means there is a probability that after designing, I'll be having a very high reinforcement, of something like 3y16. Yeah, 3y16. Then your client might now come and start telling you that all the structural design, all the building that I've built, they have been using 2y16. Why is it that in your own I'm seeing 3y16 everywhere? Please explain to that client that you know that they lack knowledge. So explain to that client that most of these people, they don't know structural design. That is why if you check those buildings that they built that is having 2y16 all around, that means they have too much columns in the building. For example, they will place a column here, and also place a column here. Remember, if you place a column here, place a column here, and also place a column here, you can never be having 3y16. You must surely have 2y16. But if you place a column at this point and also at this point, and your length is 5 meters, there is a probability that you'll be having 3y16. So explain to that, okay? You know that once they start saying 3y16, they'll start complaining. But if they see column around this whole building, or if you scatter column around this whole building, they will never complain. Yeah, they will never complain because they don't know. But if they start seeing 3y16, they'll tell you that I built so building, this place, and they use only 2y16. Why is your own? Why am I having 3y16? Please explain to them. It's because we are trying to save cost. Okay, I even forgot to mention. That's why I say you should get this my course video. The goal of every structural engineer is first safety. After safety, the next thing is to save your clients money. That's the next thing. The first goal is safety, and after safety, the next thing is to save your clients money. That's why I say you should get this course video, because most of the things I might forget to say some things, but in that course video I make sure that I table down everything. So the goal is safety, and after safety is economy. So having a column at this point and at this point, you have safety in view. Is the structure safe? Yes. But is the structure economical? No. Having a column at this point and at this point, just two columns, is the structure safe? Yes. Is the structure economical? Yes. So the goal must be safety, and after safety, economical. So that's why if a client see column round the whole building, and then all the beams are 2x16, 2x16, that client will never complain. But that client doesn't know that they are wasting his money. They don't know, because column contains 4x16 and concrete. It contains 4y16 and concrete. But if I should allow that beam to span 5 meters, and then I will now have 3y16, I save cost now. I save cost because I was able to remove a full column, a whole column. So the client doesn't know this. So most of the times, if they are telling you that your structure is very expensive, try and explain some of all these things. If they are telling you that they are seeing 3y16 instead of 2y16, try and explain some of these things to that client so that they will get to know. And let me tell you the truth, if you ever explain this thing to them, the next time they will call you back, because they know that they will not know that you know what you are doing. They are not doing guesswork in your design. I hope you understand. But if you don't really understand, you can just back forward this video, or you get my course video, and you get my paid course, and then learn more of this. Yeah, and learn more. That's the 10 days structural design, 10 days intensive structural design and detailing masterclass. Yeah, you get it to learn more of this. So this is 3.72, so it's okay. It's less than 6 meter. I'll like click again, repeat in here, and this is 4.22. I'm okay with that. It's less than 6 meter. I'm sure if I check these ones, they'll still be less than 6 meter. This is 3.52. I'll like click again. Sorry. I'll right click again, repeat linear, then I'll shake from here to here, and this is 3.45, so it's okay. Then let me shake all these inner ones, then I'll right click, repeat linear. I'll shake from here to from here, since from here to here passed, that means from here to here will also pass. Since from here to here is less than 6 meter, that means from here to here is less than it will also be good. So I think I'm through. I think I'm through. I am true. Yes, I'm through. Then the next thing I'll be doing right now is paneling. That's placing my slab and my beams, paneling. So I like to also tell you the principle in paneling. Please make sure that your slab panel is less than 30 meter square area. Reason is to prevent deflection. Deflection doesn't really mean that the structure will collapse, but it means that the structure will deflect under that load. It will deflect while carrying that load. And to remember, if a structure should deflect while carrying the load, the people living inside that structure will no longer feel comfortable, because they will feel that the structure will collapse. So please make sure that your slab panel is less than 30 meter square area before you continue. So right now, I'll be creating my beams and my panel. So I would like here to be my panel 1. Yeah, I would like here to be my panel 1. So I'll first of all, okay, I want to delete all this window position, because this will no longer be necessary to me again in this structural framing. So I would like to delete this window position. Sorry, E. I'll do E. Enter. Remember, I told you that you should make sure that your paneling is I'll also do E. Enter. Your paneling should be less than 30 meter square area. So I'll click on this column. I would like to click on this column. Once I click on it, do SE. SE, that's extend. SE stands for extend. I'll extend this and also extend this. So I'll also come and extend this and then extend this. So this is what I'm having now. Then I'll also come and delete all this, because I don't need these things again. All these windows position and the rest, I don't need them again. I'll do E. Enter. Then I'll click on this. I'll do ES. Enter. I'll come and extend this and then extend this and then extend this. I'll also come and extend this and then extend this. So this is one panel now. Then I'll shake. Is this less than 30 meter square area? Let me just shake first of all, and then I'll explain to you what to do. If it okay, this is 3.7. I'm having 3.7 linear, 3.7 by 3.5. So if you see, this is far less than 3. This is far less than 30 meter square area, because if we do 4 times 4 is 20. So 3.7 and 3.5 is far less than 30 meter square area. So that means we can call here one panel. Okay, in a situation, if I'm having that this thing now is more than 30 meter square area, what should I do? This is part of the reason why you should get this paid course, because everything is being explained there. Okay, but I'll still say it here. What should I do? If this is less than 30 meter square area, what you do is that first you either increase your slab depth from 150 to 175, from 150 millimeter to 175 millimeters, or you break this slab, or you break this slab. For example, assuming this is 30, as this is more than 30 meter square area, I'll copy this, I'll also copy this, I'll do CO, enter. I'll just come and break this slab. I'll just come and break this. Maybe I'll just place it at this point. Yes, I'll place it at this point. Then this will now become one panel, and this will become one panel. Yeah, that's if it is more than 30 meters square. I'll use a beam and break this. I'll use a beam and break the slab, and this will be one panel, and this will be one panel. But there is no need of this. But there's no need of this because this is not more than 30 meters square area. So I'll delete this. So this is my first panel. So I'll delete this, and then I'll also come and delete this E, enter. Then I'll like the whole of here to be my second panel, the whole of here to be my second panel. So I'll delete all this because I don't need them again. Yeah, I don't need them as a structural engineer. I don't need them again. And also I'll delete all this. Okay, I also need to delete this once. I'll do E, enter. So everything has been deleted, everything has been deleted. So I'll click on this, do ESC, enter. Then I'll extend this line. Okay, I'll escape again. I could have clicked on this line to ESC, enter. I'll come and extend this, and come and extend this. So this is what I'm having now. Okay, I'll extend this, and okay, I need to delete this. E, enter. Let me click on this. I'll do ESC, enter. So I'll also come and extend this. So this will be my one panel. This will be my panel two. Yeah, this will be my second panel. So I'll do E, enter. I want to delete all this in. So I'll check, is this less than 30 meter square area? Yeah, I'll do from here to here. I'm having this to be 3.4. Remember, here we got here to be 3 point something here, and this is 3.4. So it's far less than 30 meter square area. Then I also like here this panel, this to be my panel 3. I like here to remember all this right now is not my beam line. This is not my beam. Like this is my beam, this is my beam, and then this is my beam. Yeah, they are not my beam. So I like this to be my panel 3. So I'll come and copy this. Remember, you can get the CAD file and practice. The CAD file comes with these things, even comes with the structural drawing of this. Yeah, if you get the CAD file, you get to get the structural drawing. Yeah, you get to get it for free. At a very cheap rate. To our website to get the CAD file, you also get this architectural plan. Yeah, you get everything you need to know about everything about the architectural plan once you get the CAD file. So I'll advise you to get the CAD file and then practice on your own. Practice makes what perfect. Don't just watch the video. Practice. I'll do E, enter. So this is what I'm having. Then what I'll do is I'll come and click on this. I'll do ESC, enter. I'll extend this line, and also I'll come over to this point, extend this line, and then finally extend this line. Then I'll come over to this point again and do ESC, enter. I'll extend this and also extend this. So this is now one panel. Yeah, this is now one panel. The next thing that I'll be doing is that I would like to make here one panel. Yeah, I like to make here one panel. So what I'll do is that I'll delete everything that is not necessary here. I'll delete this whole thing. I'll delete everything here. I'll delete. Okay, I'll delete this. I'll delete this, and I'll also come and delete this. I'll do E, enter. Yeah, I'll delete all this, and I'll also I'll leave this. Yeah, I'll leave this E, enter. You see the reason why I'll leave it. So I like the whole of here to be one panel. Remember, here is toilet and bathroom. Okay, let me go and check. This is why you should always make a copy. So if you see here is toilet and bathroom, and he projected outward. Yeah, so I'll still leave it like that. So let me come over to this point. Then I would like to click on this. I would like to click on this and also on this and do ESC, enter. And I'll extend this, extend this, and also extend this. Then at this point I'll now click on this MA to match property, and I'll match this to this, and then this to this. Yes, so this is what I'm now having. But in my modeling, I will not place a beam here. Yeah, I will not place a beam here. I'll just have a cantilever. I'll just have a cantilever here. But I just leave it like this. I'll just have a cantilever beam. So a cantilever slab at this position. Yes, but I just left it like this. Yeah, I just left it like this. So I would like to delete this E, enter. Okay, sorry. Okay, I'll also like to D, enter. Then I'll do ESC, enter. Let me extend this line back. So this is what I'm having now. Then at this point, I'll say that I like the whole of here to be one panel. So I'll also delete this, and then I'll come over to this point and then delete this E, enter. Then I'll come and click on this line, and then I'll also click on this column and do ESC, enter. Sorry, I'll escape. ESC, enter. I'll extend this line and also extend this line. then I'll come and extend this line and then extend this line. So this is now one panel. Yeah, I'll do E, enter. This is now another panel. Then I'll also write this dining area to be one panel. Yeah, I'll write this dining area to be one panel. So that means I have to delete all this. Yeah, this panel is totally dependent on the structural engineer. Yeah, it's totally dependent on the structural engineer. So I write this to be one panel. E, enter. Then here, this is the staircase. So I don't need it. I don't need it. I don't need it. I'll do E, enter. I'll still delete it. So I write here to be one panel. So what I'll do is that I'll click on this and also click on this and also click on this and then I'll do ES. ES stands for extend. I'll extend this and also extend this, and I'll come over to this point, extend this with extend this and also extend this. I'll come over to this point and extend this and also extend this. So this is now one panel. Yeah, this is now one panel. So I can just bring this thing downward. Yeah, so this is now one panel. This is now one panel. Then if you want, you can decide to trim it off, but it's not really necessary to trim this thing off. That trim off is TR. So I also like to have a panel here because this is a staircase. This is a staircase. So I would like a beam to cut off this staircase. So I might just okay, escape. I might just copy this. I'll just extend this from this point to this point. Yes, and I'll match property MA, enter, and I'll match property of this. And then here I'll just do OFF, sorry, OFF, that's to offset. I'll click on enter. What is my offset distance? I'd like it to be 225 because I want to introduce a beam. And remember, the width of our beam is sent in as the width of our block wall. So I'm still using 225. I'll click on enter. Then I'll offset this in 225. The reason why I added this beam is because so that the load coming from this slab will be transferred to this beam. That's why I added this beam. So that the load coming from this slab will be transferred to this what? Beam. Remember, here is a void because this is a staircase. So I'll delete this and also I'll delete this. Yeah, I'll delete this. I hope you understand me. Yeah, I'll delete this. Click on delete. Everything has been deleted. So this is what I'm having, and I would like here to be okay. I would like here to be one panel. So I'll come and delete this E, enter. Then I'll do ES, enter. So I will extend this. I will also extend this. So this is now a panel. The whole of here is now a panel. Yeah, the whole of here is now a panel. Then coming to this, remember, coming to this, we are having this, but don't worry, we'll still go, you still see how we are going to go about this. You are still going to understand how we are going to go about this. Then the next thing is that we have to panel here, but remember, we said that our slab panel should not be more than 30 meter square area. So, and if you see all these ones, okay, there's no panel here. All these ones, they have been small. So let me check whether the whole of this thing will be it will be less than 30 meter square area. That's the whole of here. I'll do here and here. Let me just check so I'll know what I'm doing. Let me know that I will make it one panel. So from here to here is what? 5.15. Repeat linear again. Then I'll do from this point to this point. Here is also 5.2. So 5.2 times by 5.15. So if you see, it is less than 30 meter square area because it's 6 times 5, that is 35. So 6 times 5, that is 30. But I'm having 5.1 and 5.2. So it's not up to 30 meter square area. But if you want to confirm, we can just type cow. That's for calculator, quick calculator. We'll do 5.1 times 5.2. So 5.1 times 5.2. Let's know what we are having. So I will now click on my equal sign. So if you see, it's 26.52. So it's not up to 30 meter square area. So we are good to go. So that means I'll make here one panel. I'll make the whole of here to be one panel. I'll make everything here to be what? One panel. Yes, that's what we are doing. Everything here will be one panel. Everything here will be one panel. We'll be deleting everything here because everything here we have made it to be what? One panel. So we'll delete, and I'll also delete this. I'll delete this, and then finally I'll come and delete this because I don't need them. I'll do E, enter. Everything here is what? One panel. Everything here is one panel because it is less than 30 meter square area. Remember, if you want to dive deep into structural design and detailing, you can get my paid course. Yeah, it's very, very cheap, very, very affordable because I consider the fact that most of you are all what? Students. So I would like to delete this E, enter. Then I would like to come and click on this. Once I click on this, I'll do ES, enter. That's to extend. I'll extend this, and also at last I'll come and extend this and also extend this. So this is what I'm having right now. I'll delete this E, enter. I'll also come and delete this and also delete this. I'll do E, enter. So right now we have okay. I'll also come and delete this and also come and delete this E, enter. So right now we have successfully placed our columns, our beam, and our slab. Yeah, so this is what we are having right now. This is what we are having right now. Next thing is to superimpose. So what is superimpose? Superimpose is that we'll come and copy this whole column, all the column that we're having at the ground floor, and place it at the second floor to know whether any of the column will be popping out at the slab. Yeah, to know whether any column is popping out at the slab. Don't worry, you understand what I mean by superimposing if I do it now. So I'll just like click on what select similar. So if you see, it's already this column has been selected because I created a layer for it. So I'll do CO, enter. So I'll copy it from the staircase. Please copy from the staircase region because other side might change, but the staircase will never change. Everywhere might change, but the staircase will remain the same. Yeah, so I'll also come and place it at this point. So we'll check. So if you can see, we're having that this is popping out at the slab. It's popping out at the slab. This is also popping out at the slab. These two, they are all popping out at the slab. These two, they are all popping out at the slab. What else? What are we having again? We're having that these are popping out at the slab. So these ones that are popping out at the slab, I'll change the color to red. Yeah, I'll change it to red. Yeah, because they will terminate at the ground level. They will all terminate at the ground level. Hope you understand it. Since they are popping out at the floor, they will terminate at the ground level. Then that means I need to introduce a new columns. I need to introduce a new column. And two, if you can see, it's because I know that this thing will be terminating, because I know that this column, they will be terminating at the ground floor. They will be popping out. They will be popping out. That's why I insisted, even though we're having 5. Even though when we check the spacing between this and this, we're having it to be 5.1. That's why I insisted that this column should be here and also this column should be here, because I know that because I know that I know that there is a cantilever here. Yeah, there's a cantilever here. And since there's a cantilever here, if I place a column at any point again, I'll be having high moment. I don't know whether you're understanding. But let's just continue. You will still understand as the video goes on. But if you don't understand, I advise you get the paid course. So at this point, so this is what we are having right now. That means this will terminate, this will terminate, this will terminate, and then this will terminate, this will terminate. That means we have to create a new column position. We have to input a new column position. So in this case, I would like to move this one. I would like to do CO, enter. I like to move this column now to this extreme. Yes, I would like to move this column to this extreme. Once I move it to the extreme, I'll change it to magenta. Yes, I'll change it to magenta. So,
are you a civil engineer? Let me ask you a question. What if in just few days from now, you can pick up any architectural plan, confidently carry out its full structural design and detailing, and start earning from it? Sounds unreal, right? Stay with me because I'm about to show you exactly how. I created a 10 days intensive structural design and detailing masterclass to show you step by step how real structural design is done in practice, and this course is designed to last for 10 days. Before I show you what you are going to learn, this is the architectural plan we'll be working with, and we will carry out its structural design and detailing. Day 1 of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests, but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about path-based footing detailing. Day 6, column detailing. Day 7, beam detailing. Day 8, slab detailing, and you will understand the governing principles in slab reinforcement, that is how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10, you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan, and finally you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally, access to our online engineering community where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course now.
So this is what I'm having right now. Then okay, let's go back. Let's go back. If you see, we placed a column at this point. Yeah, we placed a column at this point. Yeah, I let it to be so. We placed a column at this point. Reason is because I met with the architect. I met with the architect. So we agreed. We came to a resolution that let's allow a column to be here, because if I don't have a column to be here and I should have a column here and a column here, I'll be having a very long cantilever. Also adding to the fact that I have a cantilever slab at this as story one. That's a cantilever slab as story one. That means the load will be more. That's why I went to the client, and then we agreed to place this column at this point. Yes, we agreed to place this column at this point. So that's why you can see here it should be vacant, but I still placed a column. I placed a column at this point, and also at this point, and also at this point. It's because I agreed with the client. And if you check the architectural plan, where is the architectural plan? So you see that there's no column. Look at it here. There's no column at that point, but I placed a column here because we agreed. I met the client and we agreed that let's leave a column here because this is carrying a cantilever slab. Look at it. This is a cantilever slab, and today we'll be transmitting the load. That means if I don't have a column here, that means we'll be having a cantilever slab, a cantilever beam, and to that cantilever beam, we may now be carrying a very high load, which can result to a higher reinforcement. So that's why we now agreed to have a column at this position. Yeah, I forgot to say it on time. So that's why I included it now. Then okay, knowing that I've pressed we are here. I have pressed a new column at this point. Then at this point too, I'll do CO enter. I'll place this column. I'll place this column at this point. Yeah, I'll place column at this point. Then I'll turn this to what? Magenta. Sorry, I'll turn it to magenta. Yeah, magenta is our new column. So if you see, it is placing. I placed it at the slab. Yeah, there's no wall here. That means it's not hiding in between walls, because normally I should place it like this so that it will hide inside the wall. But in this case, it is not hiding inside the wall. It's outside. Yes, I also came to a resolution with the client to place it at that point. Yeah, okay, look at it at this point. Look at it. Let me show you that point in the building. Let me show you that. Okay, look at it at this point. It's at this point. Yeah, I agreed with the client to place it here. Yes. So wait, let me look at it again. Let's go back. So this is what we're having right now. So I'll be having this here. Yeah, we agree with the client. I'll place it here. Then for this one, I'll move it. Let me turn on my auto key, Control F8. I'll do CO enter. I'll take it inside the wall. Yeah, I'll place it inside the wall. It will be here. Yeah, for this one now, I'll take it inside the wall. That means this will not turn to what? Magenta. I'll take it inside the wall. And also for this one, I'll take this one now. I'll take this. I'll do CO enter. I'll copy it from this point and I'll place it at this point. Yes, I also came to a conclusion with the client to place a column at this point. Yeah, I'll place it at this point. So this is what I'm having, right? So this one will terminate and I'll place it at this point. Then this one now will terminate. I'll come and place it at this point. Yes, I'll come. Okay, let me check. I want to check something. I want to check the distance from this point to this point, so I'll know where I'll place it. 6 point something. So it's very much. That means I must have a column here. So I'll come and copy this column now. I'll do CO enter. I'll copy it and I'll copy it from this point and I'll come and place it at this point. Yes, and I'll change this to magenta. Remember, you can get the 10-day structural design and detailing masterclass. You see the architectural plan that we used here. There are a lot of floating column, because this will not serve as a floating column. This will serve as a floating column because it did not start from the foundation level. It started from the first floor level, so it's a floating column. Yeah, you get to learn what you need to know about floating column in that 10 days structural design, detailing and detailing masterclass. You get to learn all you need to know about floating column. So I'll advise you get it. So this is my new column position. All others are inside the block wall. Yeah, all the columns are inside the block wall. So this one came out of the block wall. Look at it, and this one it will stop at the ground floor, and then a new column will start here. This one it will terminate at the ground floor. A new column will continue from here. This one it will terminate at the ground floor. A new column will start from here. Terminate at the ground floor. A new column, and then terminate at the ground floor. A new column. So at this point now, at the second floor, we'll be having a beam pulling out. A beam will pull out. Yeah, a beam will a beam will pull out to carry to a beam will pull out that it must have a cantilever to carry this load coming from all this. Don't worry, once we get to modeling, you get to understand. So right now we have successfully done superimposing. Yeah, we have done our superimposing, and so we are good to go. So I like to do SL enter. So I like to place I'll do H enter. I like to place a line at this point. I like to place a line at this point and also at this point. Then I'll escape. Then I'll highlight these two lines, do TR trim. I want to trim off this. I want to trim off this and also trim off this. So after, I'll then come and delete this enter. So right now what I'll do now is to delete all the grid line that I did not use. So I did not use this grid line, I'll delete it. This grid line, okay, this grid line is for this staircase. Should I leave it or I should delete it? Yeah, if I'm okay, don't worry, I'll just leave it for now. Okay, don't worry, before I start dating my grid line, I would like to do something. Before I date my grid line, I would like to do something. I would like to come and pick out the whole boundary of this. I like to pick out the whole boundary of this second floor. Reason why I'm picking out the whole boundary of this second floor is so that I will place it here, so I'll know where my cantilever is coming out from. Don't worry, after picking it out, you understand what I mean. So I like to pick out the whole boundary of this. I like to pick out the whole boundary of this. Yeah, the whole boundary. I would like to pick it. I would like to pick them out. The whole boundary of this second floor, of this first floor. Yeah, I like to pick them out. The boundary. Don't worry, you understand what I mean. Once I'm through, you understand what I mean. So that in ProtaStructure, once I'm modeling in ProtaStructure, it will be far easier. It will be easier. Yeah, I don't want to stretch myself. Don't worry, you understand. That's why you're watching this video. But if you want to understand more, get my course. You understand more from it. So I'll look out I'm having. Then then I also like to copy from here, copy this. I want to copy out all my walls. I'll also copy this. I'll also come and copy this and also copy this. Sorry, highlight, not copy. I'll also come and highlight this and also come and highlight this. Then I want to highlight all the boundaries. Highlight this, and finally I'll come and highlight this. So I'll zoom out. Let me check, have I highlighted everything? So okay, I've not highlighted this. Look at this one, I'll highlight this. Reason why I'm highlighting this is because you know that this is a void. Look at it, there will be a void here. Like in our first floor beam and corner layout, we'll be having a slab here. Yeah, look at it. Look at this slab projection. So it projected out a little bit. Look at this one. It's projected out a little bit. That means in our model we'll be having a cantilever slab at this point. Yes, we'll be having a cantilever slab at this point. So for that reason, that's why I highlighted this, so that I'll easily model it in ProtaStructure. Don't worry, you get to understand in our modeling part 2 video. In our modeling, that's the part 2 of this design. So right now I've highlighted. Okay, after I've highlighted everything, so I'll just do CO stands for copy, enter. So I'll copy this thing out. Let me just say I'll place it here. So once I place it here, I'll just do MA stands is to match property. I'll just match everything. So after matching property, I'll just do ES is just to extend. So I'll extend this. I'll also extend this. Yes, and I'll also extend this. Wait, I'll also extend this just to extend everything. Yeah, don't worry, you get to understand all they are doing. Once I'm through, you get to understand everything. I'll also come to this point and I'll extend this. Yes, I'll extend this and I'll also extend this. Then come over to this point, I'll extend this. Come over to this point, I'll extend this. Okay, I'll extend this. Then come over to this point, I'll extend this. Why is not extend? I'll extend this. I'll also extend it at this point. Yeah, okay. I'll also come and extend this. It's not extended. Don't worry, we'll see how we go about it. So I'll escape. Then if I escape, I'll turn on my auto key, Control F8. I'll turn on my auto key. I'll highlight this. So I'll move this to this point. I'll also highlight this. Then drag this down to this point. Then I'll move this one back. Okay, I'll move this one back. Yeah, or you trim it off, any one of your choice. Then I'll escape. I'll do R, enter. Enter. So this line will join from here to here. Okay, wait, let's just shake, and so we will be sure of what we are doing. So this thing terminated at this block wall. That means this one extended out. Yeah, this line now moved out and it terminated. So what we are going to do now is that we'll do enter. So we can either, okay, let's just save this thing like this. Let's save it like this. In ProtaStructure, you see how we model it. What I just want to obtain is just to get this line to know that this is my cantilever line. So what I'll do now is that I'll convert the whole of this into a block element. But before I do that, let me just trim up some certain things. I like to trim off this. I also like to trim off this. Yes, and after this, okay, I would like to convert this into a block element. Block element means that it will not be a one member. So I'll just highlight everything. Type B. B stands for block. So everything will be a one member. I'll click on enter. I'll just like to type this. Let me just type it block. Yeah, let me just go with block 1. So I'll click on OK. So right now, if you see, it's now a member. So that means everything has been converted to one member. So I'll do CO, enter. I'll copy this thing. Please copy from the staircase position. So this is my staircase position. I'll copy this thing. I'll remove my auto key, Control F8. I'll press it at this point. Yeah, so if I press at this point, you will now understand. So if you can see now, this point now is a cantilever. This is a cantilever. The reason why I did this thing is that so I can easily model this in ProtaStructure. I want to easily model this in ProtaStructure. So look at it here. This is a cantilever, and also this is a cantilever. This is a cantilever. Yeah. So we're also having a cantilever here. We're having a cantilever here. Coming to this point, we're having a cantilever here. Then this is also another cantilever. This cantilever that I showed you about, that I showed you here. Yeah. So this is a cantilever. So the reason why I did all this, the reason why I picked out the whole boundary is that so I can easily model this in ProtaStructure. So that's why I'll advise you. If you want to learn more of this, get the paid course and you will definitely learn more. It's the first link you are going to see in this video description. Yeah, that's the link to the paid course. Get it. It's very affordable because I know that most people watching this, they are all students. So after doing this now, next thing we'll be doing now is to delete all the gradient that are not necessary to us, like any gradient that we will not use, any gradient that do not pass through the beam or pass through the column position. That means that gradient is not necessary to us. So this grid line, look at this, is necessary to us because it passed through column and it also passed through beam. Then this grid line, it's not necessary to us because it not pass through any column and it also pass through any beam. It's not necessary to us. This grid line is not necessary to us because this is not a major beam. Remember, I told you that we are going to, okay, just know that since I told you that we are going to model this as a cantilever slab. When I was inputting this beam, I told you that we are going to model this as a cantilever slab. But since we are now having a general cantilever slab, look at it, all these things as a cantilever slab. That means if I'm having, that means this whole cantilever slab, this whole cantilever slab will now cover this. That means as I'm modeling this cantilever slab, this one is also involved in my modeling. So that means this is no longer a major grid line. I hope you understand. So this is no longer a major grid line because I can even choose to delete itself. I can even choose to delete it. Yes, I can choose to delete it. But doing my detailing in first floor beam and column layout, doing my detailing in foundation layout, I will input this. Yeah, because it will be docked for doing foundation. It will be docked for. Yes, so I'll select this because it's no longer necessary to me. Let's be fast. Look at this. They are necessary. This one passed through this. Okay, this one passed through this column. It passed through this column, so it's still necessary. This one passed through this beam and column. It's still necessary. This one is still necessary, and this grid is still necessary. Then coming over to the horizontal, this is necessary. This is necessary. This is necessary. This is necessary because it passed through this beam and column. This is necessary because it passed through this. This is necessary. This is necessary. And this is not necessary because it not pass through anything. It not pass through anything. And also this one's this is necessary. So I'll do E. Enter. So I've deleted all that is not necessary to me as a short, all the grids that are not necessary to me. So at this point, the next thing that we are going to be doing right now, the next thing that okay, you can just use it, but it's not necessary. Let me just save it. The next thing we're going to be doing right now is to save this as a DSF file because ProtaStructure only recognize a DSF file. And if you want to save this as a DSF file, please save it at origin so that you can easily locate your drawing in ProtaStructure. If you don't save it at origin, you might have a problem in locating your drawing. So save it at origin. So how are we going to save this now at origin? How are we going to locate our origin? You just type L, enter. You type 0, 0. That's to locate your origin. 0, 0. Okay, enter. Sorry, I made a mistake. I'll type L, enter. You now type 0, 0, enter. So let's check. Okay, this is my origin. So if you check, this is my origin. This is my origin point. So I'll just drop this grid line here. Yeah, I'll remove my auto key, Control F8. Then I'll come over to this point and pick up this my structural framing, or this is my general arrangement drawing. So I'll do CO, enter. So I'll copy it, and I'll place it at my origin. At my origin, so I can easily locate this in ProtaStructure. Yeah, so I can easily locate this in ProtaStructure. I'll do in, enter. So after placing this at my origin, I have to save this alone. Yeah, to save it alone, how are we going to save it alone? To save it alone, you use Control F8. sorry, you type w stands for web block. That's if you want to save something alone. For example, as me, you can still get, yeah, you can still get the cat file and practice on your own, because the cat file comes with even the structural drawing of this residential building. If you see, you have many different type of column, yeah, different type of column. If you get, but don't worry, I'm still going to explain everything, but get the cat file and practice, because the cat file even comes with this structural drawing. So what was I saying? I said that how to save a drawing separately. For example, if I want to save this drawing separately now, I'll just highlight it and just type W stands for web block. That's to save a drawing separately. So I'll come over to this point. I'll highlight it, type it stands for web block. I'll click on enter. Everything will appear. Then I'll come to this three dot. I'll click on this three dot. Once I click on this three dot, I'll now locate where I want to save it. So I want to save it at this point. No, I want to save it in my desktop. Yeah, this is my desktop. And what should be my name? What should be the name? I want to save it with YouTube, because I'm shooting a YouTube video. So I want to save it with YouTube. Let me say Henley, YouTube Henley. Let me now say one. Yeah, YouTube Henley one, because this is the owner of this brand, the owner of this drawing is Henley. So that's why I use Henley. So YouTube Henley. Then make sure that this is under DSF file. DSF file, because ProtaStructure only recognize a DSF file. Yeah. So I'll click on DSF file. So look at it. I'll then click on save. Then after clicking on save, please come over to this insert unit, and then choose millimeter. Yeah, choose millimeter, because our drawing is in what? Millimeter. Then I'll come and click on OK. So right now we have saved this as a DSF file. And we have come to the end of this video. In our next video, which is all about modeling, I will show you how to model this architectural plan. I'll show you how to model this architectural plan in ProtaStructure. Yeah, I'll show you how to model it perfectly, even how to go about this floating column. Please don't forget, if you want to dive deep into structural design and detailing, get our 10 days intensive structural design and detailing masterclass. Yeah, that course is designed to just last for 10 days. It is designed to last for 10 days. So I advise you get it. Not just that, if you also want to practice what you have done on this video, you can get the cat file. The link is in this video description, and also the link to the intensive 10 days structural design and detailing masterclass is the first link you are going to see in this video description. Get them and practice, because practice what makes perfect. If you watch video without practicing, I bet you the person that just watch few videos and practice all will be far better than you at the end of the day. So with all this, I want to say thank you. This video is all about modeling. Once you click on your ProtaStructure, it will bring you to this interface. So we'll click on new project. Once you click on new project, look at, we're having project code. You give your project a name. So since this is a YouTube video, I'll type it YouTube. Then I'll have this YouTube. This is a penthouse. I'll use penthouse. Penthouse. I'll just leave it as YouTube penthouse. You give your project a name. Then after that, you select the code that you want to use. So in this video, we will be using Euro code. Look at, we have BS code and we have Euro code, but we want to use Euro code. I'll click on Euro code, then click on OK. So once we click on OK, we'll allow the ProtaStructure interface to load. So while it's loading, please, if you have not watched the video where we did the structural framing, please go and watch it, because everything that we're going to be doing right now is somehow based on that video. So right now, the ProtaStructure interface have loaded. Then the next thing to do at this point is to import your drawing. That's the structural framing you did in AutoCAD. That's the general arrangement drawing. You import it to this ProtaStructure interface. How do you import it? You come to building setup. At this building setup, you come to external reference drawing. You click on it. Once you click on it, this dialog box will appear. You click on add DSF. This is the reason why we saved our drawing as a DSF file. So look at it. We say, if you can remember, we saved it YouTube Henley. I'll click on it and click on OK and click on open. So right now, look at it, is here. But if you see now, you are not seeing anything at this point. If you want to start seeing anything, you come and click on this active. You check this box. Once you check it, you are not seeing anything. If you want to use your color, you can click on the color. Yeah, if you want to reduce the color intensity, you can reduce the color intensity from this point. But I want to leave it at maximum. Then at this point, next thing that you'll be doing is that you come and import your members. That's your column and your grid line. If you can remember, we created two columns for it. We created two layers in doing structural framing. That's the grid line layer and the column layer. So at this point, look at it. This is member. So we want to import grid line column. We don't want to import wall. So I'll uncheck this. Then at this point, the grid line, I'll click on it. What do we save our grid drawing as? If you can remember, we saved it as YouTube grid, and this is it, YouTube grid. So I'll check on it and click on OK. Then I'll come over to this column point, the layer. What do we save our column as? If you can remember, we saved it at YouTube layer. That's YT YouTube. So YouTube column. So I'll click on it, then click on OK. So this is what I'm having right now. Then I'll come over to this point and then click on import. So as I click on import, I'll allow everything to import. So look at it, is important, is important. Yeah, if you see now, I will now click on close. So everything has been imported. So at this point, I'll just come here and click on close. So if you zoom now, everything has been imported. These are column. Look, if you can see, we are having a column of 225 by 225. That's what we use. And look at our axis. But if you are seeing now, our axis, they are not labeled properly. Yeah, they are not labeled properly. Look at it, A1, A11, A12. So I want to label this axis properly. But this can only be done for if you are using ProtaStructure 2022 and above. Yeah, so ProtaStructure 2025 and above. If you are using, let me say 2022, 2021, and so if you are using 2025, 2024 below, what you just do is that you click on this, you right click on it, you click on properties. Once you click on properties, you come over to this point and name it as 1. Then click on update. Look at it, it will not turn to 1. Escape, it will not turn to 1. But if you are using ProtaStructure 2025 and above, what you just do, come over to review, you click on label members, you click on it. Yes, you click on yes. This dialog box will appear. We want to relabel our axis. I'll come and click on my axis, then I will come and click on this, click on 1 and 2, yeah, and then click on OK. So look at it, everything have been relabeled automatically. But this can only be done if you are using ProtaStructure 2025 and above. Then at this point, the next thing that we'll be doing is that we want to be inserting our beams. That's the next thing. I'll come to my modeling. Once I come to my modeling, I'll click on beam. We have normal beam and wall coupling beam. I'll click on normal beam because that's what we want to insert. Then coming to our normal beam, what is the width of our beam? The width of our beam, we'll be using the width of our block wall, which is 225 by 225. Yeah, so that's what we'll be using. We'll be using the width of our block. So I will use 225, which is the width of my block. Then what is the depth of my beam? What is the depth of my beam? I'll be using the minimum beam depth. From the code, the minimum beam depth is 300. That's the minimum. Yes, I'll use the minimum beam depth, but if it fails, once it fails, I'll then come back to once after design, if it fails, and then I'll come and increase the depth. Yeah, if it fails, I'll then come and increase the depth. But if it doesn't fail, that means I'll go with it. So the minimum beam depth is 300. But don't forget, that beam depth will be having a slab on top, and so the depth of our slab is 150. So 300 plus 150 will be giving us 450. That means the depth of the beam that I'll be using here is what? 450. Hope you are understanding. Minimum beam depth is 300 plus the depth of your slab, which is 150. So 300 plus 150 will be giving us 450. So at this point, I will then start inserting my beams. I have a beam running here. If you followed us in structural framing, you'll be you'll be conversant with all this I'm doing now. Then this is it. I'll just be inserting my beams. Okay, I'll just drop this one here. I'll still explain something here. I'll still explain something at that point. Then I'll click on this. I'll insert a beam to this point. Then a beam will stay run like this. Then this beam now will now come and here. Okay, look at, I want you to understand something. The way this thing is now, look at it. This thing now, this beam now is my primary beam. Why this beam now is my secondary beam? This beam now is primary beam in the sense that it is being connected with in the sense that it is being held by two columns. Like this beam now is the primary beam because it is being held by this column and this column. So it is the primary beam. Why this beam now is the secondary beam? Because it is resting on a beam. Do you understand? It is resting on a beam. So it is resting on this beam. So in this case, this is my primary beam and this is my secondary beam. This one is not just a secondary beam, it is acting as a point load to this beam because at this point of intersection now, at this point where it is resting on this beam, it is acting at a point load. The load that is carrying is going to transmit it to this beam. So it is acting as a point load to this beam. Don't forget, if you want to learn more about this structural design, and detailing, get my 10 days intensive structural design masterclass. In that course, I explained everything. And so don't forget, that course is very, very cheap because I consider the fact that most of you are students. It is the first link you see in this video description, so you can go and get it. So because I will not really explain everything in this video, but in that course I explained everything you need to know. Yeah, so this is my secondary beam. Why this is my primary beam, and this beam now is acting as a point load. Okay, you want to master structural design in just 10 days. I created a course where I carried out the full structural design of this residential building step by step. In this course, I broke down everything you need to know about structural design, starting from the fundamental engineering principle all the way to the practical detailing. Honestly, it is far more in-depth than anything you will find for free on YouTube. And think about it, if my free lessons are already this good, just imagine my paid courses where I poured out all my knowledge and real-life experiences. This 10-day structural design masterclass is all you need to become a confident and competent structural engineer. And the best part is, it is affordable because I consider that most of you are still students. So click the first link in this video description and access the course. Okay, let me also explain another thing here. So if you can see now, if I drop this thing now, this arrow is the arrow of a cantilever. Yeah, this arrow is the arrow of a cantilever. But remember, but is it this beam that should be a cantilever or this beam? Which of them should have to which of them will be the cantilever? The one that you make to be the cantilever is the one that has a shorter rent. Yes, the one that has a shorter rent, make that one a cantilever, because don't forget, moment is directly proportional to what? Moment is directly proportional to rent, because maximum moment of a simply supported beam is WL square over 8, and to that moment is directly proportional to length over length squared. That means the more the rent, the more the moment. That means if this beam now is longer, that means there will be more moments on it. Why? If this beam is shorter, there will be a lesser moment on it. So for that reason, we'll be making the shorter one our cantilever length. We're making the shorter one to be our cantilever. Why this longer one will not be resting on it. Hope you're understanding. But if you want to understand more, don't forget, go and get my course. So I'll delete this beam. Then I'll come over, double click on this to bring out this property. I'll double click on it. Wait, sorry, I'll escape. I'll double click on this beam to bring out this property. Then, as we have concluded that this beam now should be the one of my cantilever, yeah, look at it, it is now having this side. Then this one will not be resting on it. This one will not be resting on it. This one now that is resting on it is not a cantilever. No, it is not a cantilever because it is resting on this beam. Why this one that has this arrow sign is the one that is the cantilever? Yeah. I hope you understood what I explained. Please get the course because I really went deep in that course to explain a lot of things. So I will escape. I'll still keep on inserting my beams. Remember, we'll be having a cantilever beam here. That I explained it during our structural framing. So if you have not watched our structural framing, please go and watch it. Then I also, this beam will now stop here. Yes. Then I'm having a beam from here to here. Yes, I will escape. And then I'm also having a beam from this point to this point. Yes, I will also escape. I'm having a beam from this point to this point. Yes, I will also escape. I'm having a beam from this point to this point. Yes, I will also escape. So I'm also having a beam from this point to this point. Yes, I will also escape. So this is what I'm having right now. I think I've inserted. Okay, look at the final beam. Oh, I not input a grid line here. So let me go back to AutoCAD. I'll go back to AutoCAD. I want to go back to AutoCAD and insert a grid line. So I not input a grid line here. Yes, so I'll do L, enter. That's to bring out my rent. I'll do L, enter. Then I will escape. I'll do SL. Enter. I'll do H, enter. That's for horizontal. I'll drop it here. Then I'll come and measure the distance between this grid line and this grid line. I'm having it to be 900. Okay, I'll come back to my ProtaStructure. Then I'll offset this grid line by 900. I'll click on what? Offset axis. Then I'll click on my Control F2. Then it's going up. That means it will be positive 900 because it's going up. I will click on enter. So look at that grid line here. I will escape. Look at that grid line here. This is the grid line. Yes, this is the grid line. But I would like to make it a hidden grid line because this grid line will not appear at the foundation level. Yes, it will not appear at the foundation level. So I would like to make it a hidden grid line. So I'll click on it. I'll click on what? Property. I'll click on property. Then I'll turn all these things off. And click on hidden axis and then click on what? Update. Yes, it will not appear at the foundation level because there is no wall here. So it will not appear at the foundation level. So at this point, I'll then come back and double click on one of my beams. Then I'll now insert a beam at this from here to what? Here. Hope you're understanding everything. So at this point, let's go over to our 3D view to see what we have achieved so far. So I'll click on this, click on it, then click on 3D physical model. So let's see what we have achieved so far. Let's see what we have achieved so far. So this is what we have achieved so far. This is what we have achieved so far. Then let's continue. Okay, what I would like to explain now is the concept of hinging. The concept of hinging of a beams. Please listen and understand everything. Listen and understand what I want to explain now. Remember, the moment. Okay, remember, if we were to draw the bending moment diagram of this beam now, it will go from starting from this point. It will come over here. We're having a sagging moment. It will go up. We're having a hugging moment. It will come down. We're having a sagging moment, and it come and terminate at this point. That means this point is what? Zero. That means what it means that the moment at this point is zero, and the moment at this point is what? Zero. But ProtaStructure will not take the moment at this point to be zero, unless you tell it that the moment at this point is zero. So for that reason, we have to tell ProtaStructure that the moment at this point is zero, and the moment at this point is also zero. So that is why we do hinge our members. Yes, let me tell you one thing now. If you don't hinge your members, remember, the aim of every structural engineers is first of all safety. After safety is economy. If you do not hinge your member, ProtaStructure will design it that ProtaStructure will see it that there is a moment acting at this point, and if there is a moment acting at this point, it will design against that moment. That means ProtaStructure will provide a very high reinforcement at this point, because it will think that there is a moment at this point, and also there is a moment at this point. So to prevent ProtaStructure from having very high moment, to prevent ProtaStructure from inputting, like to designing against moment at this point, you have to hinge this member. Because if you don't hinge it, you might be having something like 3y16 instead of 2y16, or something like 4y16 instead of 2y16. Yes, because ProtaStructure will see that there is a moment at this point. So for that reason, we are going to hinge our members. Another reason why you should hinge our members, let me tell you another reason. If you can remember, in your university days, we have it that the summation of moment at any point is equal to zero. If you can remember, what it means is that the summation of moment at this point is zero. I did not say that the moment here is zero. I said the summation. Also, the summation of moment here is zero, and also the summation of moment here is zero. So what it means that in this case, assuming I'm having 30 here, for example, in this case, we're having two moments. We're having a moment in this direction and also a moment in this direction. That's if you can remember. But if you want to learn more of this, get that 10-day structural design and detailing masterclass. Yeah, because all these things were detailed in that course. So don't forget, there is a moment acting at this point, and also there is also a moment acting at this point. Then the summation of moment is zero. That means if this one is positive 30, this one will be negative 30. Then if you sum both of them, it will give you zero. That means the moment at this point is zero. Yeah, that is the rule. The rule is that the moment at all points is equal. The summation of moment, not the moment. The summation of moment at all points is equal to zero. That means if you sum the moment here and sum the moment here, it will give you zero. So at this point, if you are having 30 here, that means we'll be having negative 30. So if you do 30 plus negative 30, you'll be getting zero. So in this case, the summation of moments is equal to zero. There is only one moment here because there is no beam here. So there is no moment at this extreme. There is only one moment here. That means the summation of the moment at this side plus the moment at this side will give us zero. Since there is no moment at this side, what it means automatically is that the moment at this point is equal to what? Zero. I hope I'm able to explain that this beam, that there's no moment at this point, because first of all, the summation of moment at all points, I say summation, not moment at all points. I say the summation of a moment at all points is equal to zero. And if you sum the moment here and the moment here, you'll be getting zero. If you sum the moment here and if you sum the moment at this point and the moment at this point, you'll be getting zero. But the moment here, you can assume it to be 30. Why here will be negative 30? If you sum both of them, you'll be getting zero. Why at this point? There is no moment. There is no moment at this point. So that means it's only one moment. Therefore, that one moment will be what? Equal to what? Zero. So with all this, we'll be hinging our members to tell ProtaStructure that there is no moment at this point, and also there is no moment at this point. And also in terms of simply supported beam, this is a simply supported beam. There is no moment at this point, and also there is no moment at this point. Yes, for continuous beam, let's see. Okay, for continuous beam, there is no moment at this point. There is no moment at this point, but there is a moment at this point. That's why the bending moment diagram will go like this. Sagging moment, you will have a hugging moment at this point, showing that there is a moment at this point. We also have a sagging moment, then it will not terminate at zero. So that now we're going to hinge all our members. But first, before I start hinging all my members, I would like to first of all hinge all the simply supported members. Please listen, so you see how I will do this thing fast, so you don't waste your time on this. So you first of all select all the simply supported beams. So this is a simply supported beam. This is a simply supported beam. Hold your control key and select them. Hold your control key. Also, this is a simply supported beam. This is a simply supported beam. Let's select. Okay, this is not a simply supported beam. This is not a simply supported beam because we're having the cantilever here, and two, this is not a simply supported beam, this is not a simply supported beam, and this is not a simply supported beam because we are having a cantilever here. Then let's come over to the vertical. This is not a simply supported beam, 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 this is not also a simply supported beam. Why this is a simply supported beam? This is not a simply supported beam. So right now, let's hinge all our simply supported beam. You right click. Once you right click, you click on this update beam end condition. Once you click on it, you come and click on both ends hinge. That means you want to hinge both ends because they are all simply supported. You want to hinge both ends. So I'll click on this both end hinge. Then you click on apply to the selected beam. So you have hinged all the beam. How will you know that you have hinged it? Look at this red dot. This red dot shows that you have hinged these beams. It shows that you have hinged this beam. So next one, I would like to hinge all my okay. If you bring your cursor to this beam now, you see that one end is I and the other end is what? J. So I would like to hinge all my I end that are to be hinged. I would like to hinge all my I end that are to be hinged. Remember, this is a continuous beam, but the moment at this point is what? 0. So, but first, I want to hinge all my I ends. So look at my cursor. My cursor is on this beam now. This end is I. Why this end is J? So I want to hinge my I ends. Why? You know that the moment at this point will be what? 0 because this is the I end. So I'll select the I end. I want to hinge all the I ends that are 0. So I'll hold my control key. Let me check again. Oh, sorry, this is a simply supported beam and two with no hinge it. Yeah, let me just hinge it immediately. This is a simply supported beam and with no hinges. So let me hinge it immediately. So both end hinge and apply to the selected beam. So we have hinged it. So let me continue again. I want to hinge all my IN. I'll hold my control key. So this is a simply supported beam. We are not going to select it again, even though the IN should be hinged. But since we have selected it initially, we are not going to select it again. So this is a simply supported beam. Okay, this is a continuous beam. And two, this is my IN. Yeah, this is my IN. This is my IN. So I'll hold my control key and still select it because here should be what? 0. Then this point to here should be 0. Here should be 0. Yeah, this point should be 0. Yeah, this one again. This point should be 0. Hold your control key and select this point. This point should be 0. Please hold your control. Hey, I had my shift key, not control key. Sorry, I made a mistake. So I was read this. I should have hold my control key. Hold your control key, not your shift key. Hold your control key and select. So I will say select this. Yeah, I think we have selected all the horizontal ones. Let's shake again. Let's shake again. Let's shake again. Yes, we have selected all the horizontal ones. Then we'll come over to the vertical. So this is the I end. So I'll hold my control key. This is the I end. This is the I end. Look at it. Then also this one. This is the I end. I'll select this one. While the top are the J ends. So in this case, this is also the I end. This is the I end. I'll select this. And two, this is the I end. I'll select this. This is the okay. Yeah, this is the I end. I'll select this. Yeah, I'll select this because this is not a cantilever. This is not a cantilever. Look at the cantilever here. This one is the cantilever. Why this is not a cantilever? This one is resting on the cantilever. It is not a cantilever. Yeah, if you want to learn more of this, get my paid course. Yes, get that paid course. I'll advise you to get it. So I'll also select this. This one is not a cantilever. I think we have selected all the I ends. Yeah, we have selected all the I ends. So I will click again. I'll come over to this update beam end condition. I'll click on this hinge at left end. That's at the I end. I'll click on apply to all members. Then I'll escape. If you see they have all been hinged. Look at this one. It has been hinged. It has been hinged. Then the next one is to hinge my J members. Then I want to hinge my J members. So here, this is my J members. This is my J member. It will be 0. I will like to I will not hinge J because there's a cantilever here. There's a cantilever here. Please don't hinge your cantilever because cantilever will definitely have a top moment. It will definitely have a top moment. Yes, if you want to learn more about the top moments, get the paid course. Because it is being explained because the top will be at the tension. Yeah, the top will be at the tension. While the bottom will be at compression. While for a normal beam, the bottom will be at tension. While the top will be at compression. They do interchange. For cantilever, the top is at the tension. Don't worry, we'll still get to explain when we get to interactive design. But if you want to do no more of this, you can still get the paid course. Then I'll still hold my control key. This is my JN. Then this is this is a simply supported. This is a simply supported. Okay, this is a JN. I'll hold my control key and select it. This is a JN. I'll hold my control key and select it. And then this is a JN. But I will not select here because this is a cantilever. Please don't select a cantilever. Then I'll come over to the vertical members. So this is my JN. I'll select it. This is my JN. And also this is my JN. I'll select it. This is also my JN. I'll select it. Yes, let's shake. Yeah, okay, this is also my J and I'll select it. Then I'm having that this is my J and I'll still select it. This is a simply supported beam, so I'll not select it. This is my J and I'll select it. Yeah. Yes, I think we are through. Then I'll right click. Once I right click, I'll go scroll down, go to update the beam end condition, then hinge all my J end, then apply to the selected beam. So I'll escape. So right now we have hinged all our members. So the next step now is to insert our slab. Yeah, that's the next step, to insert our slab. So to insert your slab, you click on this insert slab. So look at it, say load cases must be defined before load assignment. Would you like to define load case now? I'll click on yes. I'll like to define my load case. Then I'll just come over to this point and click on my load generator. So if you see, we have vertical load combinations. So leave these things as default. These things are being gotten from the code. Look at it, 1.25, 1.5, all of them are being gotten from the code. Just leave it at default. Then come over to the horizontal load combination. Then remember, if okay, for wind load, if the height of your building is above 10 meters, you apply wind load. If the height of your building is above what, 10 meters, you apply wind load. So our own building, the height is not up to 10 meters, so we are not going to apply a wind load because the height is not up to 10 meters. But if the height of your building is up to 10 meters, you apply wind load. Then leave it, or if you're not applying anything, just leave everything at default. Then come over and click on OK. So this is my load combination. Then I'll come and click on what, OK. Then this will apply, this will appear. So please, the slab thickness that we'll be using here is what, 150. There's a slab thickness of what, 150, and the slab tap is what, slab tap what, 1, because look at it, slab tap 1, because we have four boundary. We have you have four boundary conditions around the four boundary condition. That's this beam, and this beam. Look at it. This, sorry, let's go over to type 1. This type 1, it has four boundary condition. This. Like it has beam surrounding it at all around. So this is the relative level. Please leave relative level at 0 is when it comes to raft foundation. Yes, the beam raft foundation that we'll be using relative level, or in some special cases that we'll use relative level. Then concrete cover, we'll be using a concrete cover of what, 25. Then we'll come over to loadings. Then coming over to loadings, this self weight has already been calculated by the software. How do you get self weight? Self weight is gotten by unit weight of concrete times the depth of your slab. Yeah, so it has been calculated automatically by the software. Then the dead load. Which dead load do you want to use? So dead load comprises of two things, which is first the partition load, and second the finishing load. The partition and the what, finishing load. But partition load ranges from 0.5 to 1. That's partition load. It ranges from 0.5 to what, 1. While finishing load ranges from 1 to 1.5. Yeah, it ranges from 1 to 1.5. But in this case, I would like to select my partition load to be 0.5 and my finishing load to be 1. So if you now do 1 plus 0.5, I'll be having what, 1.5. So I like to be using 1.5. So this is what I would like to use as my dead road. I hope you understand. Then the imposed road. This is a residential building. Yeah, this is a residential building. So I'll click on this. Right click on it. Once I right click on it, I'll click on general domestic use. General domestic use, because this is a residential building. Then the roof load. This is not a roof slab. This is not a roof slab. So I will not apply any roof. I'll not apply any roof load on it. Snow load. There's no snow on this road, on this slab. Snow. This is not exposed to weather. So the snow will not be coming. It won't be coming in contact with any snow. So I will ignore it. Why this rain load? It's not an exposed slab. So it won't be coming in contact with what? Rain. So I will leave it as default. So I'll click here to insert my slab. I'll also click here to insert my slab. I'll click here to insert my slab. Click here to insert. Click here. Click here, and then okay, remember there's no slab here. Here is a void, but we have a cantilever here. But don't worry, we are still coming to model our cantilever. So at this point, I'll then click on what? I'll click on close. So let's come over to our 3D view to see what we have done so far. So this is what we have achieved so far in 3D view. Yeah, in our modeling. So this is what we have achieved so far. So right now, the next thing that we'll be doing is that I want to insert my story. Yeah, after inserting my story, then I will now come and model this. I will now come and model this cantilevers. Yeah, let's come to ProtaStructure. Let's come to AutoCAD so you see it very well. So look at the architectural plan. After inserting my story, I will then come and model this cantilevers. Yeah, after inserting my story. After inserting my story, I'll come and model this cantilevers. Then I'll come back to my ProtaStructure. Then what we want to do is to insert story. Do you want to master structural design and detailing in just 10 days? I created a course where I carried out the full structural design of this residential building from start to finish. In this 10-day structural design masterclass of this residential building, we carried out the structural framing, modeling, analysis, and design every structural members. We analyze the forces acting on them and design reinforcement to counter those forces. From there, we move into foundation detailing, part-based detailing, column detailing, slab detailing, even staircase detailing. We also section and detail our staircase and slab. And finally, I showed how to print and present your drawing professionally. This course is highly in-depth because I poured out my knowledge about structural design into it. Honestly, it's more in-depth than all the free structural design videos on YouTube. And think about it, if my free lessons here on YouTube are already this good, just imagine my paid courses. This is all you need to become a confident, competent structural engineer. It is an investment you will never regret in this life because remember, the greatest investment with the highest return is the one you make on yourself. And the good thing is this course is highly affordable because I consider the fact that most of you are still students. The link to this course is in this video description. It is the first link you will see. Go and enjoy every bit of the lesson. Do you want to master structural design in 10 days? This course will get you there. In inserting story, I'll come and click on building setup. Once you click on this building setup, you come over to, come to story, then click on this story option, then click on insert story. Once you click on insert story, look at this story 1. Yeah, I want to, how many, what is numbers of story? So I'll click on what? 2. Yeah, 2. Yeah, I want to just insert only the second story. I don't want to include the third story. Then insert story height. Insert story height. The story height, I would like to, our story height from the architectural plan is 3 meters. So I'll still leave this at default. Then look at, you click on generate member from the selected story. The selected story is this story 1 that we are currently at, the story 1. So I'll click on generate member from the selected story. Then I'll click on what? Okay. So and then I say this and this and the previous process will not be undone. I'll just leave it. Click on what? Yes. So let's allow it to generate our member. So it has generated. Let's convert to 3D view. If you can see now, we now have 2 stories. Yes. So at this point, so we are not at story 2. We are not at story 2, but we want to model those cantilevers as story 2. We want to model those cantilevers as story 2, but our plan is not showing. Our plan is not showing as story 2. So what we'll do now for our plan to start showing is that we'll come over to this external reference drawing. That's building setup. Come over to this external reference drawing. Then click on this number of story. I'll come and change this thing to 2 and then click on what? Okay. Yeah, if you see that our plan is not showing, and we are still in story 2. So right now, the reason why I made this is so that I'll be able to model this. So before we can model those cantilevers, before we can model those slab, we can just model the slab at its own. Because they are the cantilever slab. They can easily be modeled. We don't need to insert a new grid line. But don't forget, we'll be inserting beams and columns. Like we're having a column at this point. Let's go over to ProtaStructure. Let's go over to AutoCAD so you understand. Look at our modeling. We have that a column will not be at this extreme, and also a column at this extreme, and also a column at this extreme. Yes. So let's come over to ProtaStructure. Before you be able to insert a column at this extreme, you must have a grid line at this extreme. Before you be able to insert a column at this extreme, there must be a grid line. So for that reason, we'll be inserting our grid lines. Yes, I want to insert my whole grid line, because if I don't have a grid line here, I'll not be able to insert a column here, and also I'll not be able to insert a beam at this point. If I don't have a grid line at this point, I'll not be able to insert a column at this point. So for that reason, I'll be inserting all my grid line. So what I'll just do is that I'll escape. Then I'll click on this. Then I'll click on what? I'll click on offset axis. Once I click on offset axis, I'll just come and place it at this point. Yes, the reason why I brought out this line in AutoCAD is that so I can easily place this thing, because as this line was not here, that means I have to come and start offsetting the distance. I have to come and start offsetting the distance. But for the fact I brought out this line now, I don't need to offset the distance again. So I'll just place it at this point. Yes, please, if you have not gotten the CAD file of this architectural plan that we are using, please get it so that you practice. If you watch 100 videos without practicing anyone, the person that watches 10 and practice those 10 that he watches will be far better than you. So practice, because practice what makes what perfect. So for that reason, get the CAD file and practice. So I'll escape. Since this is not a major grid line, I'll convert it to a ghost axis. So I'll click on what? Property. I'll click on property. I'll turn off this, and convert it to a hidden axis. I'll then click on update. So right now, this is not a hidden axis. If you can see, it's no longer that visible because it is not a hidden axis. Then I'll still copy this. I'll still copy this. Then click on offset. I'll click on offset axis, then I'll place it at this point. Look at this point. These are cantilever. These are cantilever point. Yeah, these are cantilever points. So I'll place it at this point. I will still escape again. Like click on what property, and then turn off this, turn off this, turn off this. Then click on this hidden axis. I'll click on what update. Yes, I'll click on update. So if you don't look at it, it's no longer there. Then I'll click on this one again. Like click again, click on offset axis. Then I'll come and place it at this point. Yes, as I place it at this point, I escape. Okay, sorry, I did not place it. I did not get it. I'll like click on offset axis. I'll place it at this point. I'll place it at this point. I will escape. I will escape. Yeah, I'll now double click on it to bring out this property. I'll turn off this. Then click on hidden axis and then click on update. So look at it. It's gone. And then the next one. Okay, the next one. Okay. I want to do for this one. So I'll click on this, right click on it, click on what offset axis. Then I'll place a grid line at this point. I'll escape, right click on property. Then I'll turn off this, turn off this, turn off this. Then click on hidden axis. I'll then click on what update. So look at it. It's not a hidden axis. Then I think yeah, our next one, the next one will be this one. Then I'll come and copy this vertical axis. Right click on it, click on offset axis. I'll place it at this point. Yes, I'll escape, right click on property. I want to convert it to a hidden axis because this is not a major axis. I'll click on what update. So it's not a hidden axis. So look at it. Look at this is the axis and this is the axis. Yeah, these two are the axis. These two now, these two now are the axis. These two now they are the axis of our cantilever slab. Then I'll escape again. Escape again. Don't worry, doing our modeling, we'll remember all of them. We'll remember all of them. We'll remember all of them. Then at this point, I'll also come and copy this axis. Right click on it. Okay, let me leave this one. Let me leave this one so I'll not get confused. During the time when I want to place my column, I'll come and place this grid line. Yeah, in fact, let me stop it because I might get confused right along. So let me just stop at this point so I'll not get confused. Let me just stop at this point so I'll not get confused. So right now, what we are going to be doing now is that remember some of our columns will be terminate. Let's come over to AutoCAD. This okay. Let's do for this side first. This column now will terminate and we'll be having a new column at this extreme. This column will terminate and we'll be having a new column at this extreme. So let's come over to ProtaStructure. Then remember this column will go as 32. I'll click on it, right click, and then click on property. Then I'll click on it, right click, then click on delete. I'll delete it because we say that this column will go. Then I'll come and double click on this to bring the artist property. And then I place a column at this point because we say that a new column will start emerging from here. Then I'll come and click on this and select this and then click on update property. So it is not like this. Yeah, so this column will go. Then if this column now should go now, remember our beam will now run like this. We will now have a beam from here. Yes, a beam from here. Okay, let's see what we have done in ProtaStructure so you will see. So in 3D view, so this is what we're having now. So this beam now and this beam, they will go. Just follow me. Just follow me. I will escape. I'll click on this beam, hold my shift key again, and still click on this. Okay, sorry, I'll hold my control key, not shift key. Like click on what? Delete. I'll click on delete. I'll click on what? Okay. Then I'll come over to this beam. Okay, no, I don't want to. Let me use a new beam. Where is my modeling? I'll come over to modeling beam. If I pick the properties of this beam now, you remember I've hinged them, so everything will change. So that's why I want to use a new beam. 225 by 450. I'm okay with it. So a new beam will move from this point to this point. Remember, look at it. This is not how it should be. It should be in alignment with this column. So I'll come and click on this. Click on one of these. Let me click on this one first, and then click on update. I'll click on update. So it's fits in now. It now fits in. Have you seen it? It now fits in with this column edge and with our grid line. Look, this is our grid line. It now fits in. Then I'll come over again and drop this one. Remember, the next point is this point. I'll drop it at this point. Look at it. It's still fitting. Then I'll still drop it at this point. Yeah, I'll still drop it at this point. Remember, this shorter one should be the cantilever one because it's the shorter one. Then this one now. Then this one now, I'll double click on it. Once I double click on it, I'll come and click on this. I'll click on this property. And then click on update. Yeah, it now fits in. I want it to be in alignment with our axis because these are hidden axis. So I want it to be in alignment. But if you can see, they are trying to hinge everything. They are trying to hinge all the beams. So I'll select this. I'll hold my control key, I'll escape. I'll select this, hold my control key, select this, and also select this. Then I click on. I don't want them to hinge all of them. Okay. let me say unhinge, let it unhinge everything. Update beam end condition, no hinge for now, no hinge for now. Yeah, so I want to hinge it now. So in this case, this is a simply supported beam, so it will be hinged at this point and also hinged at this point. And two, this is a simply supported beam, it will be hinged at this, it will be hinged at this point and also at this what point, it will be hinged at both points. So I'll click on this and then hold my control key, click on this, then like click on what, update beam end condition, both end hinge, apply to the selected beam. So it's okay now. This is a cantilever, there should be no hinge here, this is a cantilever. So I'll click on it, I'll right click again, click on the update beam end condition, update beam end condition. I'll click on no hinge, I'll click on apply to the selected beam. So right now there is no hinge. This hinge now is for this beam. This hinge now is for this beam. Is for this beam. Yeah. So I'm okay with this. So I've gotten. Let's come over to our 3D view. So this is what we're having right now. This is what we're having right now. Then this column now will now rest on that cantilever slab. We'll still moderate. We are still going to moderate. Just follow me. Just follow me. So we have done this part. Then let's come over to this part. Let's come over to our architectural plan. Architectural plan. So we are through. We are done. We have done this. We have removed this column and we have placed this column and we have inputted this beam and we have inputted this beam. Then coming over to this cantilever slab, this beam, okay, this column, and this column, they are going, these three columns. Then I'll come over to my ProtaStructure. I'm having that this column, I'll hold my control key, this column, and then this column. Three of them, they are going. So I'll right click, then I'll click on what? Delete. I'll click on delete. Okay, they are going. Then the next part is that we'll be introducing, okay, we'll be introducing a beam. But first, let me insert this grid line. Okay, look at it, it stopped here. But first, let me make this thing a grid line because we will not be able to insert any beam or column at this point if you are not having a grid line at this point. If you are not having a grid line at this point. So, but first, remember, this grid line now is after grid line 8. It is not before, it is after grid line 8. So we'll not get confused. I'll right click, then click on what? Offset axis. I'll place it at this point. Remember, it is after grid line 8. Then I'll right click again, click on what? Properties. Click on properties. I'll turn everything off and then convert it to a hidden axis because it is not a major axis. So it is after grid line 8. Then okay, let's go and check the points of our new column. Let's go and check the points where we're having a new column. So we're having a new column at this extreme, then above this column, above in alignment with this column, and then at this point. But first, let me insert this and then insert this first. So and to this now, this column now is grid line what? This column now is the grid line after our staircase. Then I'll come over to my ProtaStructure, then I will double click on one of the columns. We're having a column at this point. Yeah, this is the point. Then I'll come and click on this to change the properties of this column because I want it to fit, I want it to be in alignment with this grid line. So which of them will make it to be in alignment with this grid line? So this is the property, and then click on what? Update. So now it's not in alignment with the grid line. Then I have another column at this point again. Yeah, so I want it to be at the center. I want to position this column correctly. Now I'll come over again. I'll select this property. Yeah, this is the perfect property, and click on what? Update. So it's not correct. Then the next one, where else are we having our grid line? Let's go and check the grid line. Let's go and check where else are we having our next column. Then I'll come over to my AutoCAD. My next column, okay, sorry, my next column is being placed at this point. Let's check whether we're having any grid line at that point. So what I'll do now to check whether I'm having any grid line at that point, I'll just copy this whole grid line. I want to check whether I'm having any grid line at that point. I'll do CO, enter. I'll do CO, enter. Then I'll copy from this staircase position. Remember, staircase will forever remain the same. So I'll place it here. So okay, you're having a grid line at that position. That's the grid line. The grid line after this. The grid line after this offset. The grid line. Yeah, the next grid line. That's the place we'll be placing our column. Then I'll come over to this. I'll come over to my ProtaStructure. That means this is the grid line. That means I'll be having a column at this point. This is the point. Yeah, this is that grid line. Look at it. Remember, we said it's after grid line 8. So we'll be having a column at this point. Yes, but this column now is not in alignment. Let's position it very well. So we'll come over to this one. Which one will be the perfect position? Is this one. This is the perfect position. So I'll click on it and then click on what? Update. Yes, so this is the perfect position. These are grid line and these are grid line. So it's at the center of both of them. So this is perfect position. So we have inserted the three columns. So the three columns that we need. That means we'll also be inserting a new grid lines. So a new beam. So I'll hold my control key, select all these beams because I don't need them again. I don't need them at this story too. I don't need them, and also I don't need them. Then I'll right click. Once I right click, Once I right click, I'll click on what? Delete. And then click on what? Remember, make sure it's only beam that is selected. I'll click on what? Okay. So everything here has been deleted. Everything has been deleted. Now is to insert a new beam. Is to insert a new beam. So I would not like to double click on this, because if I double click on this, it will bring out this property. Then I'll come and click on this beam. Once I click on this beam, I'll click on normal beam. Once I click on normal beam, 400 by 450, 400 by 450. Then I'll come over to this point. I'll pick from here, a beam from here to here. I'm having a beam from here to here. This hinge is still appearing. This hinge is still appearing. No problem. Let's just continue. Then I'll come and select the perfect property. Let's shake out this property first and then click on update. Okay, it's going out. It's going out. As you see, it is going out. That means we want it to come inside, so it will be in alignment with this grid line. So that means this is the perfect condition. I'll click on update. So look at what we're having now. Is okay with we are okay with it. Then I'll stop. Remember, don't stop at this point. Stop at the end of your grid line. Don't stop at this one. Stop at the end of your grid line. So I'll be stopping at this point. Then next one is that I'll stop at this point. I'll stop at this point. I'll stop. Okay. I'll stop at this. I'll stop at this point, but this is not the perfect property. This is not perfect property. So I'll like click again, update this, click on update. Sorry, okay, that means it will be this. I'll click on what? Update. Yeah, so this is that in alignment. So this is what we're having right now. Remember, we're having a cantilever beam pulling out from this point. We should have a cantilever beam pulling out from this point. So I'll click on this, and then I'll click on this to this point. Yes, if you see that it's pulling up, but it should be at the center. So we'll come and check what is the perfect beam end condition. This one should be the perfect. I'll click on it, then click on what? Update. Look at it, it's not perfect. Then the next one is that it will not terminate at this point. It terminate at this point. So this is not the perfect. This is not the perfect. Then I'll come and click on this and check, is this one the perfect bending? This one the perfect condition. I'll click on update. Update is going out. Is going out. So I'll come and click on this. Click on what? Update. So hope you understand. Hope you understand it. So this is how it should look like now. So this is how it should look like now. So I'll escape. I'll come and deselect all these things, because not they're making everywhere. They are hinging all the beams. They are hinging all the beams, but not all of them should be hinged. Not all of them should be hinged. So I'll click on all of them. Like click on what? No hinge. I'll click on no hinge. I want to hinge it properly. I want to hinge it properly now. I want to hinge it properly now. Don't forget, if you want to learn more of this, get the paid course. Get the paid course. Everything is where it's printed in that paid course. Get the paid course and learn. Get the paid course. Then I'll come here and hinge on, because in the paid course I calm down and I explain everything. This is a YouTube video, so I'm trying to make sure that this video is not renting. So that's why I'm cutting most of the things. But in that paid course, since I know that you paid it with since I know you paid with your money, I calm down and I explain everything. So at this point, I'm having this point now should be hinged. That means I want to hinge only my IN. I want to hinge only my IN. So I'll click on this. This IN should be hinged. This one is JN. So this one now, this is still JN. I want to hinge only my IN. Oh, I'll then hinge this IN. I'll hinge this IN. I want to hinge only my IN. I'll not be able to hinge this IN because this is continuous. So I'll just like click on what? Update and beam end condition. Then hinge IN. I'll take hinge IN. I'll click on apply to selected beam. The next one, I want to hinge my JN. I want to hinge my JN. So this JN now will not have any hinge because it is continuous at this point. That means the moment here is not zero. But here now I will hinge it. I'll click on it, then select it. Then this is still this is my IN. This is my IN. Why this is my JN? But please don't forget, this is the cantilever. Yeah, okay. They don't even put for us the cantilever sign. But don't worry, I'll still input the cantilever sign. But this is a cantilever. I'll still come and explain it. Then we're having only one JN being hinged. So I'll right click again. Click on update beam end condition, then JN hinge it. I'll click on apply to selected beam. Yes, so if you can see, they did not put that cantilever sign here. That means if ProtaStructure design this thing now, it will not design it as a cantilever. That is why we are hinging our members, because if ProtaStructure design this beam now, it will not design it as a hinge beam. It will not design it as a hinged beam. So that's why we are hinging it. Also, in this case now, you are not seeing any cantilever sign here. That's the this sign now. This sign now, you are not seeing it. This sign now, you are not seeing it at this point. You are not seeing it at this point. That means if ProtaStructure design this beam now, it will not design it as a cantilever beam. So we have to input, you have to tell ProtaStructure that this beam is a cantilever. That's why we are also telling ProtaStructure that we are to hinge here, we are to hinge here to minimize moments, because if you not hinge it, it will design it as if there is a moment there. That means it will provide more reinforcement. Instead of it to be having 2Y system, we are having 3Y system. Knowing fully well that the goal of every structural engineer is to save cost. So you must hinge your member. Also in this case, if you do not tell ProtaStructure that here is a cantilever, ProtaStructure, remember, a cantilever will be having a top reinforcement. Yeah, it will have a very high, it will have a top reinforcement. That means ProtaStructure will not design to provide a top reinforcement for this beam if you do not hinge it. But right now, let's hinge it. We'll click on it. Then like, remember, we are hinging the J end, sorry, the I end or any. So let's hinge it right now. So hinging, I will right click on it, then click on, look at it, mark free end of cantilever, mark free end of cantilever. So we want to mark the JN, we'll just mark it JN. Look at it, I just see JN. This cantilever sign have appeared here now. So if ProtaStructure want to design this beam, it will design it as what? A cantilever. So please take note, all these things I'm saying here, they are all very, very important. But if you still want to learn more, get the paid course. If you want to learn more, get the paid course. Then automatically this slab will go, and also this slab will go. We'll right click, then click on delete. We'll delete the slab. Yeah, we'll delete the slab. So right now we have gotten this. Let's go over to our 3D view to see what we have achieved so far. So this is what we have achieved so far. But don't worry, once we input our bottom cantilever now, this will now look very good in your eyes. It will now look perfect in your eyes. So let's take continue. Let's take continue. So let's come over to this. Okay, we are at this point now. This is 32. Okay, let's go over to AutoCAD. Let's just see what we have done so far in AutoCAD. So if you look now, this is the back view, this is the back view, this is the back view. We're able to bring out this back view. We are now able to bring out all this cantilever. If you are seeing it, we have pulled out all this cantilever, and also we have been able to pull out. We have been able to pull out this cantilever too. So this is what we have achieved so far. This cantilever, we have been able to pull it out. Yeah. Then let's pull out this cantilever. This cantilever now, let's bring it out. This cantilever, let's bring it out. Remember, we'll be bringing out this beam. Right now, what we are bringing out is these beam positions. So let's bring them out for this section, for this front elevation. So let's come over to ProtaStructure again. Then that is, we want to work on this side, on this front view. We want to work on this front view. Then what we'll be doing now, let's go and check the places where the columns will terminate and where we're having new columns. So we'll come over. That's why I say you should watch the structural framing of this video. Yeah, so you understand all these things. So look at this point. We have that this column will terminate and we'll have a new column at this point. Yeah, this column will still be intact. But it will project a beam outward. Yeah, so these are the two things that we're having right now. So let's go and delete this column and insert a new column. So I'll come back to this point. I'll click on this. So this is the column that we go, and we'll be having a new column at this point. But before we can insert a column at this point, that means we should have a grid line here. I've said this over and over again. So I'll click on this. I click on the offset axis. I'll click on offset axis. Then I'll come over to this point and place a grid line at this point. I'll escape. I click on what property. Then I'll turn off this, turn them off. Then check this hidden axis. I'll click on update. So I'm having a grid line at this point right now. Then what I'll do now is I'll double click on this. Once I double click on it, I'll come and place a column at this point. Once I place a column at this point, I'll come and change the properties. This is the perfect property. Then I'll click on update. So this is what I'm having right now. I'm okay with it. Next thing now is to insert my beams. Yeah, to insert my beam. Remember, a beam will run out from here. If you can remember, this is the hidden beam. This is the hidden axis that we inserted. So a beam will be projected outward. So right now, what I'll do is that I'll double click on it, knowing fully well that after we'll come and change the hinges. So we'll have a beam from this point to okay, our grid line, look at our grid line from this point to this point. Yes, this is the perfect condition. If you go and shake, you see, okay, let's shake so you see it. Let's shake our AutoCAD so you see that is the perfect condition. Look at it. The beam is moving straight with the wall. So this is the perfect condition. So I'll come over again to ProtaStructure. This is the beam that we're having right now. Then we'll be having this beam now. This beam now from this point, it will now rest on this what? It will not rest on this column. But don't forget, it should be in alignment with this grid line. So I'll click on this, select this, and then click on update. So it's not in alignment with this grid line. Hope you understand it. It's not in alignment with this grid line. If you go over to our 3D view, see what we have achieved so far. This is what we have achieved so far. Then the next thing, I'll come over to plan view. Then the next thing now is this area. Let's go to our architectural plan and see how it is. Let's come over to our architectural plan. So we are seeing how it is. That means at this point, we'll be having a beam projecting outward. Here. Then another beam will now will not be having another beam at this point. That means this beam now will now rest on this column and on this cantilever beam. Hope you're understanding. This new beam now will now rest on this column and on this cantilever beam. So let's go over to ProtaStructure and do it. So we're having a beam projecting outward. So I'll double click on this. We're having a beam projecting outward to this point. Yes. Then we'll now have a new beam now. Remember, this now is a cantilever beam. So the cantilever sign is there. Let's check this one. Okay, the cantilever sign is there. So we are good to go. Then we'll now have a new beam from this point now to this extreme point. But it is not in alignment. It should be in alignment with the edge of this column. It should be in alignment with the edge of this column. It should be in alignment with the grid line. This is the grid line. I've been seeing the grid line. So it should be in alignment with the grid line. So I'll click on this. Then the perfect property, I think it should be this. I'll then click on update. Yeah, this is it. So this is what I'm having right now. So we are good to go. I'll escape. I'll delete. I'll click on this to delete it because we don't need it again. And then hold my control key again. And then also hold my control key for this slab because we don't need this slab again. I'll right click on what delete. then beam and slab. That's what we selected. I'll click on OK. So everything has been deleted. So let's go over to our 3D view and see what we have done so far. So this is what we have done so far. So right now, let's come over to our plan view. So let me come over to this and see what we still need to do. So I'm going to come over to our architectural plan. So to see what we still need to do. So look at it. We should be having another. Okay, wait. Let me shake our 3D view. okay. Our 3D view says that we should be having another beam projecting upward. Yeah. We should have another beam. Like that's this. We shall have a new beam projecting outward. That's this. So let's come and tackle it now. A new beam projecting outward. Let's come and tackle it now. Then at this point, I'll come over to my ProtaStructure. That means this beam now should extend to this point. Why another beam will now project from here to this point. Hope you are understanding. This beam now should extend to this point. Why another beam will now project from this point. But since we are not having any grid line at this point and also at this point, we need to insert a new grid line for us to be able to insert our column and our beam. I've seen it before. Then I'll click on what? Property. I'll click on what? Sorry, not property. Offset axis. I'll click on offset axis. I click on what? Offset axis. I'll place one axis at this point. I'll then click on what? Property. I'll click on property. I'll convert it to a hidden axis. I'll click on what? Update. Yes. So we are having an axis here now. So this one now we can ignore it because we will just extend this beam to this point. So we can ignore it. So you can stretch this beam or you can delete it and start from beginning. So but let me just delete it because most of us might not really understand the concept of stretching a beam. So I'll just double click on this to bring up this property. Then from this point to that new beam we list on our new grid axis. This grid. Say okay, look at it. Let's read this thing so you understand what this thing means. He said that new beam crossing over another. New beam. That's why I say you should get the paid course. Get the paid course because all these things are well detailed in that paid course. Look at it now. It said new beam crossing over another. Do you want to split the new beam at the supporting span? They are asking us, do you want to split the new beam? I will say no. I don't want to split it, and I will explain to you so you understand. I will say no. So I'm having okay. Look at what does that thing mean? Get the paid course. Get the paid course so that you understand all this thing. It's very cheap. So what does that mean now? It means that new beam is crossing over another. What it means that they are trying to tell us that they want to split the beam, like they want to split this beam at this point. That means we're having one beam from here to here and another beam from here to here. They want to split the beam. That's what they are trying to tell us. But we tell them no, please don't split the beam, because if they split the beam, that means because our intention is that this beam now should be resting on this beam. That means if they split the beam, that means what you're having is that you're having a beam from here to here and then a beam from here to here. That means this beam now will not be resting only on the beam from here to here. Why this one now will be resting back on this? Like it's not really structurally inclined or understandable. Like I don't know how to explain, but what it means that they are trying to break the beam, but we told them no, please don't break it. We want this thing to be a straight beam. Why this one will not rest on that beam? Yeah, get the paid course and understand all these things more. So I'll click from here to here. Remember, it should be in alignment with this axis. It should be in alignment with the axis. So I'll click on this. Click on what? Update. So it's going out. That means it will be this condition. I'll click on update. So this is the perfect condition. So this is what we're having right now. Then I'll click on escape. Hope you understand. Please, new beam crossing over another. We don't want to split the beam, but there are some situations where we split the beam. That's why I say you should get the paid course. There are some situations where we have to split the beam, but in this case, there is no need of splitting the beam because we want this long beam. We want this long beam to rest on it, so we don't need to split it. Yeah. So right now, let me hinge all my beam. So I'll first of all select all of them and say and unhinge all of them. I'll first of all unhinge all of them. Let me escape. I'll first of all unhinge all of them. I'll hold my control key. I'll select this. I'll still select this. I'll still select this, and I'll still select this, and finally I'll still select this. Yes, I want to unhinge all of them. I'll right click and say what? No hinge. Yeah, no hinge. I'll say apply to the selected beam. Yes, so at this point I want to hinge it properly. There will be no hinge at this point, so I want to hinge my JNs first. So I'll hinge here. There will be for this beam, there will be a hinge here. Why this cantilever beam? Please don't hinge it to this beam now selected, and there will be a hinge here. Yeah, I want to hinge my JNs first. So this my JN will be hinged. It will be hinged. Yeah, it will be hinged because it is not continuous at this point. Why this point? This my J. Okay. It's simple. All these things, they are all cantilever. They are all simply supported beams. Yes, they are all simply supported beams. So I'll just select it. I'll just hinge at both ends because all of them are simply supported beam. This is a simply supported beam, and this is a simply supported beam. We are not going to hinge this one because this is a cantilever. Yeah, we are not going to hinge it. And we are not going to hinge. We are not going to hinge one because this is a cantilever. Then I'll right click again. Once I right click, I'll click on what? Update beam end condition. Hinge both ends because they are all simply supported beam. There's something I just saw now. Remember, in story one, 1, we hinged here, we hinged here, we hinged here. Yes, we hinged here. But at this point now, we are not meant to hinge here because this is a continuous beam. It is not continuous. So I'll select this. Sorry. So I'll select this beam. So I'll select this beam and unhinge it at this point. Yes, and unhinge it at this point. So that means in this case, I'll be hinging only the J end. I'll be hinging only the J end. So I'll click on all beam end condition. I'll hinge only the J end. I'll click on apply to the selected beam. Yes, I'll be hinging only the J end. Then at this point, we hinged here, but now it is not continuous. That means we should not hinge here again. So at this point, that means at this point, since here is continuous and here is continuous, that means there will be no hinge at all. There will be no hinge at all. There will be no hinge at all. Then I'll click on this. I'll click on what? No hinge. Apply to the selected beam. I'll escape again. Then which other point again do we have all these things? Okay, at this point, yeah, here there should be hinge. Okay, here we not insert hinge at this point. Why? We not insert hinge here. There should be a hinge here. There should be a hinge here at I end. There should be a hinge at I end. Maybe it's a mistake. There should be a hinge at I end. So I will escape. Now there's a hinge here. At this point, okay, yeah, we no hinge here. We remove the hinge at this point. So we are good to go. We are good to go. We are good to go. So let's continue. So we are through with everything concerning this story 2. Yes, we are through with everything concerning this. Okay, we'll still come back to story 2, but let's come over to our 3D view to see what we have done so far. This is what we have done so far. So right now, I want us to come to this button story. I want us to come to this button story. Yes, to this one, to this story 1, and insert our cantilever slab. So that this thing will now look good in your eyes. Let's come to the story. Let's go to story 1 and insert our cantilever slab. So I'll come over to my plan view. I'll come over to my story 1. So I'll double click. So this is my story 1. This is my story 1. If you see our this thing, our building setout, building setout, that the layout is not appear, is not showing in this is not showing in this story 1. So let's go and make it. Let's come turn it on so it will start showing in story 1. So I'll come to building setout, come to external reference drawing, come to change this thing from story 2 to what? Story 1, and then I'll click on what? Okay, yeah, it's not showing. If you can see the staircase, story 1, the staircase is not showing. But the reason why these ones they are not showing because we have inserted this grid line. This grid line is preventing them from what's showing, but we still know their positions. So let's go over again to okay. Remember, okay, let's now insert our slab. We're having slab at this point. Look at it, you're having slab at this point, yeah, and also slab at this point, and what we're having is what? Cantilever slab. They are all cantilever slab. So let's go and check the length of our cantilever slab. So let me come out of my AutoCAD. Then I want to check the length of this cantilever slab. So I'll click on this thing dimension. I want to check the length of this cantilever slab. The length of this is 600, and I'll right click again, repeat here. The length of this is what? The length of this is 600. So the length is 600. So I'll come over to my ProtaStructure. But there's something I want you to understand. Naturally, this is a duplex. Naturally, we can rest a column and on top of a slab. Yeah, like a normal construction. If it's all these duplex, 1-story building, yeah, you can rest a column on top of a slab. But if it's a 2-story building, if it's 3-story building, 4-story building, please, don't rest a column on top of a slab. Please, I'm begging, please don't do it. But if it's for duplex, all these duplex building, because the only thing that will be coming to that column is the roof load. That's the only thing coming to that column. Is the only thing coming to the column is the roof load. So you can rest a column on top of that slab. Remember, we are dealing with this point now. So if you go and check AutoCAD at this, let's go and check. Let's come over to AutoCAD. So if you check, remember we are dealing with this point. That's this back end, this column position now. If you see now, look at is this column position. So that means this column now. Remember we said that will be inserting a column here. That means this column now will be carrying only the roof load, so it can carry it. But if there's let me say all this step on top of it, please. If there's all this step on top of it, please. Try not to insert a hidden beam, insert a beam. Yeah, it will be more advisable to insert a beam. But if you're a professional that you know what you are designing, yes, you can go with it. So far you know what you are designing. But if you are still starting up, please don't let it on top of a slab. Yeah, unless what that column is carrying, unless the only thing that column is carrying is just the roof load. So in this case, what our column is carrying is just the roof load. So I'll come over to this point, click on my ProtaStructure, and click on this, and click on my ProtaStructure. So I will be inserting a column at this my column will be resting on the slab. Yes, my column will rest on the slab, on my cantilever slab. But ProtaStructure, if you rest a column on top of a slab in ProtaStructure, but from ProtaStructure 2025 and above, you can rest a column on top of a slab and it will work. It will show you error, but in your design, it will still design through. But for ProtaStructure 2024 below, if you rest column on top of a slab, it will not design. Like they will be telling you error will be popping out at all points that you are resting a column on top of a slab. So I know that most of you will be using ProtaStructure 2024 and below. So let me show you what to do so that you not get stuck while going through the video. Please get the cat file and practice the architectural plan of this video, of this and practice. If you can see, this is a little bit challenging, so that's why you should get the cat file, because if you're able to succeed in modeling this and in designing this, that means any design that comes your way, you can easily model it and design it, and you make money from it. So at this point, what are we going to do? That means for us to be okay. Remember, I said that ProtaStructure will, if you rest a column on top of a slab, ProtaStructure will see it as an error. So for that reason, what we are going to do now is that we will insert what is called a hidden beam, so that the column will now rest on that hidden beam. Yeah, we'll insert a hidden beam. So let's do it now, so you understand. So I'll double click on this. I'll double click on it to bring out the property. So to make this now a hidden beam, the only thing I need to do is that I need to change this thing to the thickness of the slab, which is what, 150. Then I'll now insert a beam from this point to what, this point. So this beam now is called a hidden beam because it has the same thickness with the slab, or is carrying the slab thickness. You can either call it a hidden beam or you call it slab stiffener. A hidden beam or slab stiffener. Yeah, you can call it any of them. So this is it. I'll escape. So this is what we're having right now. Then I'll remove this cantilever sign. I'll remove this cantilever because remember I told you that I could have rested it on top of the slab, but due to the fact that ProtaStructure we see it as an error. That's why I inputted that hidden beam. Yeah, so that's why. So I'll click on this. I'll say, okay, no. Okay, let me just leave it. But the thing that you have to know that another thing you have to know, since I just inputted this so that I'll be able to design using ProtaStructure, please try and hinge it at both ends, because if you don't hinge it at both ends, ProtaStructure will provide a very heavy reinforcement. Remember I told you I don't really need this slab, I don't really need this beam. It's just that ProtaStructure will be popping out error if I want to design. So that's why I'm inserting this. I don't really need it. So to prevent those error, yeah, that's why I just inserted it. So, and if you leave it at the depth of 150, ProtaStructure, it will fail. So for that reason, I'll advise you to hinge it. Just hinge it. But if you still want to learn more, like if you want to understand these things that I've said well, if you want to understand all these things that I've said, please get the course, because I really went deep in the course. Get the course. So I'll just hinge it. I'll just select beam end condition, hinge both ends. Yeah, I'll try to select beam. So I've hinged it. So just get the course so you'll be able to understand this thing more. So like this, at this point now, what I'll do now is that I'll come over, click on this tab, to bring out this property. I'll click on this tab to bring out this property. What's going on? Let me escape. So I'll click on this tab. To bring out this property. Then for a cantilever slab is what? 12. Cantilever slab is what? 12. Then the next thing that we'll be doing is that since cantilevers, okay, we are still having the same loading. Well, then what is the length of our cantilever? Whereas we shaped it is what? 600. Is 600. So I'll come over to this point and I'll insert my cantilever slab from this point to this point. I'll take it up. Then I'll also insert another cantilever slab from this point to this point. I'll bring it to this point like this. Yes. So this is what I'm having now. I've inserted my cantilever slab. So I'll escape. Let's go over to ProtaStructure and see what we have done. So if you see now, it's not looking good in your eyes. Yes, it's not perfect now. Then if we want to model now, we will not trim off at side now. We will not trim off this and trim off this, like this excessive concrete. Yeah. So exactly what I've done here, I'll still repeat it in all. Okay, I made a mistake. This cantilever slab did not start from the extreme. So yeah, it not start from this point. It should have started from this point. So I made a mistake. So let me delete it. Like click on what? Delete. And click on delete, and then double click on this again to bring out this property. I'll double click on this again to bring out this property. So it should start from this extreme. It should start from this extreme. Yeah, it should start from this extreme to this point. It say cannot find common axis element. I'll just click on okay. I'll click on okay. Then I'll do it from here to here. Then I'll bring it out. So this is it now. So I'm okay now. It's now on this, so that the column will be able to rest on the slab. Yeah, on the slab. Okay, let's check again. Okay, we are not having any column at this point. So we are still good to go. So next one that I would like us to do is this one. Let's do for this extreme one. So I'll come over to my plan view. I know that this video is taking long, but I just want you to understand. So don't forget, let's check the point. We're having a column at this point. We're having a column at this extreme. So that means I'll have a hidden beam here, based on the things I've explained earlier. We're having a column. Let's just check the places where we're having a column. We're having a column at this point, and also at this point. That means we'll be having a hidden beam at those points. So I'll just come over and then double click on this to bring out this property. I'll double click on it to bring out this property. I'm having a hidden beam from here to here. So I'm okay with this. Yeah. both ends are hinged because I took the property. So both ends are hinged. I'm having a hidden beam from here to, remember we said that is this extreme. Okay, is this one from here to here. I'll also escape. The next one, hey, let me come and select the property. Let me come and still select the property. The next one, we say that we're having a hidden beam from this slab point to this point. Yeah, so I'll escape so that the column will rest on it. So at this point, let's go and check the length of our cantilever. Let's come over to AutoCAD and check the length of our cantilever. So I'll check the length of my cantilever. I'll click on my linear. And what is the length from here to here? I'm having to be 600. Then repeat linear again. What is the length from this point to this point? I'm having to be 825, 600 and 825. So at this now, I'll double click on this. So the length is what? 600. So we are good to go. So I'm having from here to this point. I'll bring it out. This one I'm having from this point to this point. I'll bring it out. Then I'll change the length now to 825. 825. I'll change the length to 825. Then I'm having from oh sorry, not sorry. From this point, I'm having, please, I'll pick the extreme from here to here. I'll bring it out. Yes, I'm good to go. And next one is that I'm having from this point. From this point. You can stop it at this point if you want. Yeah, if you want, you can stop it at this point. But I'll prefer that you stop it at this point. I prefer you stop it at this point. So I'm having a from here to here. I'll bring it out. So this is what I'm having right now. Let's go over to our 3D view and see. Let me escape. So let's come over to this point. Yeah, we are seeing what we are having right now. Yeah, this one will be trimmed off our side. So if you see, we made it 150 so that it will be in alignment, so that it will flush with this slab. So this is what we're having right now. Then the next part is that let's come and model this part. I forgot to delete this beam. I forgot to delete this column. I forgot to delete this beam. Sorry, this column. No, this, yeah, I forgot to delete the column. Let me come over to my plan view. Then I'll come over to story 2. I'll come over to story 2. Yeah, I forgot to delete the column. Look at it, this column. I'll like click on what? Delete. I'll click on delete. So it has gone. So I'll come over to my story 1 again to continue my modeling. I'll double click on it to continue my modeling. Then the next phase of this modeling now is we have to model here. We have to bring that here. So we're having a slab from this point to this point. So let's remember we're having a column at this extreme. So we should have a slab there. So we should have a hidden beam there. At that point. So from here to here, we should have a hidden beam at this point. So we have a slab here. We have a slab at this point. Then we have a slab here. Then we'll have another slab at this point. Yes, so these are the things that we're having. We're having a slab at this. Okay, let's model so you understand. So I'll come and double click on this to bring out its property. So this slab is starting from this extreme. Yeah, this extreme to this point. You bring it out. I'll bring it out. Yes, I'll bring it out. Then the next phase of this slab is starting from here, from this point now to this point. I will bring it out. Yes, I'll bring it out. Then I want to know the length of this slab. I want to know the length from here to here. So I'll just like click. I want to measure. I'll click on measure. I want to know the length from here, from this now to this point. Okay, let me just click here. So look at it, 1,600. 1,600. So it's still okay. So far, it's not carrying any column and anything. It's still okay. It's just carrying only. Okay, let's go to our AutoCAD and see what it's carrying. It's just carrying only window, only handrail. It's not even carrying any column and anything. So we are good to go. This one is carrying wall load. Yeah, these ones, they are carrying wall load. Yeah, it can carry it. It's carrying wall load. It can carry it. Highest the space will be 200, but it's carrying wall load. Yeah, it can carry it. The space will be 200. We'll make the spacing 200. Why this one is not really carrying anything, and the length is 1,600. So it's good to go. So far, it's carrying only the handrail. We are good to go. So I'll come over to this again. I'll come over to my ProtaStructure. Don't worry, you see how we are going to load our structure. So I'll double click on this. So okay, wait, I made a mistake. I want to check on something again. So I want to come over to this point and measure the current rent. Measure the correct rent. So 1,500. So I'll come over to this point again. I'll double click on this. Once I double click on this, I will come over to this cantilever length and change it to 1,500. So I'm having it to be from this point to this point. I'll bring it out. Yes, this is what I'm having. Remember, it should start from here. It should start from here. Don't worry. Doing our detailing, we'll make it to start from here. This doesn't really mean if we want it to start from here, that means we need to input a new grid line here. Yeah, but it doesn't really mean because it is too small. So doing our detailing will account for it. So I will escape again. So this is what we're having right now. Then don't forget we are still having this point. We are still having a cantilever length at this point. Yeah. Let's go to AutoCAD so you understand what we are saying. Look at it. Look at it. This is the cantilever. We are still having a cantilever at this point. That's for this family range. That's for this family range. So let's check the rent. Let's check the rent and moderate. Let's check the rent. So the rent is from here to here. We have it to be 1 meter. 1 meter. So I'll come over to my ProtaStructure. Once I come over to my ProtaStructure, I'll come and double click on this again.
Are you a civil engineer? Let me ask you a question. What if in just few days from now, you can pick up any architectural plan, confidently carry out its full structural design and detailing, and start earning from it? Sounds unreal, right? Stay with me because I'm about to show you exactly how. I created a 10 days intensive structural design and detailing masterclass to show you step by step how real structural design is done in practice, and this course is designed to last for 10 days. Before I show you what you are going to learn, this is the architectural plan we'll be working with, and we will carry out its structural design and detailing. Day 1 of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about path-based footing detailing. Day 6 column detailing. Day 7 beam detailing. Day 8 slab detailing, and you will understand the governing principles in slab reinforcement, that is how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10 you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan, and finally you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally access to our online engineering community, where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course now.
So I'll double click on this. So I'll click on this cantilever length and change it to what? 1 meter. And change it to what? 1 meter. Yes, and change it to 1 meter. Okay. Hey, I just saw something. We not insert any grid line at this point. We not insert any grid line at this point. So if we try to insert it, you see that it will not work. Okay, let me just show you. So you see. Let me just show you. So you see. You see, it's not working. It's snapping to this. It's snapping to this grid line. Let me just escape again. Let me just zoom where and pick here. You see, I picked here now. If I pick here now, let me go and insert it to this point. I'll pick here now. Look at they say cannot find a common axis for element insertion. That means we don't have a please pick insertion points again. That means we don't have a grid. What they're trying to tell us that we don't have a grid line at this point. There's no grid line at this point. So we either let me just input a new grid line. So I'll right click again, click on what? Offset axis. I'll click on offset axis and then place a new grid line here. You can either input a new grid line or you just leave it. Doing your detailing, you account for it. Doing your detailing, you account for it. But let me just input a new grid line since I've started. If I'm the only one doing the design, now I'll just leave it. Doing the detailing, I'll account for it. Yeah. So I'll come again. I'll double click on this. I'll come over to cantilever length again and change it to what? 1 meter. I'll change it to what? 1 meter. Then I'm having it to move from this point again. You see now it will not insert. I'm having to move from here to here. See, it's not insert. Yes, so this is what I'm having right now. So right now we have inserted all our cantilever. So let's go over to our 3D view and see what we are having. So this is what we're having so far. This is what we're having so far. This is what we're having so far. Remember, some of the beams will still terminate. Some of the beam will convert them to 300. Yeah, for example, this ones. Remember, this one now. Remember, this is a penthouse. This is a penthouse. So this beam now is not carrying the roof load. So we'll change it what to 300. Let's go and shake. Let's shake. Let's shake. So you see now, all these beams that are not carrying anything. Okay, look at it now. From here now, any beam now that is not carrying anything, that is only carrying the roof load, we will remove them. We will change them to 300. Yeah, because they are not carrying anything. Any beam that is only carrying the roof load, we change it to 300 because there is no slab on top of it again. Remember, I told you that the minimum beam depth is 300. Then plus the depth of your slab, making it what 450, because 300 plus 150, which is depth of your slab, we now make it what 450. So these ones that are not really carrying anything again, they will not be what 300 because they are no longer carrying any what slab. So what I'll do now is that let me just do CO enter. And let me just do CO enter. Let me just keep this in at this point. Then what I'll do now is that I'll convert this into a block element B enter. I want to convert it to a block element B enter. Let me just type block 2. Let me just type block 2 because we have done block 1 before. So I can just type block 2, or you just type anything that you want. So I want to type block 2. So I want to type block 2. So everything, this is not a block element. So I'll copy it from the staircase position. So we'll copy from this point. Yeah, the staircase position. And to look at the staircase, this is the staircase, this is the staircase. So we'll place it at this point. So any that means any beam now, all these beam now, they will be what 300. I'll change the depth to what 300. All these beam, their depth will what change to 300. And also this beam, yeah, and also these beams, their depth will change to 300. It's only this one that are carrying slab that will remain at what 400. So first look at it. This one's, remember, here is staircase, so here will be void, here will be void, here will be void, here I am this. So let's go over and model it now. So you see, so what we're having right now, there should be a slab here and there should be a slab here based on what we have seen so far. So I'll come over to my plan view. So this is story 1. I'll come over to story 2 again. I'll come over to story 2 again. I'll double click on this. Yeah, there should be a slab here. There should be a slab here. So I'm having a slab here. There should be a slab here. Look at what I'm having, a slab here. And then here, I should have a beam that will cut off this. Let's go and check again so you see. Let's check again so you see. Look at it. It went straight. A beam that will cut off this. Then I'm having this. I hope you are seeing a beam that cut off this slab. You're having a straight beam. Look at what I'm having next. Flowing from here. I'm having from here next, then down. So let's go and check. Let's come over to ProtaStructure. Remember, a beam that will run straight. Look at it. So this is it. So that means I'm having slab here, slab here, slab here, slab here, and slab here. We are good to go. So what I'll do now is I'll click on this, right click to delete this, then I'll double click on this. I'll come down. Okay, I'll come down and double click on this. I'm having a beam from this point to this point. Yes, a straight beam from this point to this point. So let's shake. I'll remove. Okay, this one will be hinged at I end alone. So I'll select it. It will be hinged at I end. It will be hinged at I end. It will be hinged at I end. So hinge at I end. Upright beam. Yeah, it will be hinged at I end. Why this one? This one will not be hinged at a. Okay, it will not be hinged. It will not have any hinge at all. So I'll do no hinge. No hinge. So this is it. Apply to the selected beam. No hinge. So that means this beam now is no longer necessary. So I'll delete it. Is this beam now is no longer necessary, so I'll delete it. Yeah, because this is a roof load. We want to save cost. So I'll double click on this again. And apply a slab. And I'll apply slab here. Yeah, so this is what we're having right now. So that means all these beams now, they're not really carrying anything. They will not be what 300 by what 300. So let's select all of them. We'll hold your control key, select all of them. So they all now will not be what 300. The depth will not be what 300. They will not have a beam depth of what 300. A beam depth of what 300. So this is what we're having right now. A beam depth of what 300. So we change all of them to a beam depth of what 300. This a beam depth of what 300. So let's continue. Oh, I made a mistake. So let me deselect this again. Yes. Okay, I will not select these ones. I'll come over to this point. I'll select this. 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 I'll select. Okay, after I'll come and check whether we're having something here. So I'll come and okay, this one I'll just leave it. Okay, yeah, this one I'll just leave it. I will say explain something with this beam now. I think we are good to go. Okay, this one too will be 300. I'll hold my control key. Oh my control key, this one should be 300 too. Yeah, we are good to go. We are good to go. We are good to go. Then let me come and shake. Okay, this one, let me just leave it at 450. Let me leave it at 450 because they will be carrying a, I think they are carrying slab. We will go and check again. They are carrying slab. So I'll leave it at 450. Yeah, so we are good to go here. So I'll right click, then click on property. I'll click on property. So let's wait for it. Then once I click on property, look at the depth. I'll click on this, then click on this pencil icon, then change it to what 300. I'll change it to what 300. 30. Yeah, 300 now. I'll click on OK. Look at it. All of them have been changed. Then I'll click on what close. So the depth has been changed to what 300. Yes, this one will be left at 450 because it is still carrying slab. Let's check. Let's check in ProtaStructure. Let's check in AutoCAD. So look at it in 3D view. Look at it. It's still carrying a staircase. It's still carrying this. So we'll leave it at what 450. Yeah, it's still carrying this slab. So we are going to leave it at 450. So let's come over to AutoCAD now. So let's go and see what we have done so far. Let's go and see what we have done so far. Let's go and see. So this is what we have been able to achieve. These are front elevation. These are front elevation. And two, this is what we have achieved so far. This is what we have achieved so far. This is what we have achieved so far. So next one that we'll be doing now is to come over. Next thing that we'll be doing now is to insert our story 3. Yeah, it is to insert the final story. So you get to understand everything. That's the next thing we are going to do. We are going to be inserting our final story. Yeah, that's this roof, that's this penthouse, And I'll come over to this ProtaStructure. I'll come over to ProtaStructure. Yeah, if I even forgot to show you, if you look where, if you see the depth of this is now smaller than this. Yeah, the depth is now smaller. Yeah, I'm not having the same depth because this is 300 and this is 450. Then I'll come over to my plan view to insert a new story. Please, I want to stay in story 2. I will stay in story 2 because I want to generate members from this story 2. So I will stay in story 2. Then I'll come over to my building setup, come over to my story operation, come over to insert story. Then come over, I'll input this into what to story 3. See the height of what 300. I'll now say generate story from the selected member. The selected member now is now what story 2 because I want to generate from story 2. Then I'll click on what okay. I'll click on OK. So this and the previous process will not be undone. I'll click on yes. So let's allow it. Let's allow it to generate story. So let's allow it. So look at it. Everything has been generated. Coming over to our 3D view, I'll click on this. So these are 3D view. This is what we're having in our 3D view. So this is what we're having right now. Then, as you all know, we don't need all these things. Like all these beams, they are not involved. They are not in our 3D view. So let me just come over to our plan view. I'll come over to my plan view. So once I come over to my plan view, I'll select all of them. Yeah, I'll just select all of them. I can just select them like this. Yeah, I'll select these ones like this. Everything will be selected. Then I'll hold my control key. Please hold your control key and select this. And select this. Hold your control key and I'll select this. Anyone that I don't need, I'll just deselect them. I'll select this. I'll also select this. And then come over to this point, I'll select this. This is what I'm having. This is what I'm having. This is what I'm having. Yes, I'll select all this. Everything that I don't need, I will select them. These ones too. This one, they are not needed. They are not needed. And two, it is not needed. It's not needed. I'll just select all the ones that I don't need and delete them. So this is what I'm having right now. I'll click, then click on what delete. I'll click on delete. Then I don't want to delete any axis. Yes, I want to delete some columns and I want to delete some beams. Then I'll click on OK. Let's allow it to delete. Look at it. So everything has been deleted. So this is what I'm having. Okay, I would not delete this column. Then I hold my control key, select this. Also hold my control key, select this column. Then hold my control key, select this column. What next? I'll hold my control key, select this column. Hold my control key, select this column. Then we have deleted everything. Then this is a roof beam. This is a roof beam. That means there is no slab. There is no slab. There is no slab. So I'll also delete all this slab. Then I'll click. Then click on what? Delete. I'll click on what? I'll click on delete. I'll click on delete, which is this. And then click on what? Okay. Yeah. So if you see this beam now is projecting outward. I don't want this beam to be like this. That means I need to remove this beam and then insert a column at this point. So what I'll do now is that I'll click on this. Once I click on it, I'll click okay. You know, I told you I'll explain something with this. I told you I'll explain something with this before, but I forgot to explain it. So looking at this, I want to explain the concept of primary and secondary beam and also breaking of beam. That's why I say you should get the paid course. That's 10 days intensive structural design and detailing masterclass. Get that course. It will really help you a lot because I really explain all these things in that paid course. So remember, I told you this is a primary beam. Yeah, this is a primary beam. And two, this beam now is being connected by this column and this column. Why this now? This now is a secondary beam. Yeah, this is a secondary beam. Even though I'm having a column at this point, this will still be called a secondary beam. And two, in this case, if you see this is this is one beam and this is also one beam. Yeah, what it means is that this beam is resting on this column and this beam is resting on this what column. Yeah, that means both of them are resting on this what column. Why this primary beam is not carrying their load. That means this is serving as a point load to this beam and this is also serving as a point load to this beam. So in a case, for example, let me delete this now and show you something. Let me hold my control key. I'll delete it and show you something. Let me delete it. I'll click on what? Okay, I'll delete both of them. Then I'll double click on this to bring out this property. I'll double click on it to bring out this property. Let's wait for it. So look at what I'm having. So I want to insert a beam from here to here. So look at, they are telling me new beam crossing over each other. Do you want to split the beam? In this case, I'll tell them no, I don't want to split the beam. Yeah. Sorry, I'll tell them yes, I want to split the beam. It's a mistake. Let's undo it. Okay. Let me just show you something. But I should have said no, I don't want to split the beam. So in this case, now look at it now. This now, if you see, this now is just one member. What it means is that this beam now is not transferring its load to this beam. Yeah, it means is that this beam now is not transferring its load to this beam. Like this is one member. Why this is one member and it is not transferring its load to the beam. So if you model this like this, that means you are not accurate in your modeling. You are not accurate in your modeling. And in design, this beam will fail because this is a very long beam. Yeah, because it is a very long beam. It is assumed or supposed that it should be transferring its load to this beam. But if you say don't split, that means it is not transferring its load to this beam. So the correct option should have been that I'll select this. I also hold my control key. I'll select this. Okay, sorry. I'll select this. Okay, I'll hold my control key. Then click on delete. The correct option should be that I'll double click on this. Let's wait for a dialog box to appear. The correct option should be that. So let me double click on it again. And then the correct solution should be that I'll move from here to here. Then they'll not ask me, do you want to split the beam? I'll say yes, split the beam. So they will not be. So what I'll now be having here is two beams. Look at it. I'm having this beam and then this beam. That means I'm having two beams, this and this. This beam now will now transfer its load to this beam. Why this beam now also transfer its load to this beam? So this is how it should be. Get the paid course because almost all these things I don't really explain them here, but I explained all of them in the paid course. So seeing that this is a roof beam, we don't need this. Seeing that this is a roof beam, and two, our roof is like this. Our roof is like this, like this block wall is like this, like this, like this. Yeah, that means this one we don't need this here. We don't need this here. So what are we going to do? What we are going to do now is that what we are going to do now is that since this is a roof beam and we are also trying to economize because in roof beam not all the beams are necessary. Not all the beams are necessary. So I'll be removing this. I'll be removing this. This is here. Don't worry. You just what I'll do. I'll delete it. I'll click on what? Delete. Yeah, I'll click on delete. Then I'll double click on this to bring out the column property. I'll double click on it to bring out the column property. I'll insert a column at this point. Yes, I'll click on this, right click, then click on what? Delete. I don't need it again. So I'll be having this thing like this. It will be like this. So this will be my roof beam. This will be like roof beam. I'll come over to my 3D view to see what I've been able to achieve so far. So let me click on Story 0 so that this grid line will go to Story 0. So this is what we have achieved so far. Yes, this is what we have achieved so far. So this is what we have achieved so far. Yeah, okay, I'm having this. Let me come and check my architectural plan for this. And also, okay, I will also forgot to delete this. So I'll just like click on what? Delete. Yes, so it has gone. So this is what I'm having. This is what I've been able to achieve so far. So I saw how we were able to model this penthouse. So in this case, let me come to my architectural plan and see what I'm having. So coming over to my architectural plan, so I'm having that. Remember that column is this column now. Is this column, and to that we are seeing that column did not come up. Like it shouldn't be here. We should not be having it at this storytelling. We should not be having it at this penthouse. So I'll come over to my I'll come out to ProtaStructure. Then at this point, what I'll do is that I'll click on it to delete it. Yes, okay, escape. I'll click on this. Then I'll also hold my shift key, hold my control key. Then click on this. I'll right click on what? Delete. I'll click on delete. I'll click on it and then click on OK. Yes, this is what I'm doing. Let me go to plan view so I'll be seeing it very well. That means this one too. Wait, it did not delete. Let me do Ctrl Z to return back everything. So I want to delete this and this. Yeah, I want to delete both of them. I'll right click on what? Delete. I'll click on delete. I'll click on what? Okay. So like at this point now, I'll double click on this thing to bring out its property. So I'll double click on it. So I'm having this from here to here. So this is what I'm having. Yeah, this is a cantilever. So it's showing a cantilever sign. But okay, it's okay. I'm okay with this. So this is my roof beam. And so I've gotten the modeling accurate. Hope you are understanding and hope you are following. Get the paid course because I really went in depth in that paid course. So right now, the next thing that we'll be doing now is to insert our wall load. In inserting wall load, I would like to come to my plan view. I would like to go to story 1. I'll click on story 1. So I would like to insert a wall load. For sure, I know that I should be having a wall load here. So I'll click on this, then click on edit load. I'll click on edit load. Once this dialog box appears, what we want to apply here is wall load. So this is for point load, full uniform load. So we'll come to wall load. This is what we want to apply. So we'll click on it. So this dialog box will appear. Then you come to this point, and choose user define. Yes, so user define. Then if you want to put in windows and the rest, you from here you put it. But me, I don't like putting windows and the rest because I want to design as what condition. So I don't normally like putting windows and the rest. So if you want to apply wall unit weight, so okay, so this is it now. This is wall unit weight. So wall unit weight, your wall unit weight for wall unit weight. Okay, for wall unit weight, we'll be having that. Okay, let me explain wall unit weight for you. So for 225 by 225, sorry, for 225 block wall, its wall unit weight is 2.87. That's the wall unit weight of a 225 block wall. 2.87. But you know that after placing your block wall, we will do plastering. Yes, so we will plaster both the front and the back. So the unit weight of plastering is 0.3. Of that plaster, the unit weight, that's the sand and the mortar, the unit weight is 0.3. So until you know, it will be 0.3, we'll be doing front and back. So it will be 0.3 plus 0.3, so which is now 0.6. That's the unit weight of the mortar and sand for front and back of the block wall. So let's now sum everything up now. So we'll get the unit weight of the block we'll be using. So in summing it up, we'll be having that the unit weight of block is 2.87. That's 225 by 225 block wall. That's 9 inches block wall. Its unit weight is 2.57. Then the unit weight of plaster, that is the sand and the mortar, is 0.3. We'll be having front and back, which is now 0.3 plus 0.3. We'll be having 0.6. Then 0.6 plus 2.87, you can press to your calculator, you now be having 30.47. 0.6 plus 2.87, we're having 30.47. So we'll come here and input our unit weight to be 30.47. So this is our unit weight. So at this point now, they are asking us what is the height of our block wall. What is the height of our block wall? So the height of our block wall is 2.7 meters. 2.7 meters, that's the height of our block wall. 2.7 meters. Let me explain it to you. Sorry, is in millimeter, so it's 2,700. Since the unit is in millimeter, so it's 2,700. Let me explain it to you. You know that if you check our architectural plan, the height of story 1 is 3 meters. Okay, let me just click on insert and then go to the modeling and show you. So the thickness of our block, we're using the thickness of block of 225 by 225. So I'll click on 225 by 225. Don't click on insert. Just come here and click on this. You have applied it. Then I'll click on OK. This is what I'm having. So I'm not able to insert wall. Let's go to our 3D view to see what we have done. So look at it. What you have done. So right now I'll come over to my AutoCAD to see the places that I'm having wall load. Yeah, to see the places that I'm having wall load. So in this AutoCAD, I'm seeing that to see the places I'm having wall load. Remember, if you want to check the places you're having wall load, you use this first floor. Yeah, because it is this first floor that will be carrying wall load. So I'm seeing that this will have wall load, this will have wall load. Okay, let's just apply it to all places. Then after, we'll not delete the places that are not having wall load. Yeah, let's just apply it all, and after, we'll not delete the places that are not having wall load. But first of all, let me delete this enter. Let me delete it because I don't need it again. So I can easily locate places that are having wall load. So at this point, I'll come over to my plan view again. Then I'll come over to story 2. So this story 2, I'll come over to beams. Okay, first of all, I'll copy it. I'll copy the wall load. I click, then click on copy load. I'll click on copy load. I'll click on OK. So I've copied the load. So at this point, I'll click on this first beam. Once I click on this first beam, I'll hold my shift key. Hold your shift key. I'll select this last beam. Then it will select all the beams. Then at this point, I'll then come to this point and click on paste load, or you right click, and then click on what? Paste load. So once you do that, you see the load has been pasted in all the beams. So I will escape. Remember, these ones they are not having wall load because the wall load will be applied on the slab, on this cantilever slab. So I'll hold my shift key, select this because I will remove the wall load on it. These ones they are not having wall load. So I'll hold my shift key, select all of them because I know they are not having wall load. So I'll hold my shift key, select this, also select this, Yes, because I know they are not having wall load. I will also select this. Yes, and I will also select this. I know they are not having wall load. Come over to, okay, let me just leave here. This one, I'm having window here. So I'll select this and select this because I know it's not having wall load. Here, the wall load is at this cantilever sign. Then here, I think, okay, let me just leave here after I'll check on it. Then at this point, what I'll do, okay, this one is not having complete wall load. So I will still delete it. And at this point, I'll still delete it. I'll right click. What I'll do now is that I'll click on delete load. I'll click on delete load, then click on OK. So this is what I'm having. Let me escape. Let me escape. So this is what I'm having. We have removed all the wall load. So let me check here and also check here to know whether we are having wall load on those places. So I'll come over to my AutoCAD. Yeah, I'll come over to my AutoCAD. Okay, yes, there's wall load. There's wall load. There's wall load. Then okay, at this slab there's wall load here. So then at this extreme there's wall load. There's wall load here. I want to go. I need to. There's wall load here. So I'll take note of this, and then this one and this one. So let me come back to ProtaStructure and model it. So at this point, remember we said there is no wall load here. The wall load is at the extreme. So I will hold my control key, select it, and also select this one. Then I will right click. Sorry, I will right click on what? Delete road. I'll click on delete road. Then click on OK. Yeah, I will escape. I will escape. Then I'll select this beam. I'll select this beam. Hold my shift key. Also select this beam. I'll come over to this point and click on paste road. Then it will paste the road. So I've done this. Remember, we'll apply the slab load here. So okay, let's come over to this one. Let's come over to AutoCAD. This one that is having line here. Okay, this one that is having a load at this point. A load at this point. I'll just apply it on the beam. I just want to apply it on the beam. So I'll come over to this point. Come over to this point. I'll click on this, then click on wall load. I'll click on paste load. I'll click on paste load. Then this is now my cantilever. Yeah, this is my the veranda. That's the sit out, the cantilever. So this is what I'm having. Let's also check to know whether is there any place there should not be wall load, that we are inserting wall load. Yeah, I think we are through. Okay, this point is free. Okay, I've taken note of it. I think we are through, and this point too, they are free. I think we are through. So let me come back again. I'll come to my story. I'll come to this. I'm having that here. There's no wall load here. There's no wall load here. Then I'll click on. I'll like click on what? Delete road. Delete road. Not delete. Just delete road. I'll click on delete road. Then click on OK. Yeah, there's no wall load here. I'll escape. Then I think we are through with everything. I think we are through. So the next thing now is to apply. Okay, remember there is a partial wall load here. Let's shake. Yeah, there's a partial wall load here. Look at it. It starts from here to this point. It starts from here to this point. So let's go and insert that partial wall load. So you see how to insert partial wall load. So let's take it that it starts from here and stop at this grid line. Let's just take it that it starts from here and stop at this grid line. If you want to apply it, look at how to apply it here. You come, okay, if you want to apply, look at how to apply it here. You come over to this space. Look at insert load by dragging. Insert load by dragging. You click on it. Once you click on it, you click on from here to this point. Yeah, look at the road that has been inserted. So insert load by dragging. But I think this option is available only in 2025 and in 2024. I think so. Then at this point, we are through with our load insertion. The next thing is to apply this cantilever load. Yeah, this cantilever load. Next thing is to apply them. So how are we going to get our cantilever load? The cantilever load is gotten by the unit weight of your block wall times the height of your block wall. The unit weight of your block wall times the height of your block wall. If you can remember, when we are doing slab, I told you, when we are inserting slab, I told you that the ProtaStructure have automatically calculated the self weight of the slab. And I told you that the way it calculated it is the unit weight of slab, unit weight of concrete times the depth of your slab. The reason why I use unit weight of concrete in that area is because slab is made up of concrete. But in this case, I'm using unit weight of block because I know that block is made up of, so I know that wall is made up of what? Block. So I'm using the unit weight of block times the height of block. So I'll come over to my calculator. Let me come to calculator. I'll type tau to bring out my calculator. So I'll click on my calculator. Let's wait for it to appear. So the unit weight of my block wall will agree to be 3.47. Then times the height of my block wall. What was the height of my block wall? 2,700 millimeter. But this one is in meter. This is in meter. That means I'll be using 2.7. That's times 2.7. So that both of them will be in meter. Then I'm having 3.96. So I can use 9.4. I can use 9.4 as the magnitude of my what? As the magnitude load that I'll apply on this what? Block wall. That I'll apply on this slab, as the load that I'll apply on this slab. Then I'll come over to modeling. So I'll come over to loading. Come over to loading, look at point load, line load, and area load. So I'll click on it. Then come over to this point that says, okay, I'll come over to line load. Then come over to this magnitude. This will be a dead road. So I will be using this dead road. This one is for rife road. This block wall is not rife road because it is not movable. It will be there forever. So it is dead road. So I'll be using 9.4 as the magnitude, load magnitude. That's the load that you are using. So I'll be using 9.4. So I'll use 9.4. So that's what I'll be using. Then I'll apply it from this point to this point. It has been applied. I'll apply it again from this point to this point. It has been applied. Then I'll bring apply from here to here. Yes, it has been applied. The magnitude of what? 9.4. Hey, I made a mistake. Here does not have any block load. Yeah, here does not have any block load. Let's go and shake. Let's go and shake. Let's go and shake. So you see it. So you see it. Look at it. Here is a cantilever. There is no line load there. And also even here too. Here, we will not account for it. So let's go back. Let's go back and account for it. Let's go back and account for it. That means this thing should stop here. So I will escape. Then I'll do Control Z to undo. Also do Control Z to undo. I'll also do Control Z to undo again. Then I'll come over to my line load, come over to this. Then I'll come over to and insert what? 9.4. 9.4. So I'm having my line load to be from this point to stop here. Yeah, here is veranda. Then I will escape. Then I'm having another line load from at this point. So it will start from this point to this point. Yes, then it will start again from here to this extreme. Yes, then it will still start again from this point to this point. Yeah, so this is what I'm having. So let's go over to AutoCAD to see the places we're having our line load. Look at it here. Then at this point, let's also apply it at this point. Then let me come over to this point. Then it will also apply from here to, okay, it will stop here. So we are good to go. Then at this point, let me come over to ProtaStructure. Then at this point, we are having line load. This line load moved from here and stop at this point. It stopped at this grid line. Any grid line that comes from this staircase, it will stop there. Then the next one starts from this point. We'll just start from here, downward. So hope you understand. So let's go and insert it now. Let's go and insert it. Then I'll draw this down. So this thing, it will stop at this one, at this second grid line. Okay, it's from this point. Okay, let's just stop here for now. Let's stop here. Then I'll click from here again and then stop at this point. I'll stop at this point. Then I'll come over to this point. Then I'll start from here, then draw it to this point. Yeah, I'm inserting my load. Please insert your load. Insert this line load. They are necessary. Not they are necessary. They are very, very important. So you know under design. Because if you not insert all these things, your structure is prone to failure and is prone to collapse. So this one now, what will be here is handrail. So I can decide to just use a load magnitude of 1 or even 0.9 because it does not have any high load. So let me just use a load magnitude of, let me just say 1. Yeah, a load magnitude of 1 because handrail is not heavy. So I'll apply it from this point to this point. Yes, and also I'll still apply it from this point to this point. Yes, I think we have successfully applied all our line load. So I'll come over to AutoCAD to be sure that I've applied all my line load. So yes, we are through with everything. Then let's come over to ProtaStructure. So let's go to 3D view and see what we have done so far. So hope you have seen what we have done so far. Here is grass. So you can see apply a line load of 1. Okay, I will come and apply a line load of 1. So look at what we have done so far. The reason why this one is very tiny and this one is like this is because this one is 1 kilonewton per meter square. Why this one is what? Why this one is 9.4? So this one is more than this. So that's why this one is very, very small. So this is what we're having. Here. We will not apply any line load because this is a veranda. Yeah, we don't apply any line load. Then this is what we're having so far. This is what we have achieved so far. I think there should be a wall load there. Let me check in AutoCAD. I think there should be a wall load here. Yeah, there is a wall load. Yeah, we're having a wall load. Here. We're having a wall load here and here. So we're having a wall load here and here. So let's go inside that wall load. So I'll come over to this point. So is part of the reason why you should cool down and do your detailing. That's the part of the reason why you should cool down and do everything. Okay, I'll just click on this. Let me just escape. Then I'll click on this. Sorry, first of all you click on one of these. Then this option will appear. Okay, wait. If you click on one, this option will appear. Insert load by dragging. So I'll select this. I want to insert load by dragging. So I want to. I'm moving from. Okay. Yes. Let me escape. I want to insert. Okay. I want to apply line load. So I'll click on. Let me escape. I want to apply line load because it is running on slab. Yeah. The reason why I say let me apply this load on this beam is because before I apply line load on this slab, I have to insert an axis. And because line load will not be, I can't apply any line load on just normal slab. I must insert an axis, then apply it on top of that axis. That's the hair. So, but since the length of this video is already much, I just say let me just ignore it and just apply it on this. That's why I say you should get the paid course, because in the paid course, I'm not considering length of the video because I know you paid for it. So I explained everything. So in this case, we'll be using line load and it's still 9.4. So our line load will be from this point to this point. So that's where our line load. So if you see now, we have applied the line load. We have applied the line load. Let's go to the 3D view so you see it. So you see the line load. So look at it here. So I told you the reason why I not apply it here is because I know I have to start inserting axis, and two, this video have taken too much time. So you can get the paid course. Everything is explained there. So this is what you're having right now. Then I'll come over to my plan view, get the CAD file and practice, because if you're able to practice this and understand this, I trust me, there's no building that you cannot model. There is no building that you cannot model. Yeah, because I believe that this is the most complicated building you can see. Yeah. So at this point, we are through with everything concerning this first floor. We will now go over to story 2. But before I go over to story 2, I'll like to copy this road. So I'll click on this, like click again, click on what? Copy road. I'll click on copy road. I'll like to copy this road. I'll like to copy this road. Then I'll come over to story 2. I'll come over to story 2. I'll double click on story 2. Remember, in story 2, is not everywhere that is having what? Line load. It's not everywhere that is having wall load. Yeah, it's no longer, because here now, this is our roof area. All these are our roof area. They are not having any wall load. So I'm having this. So I will click on paste road. I'll click on paste road. So let's go to our 3D view and see what we are having. Let's go to our 3D view and see what we're having. So look at what we're having right now. Hope you are seeing what we're having right now. Yes, yes. Oh, wait. Let me check something. Do we change the depth of this beam? Because this is a roof beam. Oh, we did not change the depth. We did not change the depth. So let's change the depth immediately so that we'll not forget. So that I will not forget. Let's change the depth immediately. So I'll come over and click on this. Okay, I'll click on story 3. Once I double click on story 3, I'll come over to beam. I'll click on beam. I'll right click on what? RC beam table. RC beam table. I'll click on it. A dialog box will appear. Once this dialog box appear, I'll come to this place hinge. I'll change it to what? 300, because the minimum beam depth is what? 300. So this one is no longer carrying any slab. So I'll change it to what? 300. Yes, I'll click on OK. So if you see everywhere I've been changed to 300, I'll do close. So look at it. Yeah, it's not small. So it's not 300. So let's go back to our story 2 and insert our load and insert our wall load. So let's come over to ProtaStructure. Let's come over to AutoCAD to know the places that we are having wall load in this story 2. So it's all just only these places that we're having wall load. This. So let's come and apply it now. Let's apply it now. So I'll come to ProtaStructure. Then anywhere that's having wall load, I'll just be selecting them. I'll just select them. I'll hold my control key. Wall load is here. I'm having wall load at this point. I'm also having wall load at this point. I'm also having wall load. Sorry, let me deselect this. I'm also having wall load at this point. Yeah, this one is also having wall load. Sorry, let me deselect it. I'll deselect it. So this beam now is also having wall load. We again, I'm having wall load at this point. Yes, I'm also having wall load at this point. Yes, I'm also having wall load at this point. Yes, I'm also having wall load at this point. I'm also having wall load at this point. Yes, I'm having wall load at this point. There's no wall load here because this is step, so there's no wall load here. I think I'm also having wall load at this point. Yes, then I'm having wall load here, but I will use insert load by dragging for this area. Then I think that I'm having wall load at this point, and then I'm having wall load for this veranda. Yes, okay, for this, yeah, on this beam. Then this one I'll use insert road by dragging. Then I'll come over to this point and click on paste road. It will paste the road. I'll escape. So let's go over to our 3D view. So this is what we're having so far. This is what we have been able, this is what we have achieved so far. This is what we have achieved so far. So I'll come over to my plan view again. Then let me go over to AutoCAD to be sure that what I did is the right thing. Yes. I'm having this line load. So let's check again and be sure. Let's check again and be sure. So this is it. This is so this one now. Okay, there's no road here. Yeah, there's no road here. It's true, there's no road here. This one there is a road here, but I'll use insert road by dragging. So click on this, it will appear. I'll click on this. I want to insert road from this point to this point. So look at it, it has been applied. So this is what I'm having right now. So we have modeled this accurately. So I think we have modeled this accurately. Yeah, we are through with our modeling. We are through with everything. Is there? Let me check. Is there any way that we need to apply load? Without, okay, here there should be a slab here. Why do we delete this? We did not insert slab here. There should be a slab here. So let's come over to our 3D view. Yeah, there should be a slab here. So I'll double click on this. Once I double click on it, it will appear. So then I'll apply my slab at this point. Yeah, there should be a slab here. Yes. So I'll come over to my 3D view again. I'll come back to my 3D view again. Yeah, okay. Let me move this into story zero. So this is what I'm having so far. This is what I'm having so far. This is what I'm having so far. Hope you are understanding. This is what I'm having so far. This is what I'm having so far. This is what I'm having so far. So I can apply a line load on this beam. Yeah, a line load of one. So let me come over and apply a line load of 1 kilonewton. So I'll click on this. Then click on line load. At this point, I'll select just one. Yes, I'll select just one. So I'm having a line load from this point. Okay, then escape. Okay, yeah, it's still okay. So I want to have it at the center from this point to this point. Yes, then I'll have another line load from this point to this point. Yeah, so these are the places we're having line load. Here, yeah. This, I don't think there is a line load here. Let's just shake. Let's just shake. Okay, yeah, there is a line load. I'll take it back. Okay, no. There is a wall load. Okay, sorry. Is there? There is a load. I'll still apply the line load. So I'll come to my ProtaStructure and still apply a line load from this point to this point. Yes, let me go to 3D view and be sure of what I've done. Let me just go to 3D view and be sure of what I've done. Yes, yeah, it's okay. Yeah, this, because this one will terminate here, so there should be a line load at this point. So we are good to go. Okay, we not apply the line load for this. That's the grass load. But let me just leave it. It doesn't mean the road is very small, 1 kilonewton, so it really doesn't mean. So I'll just leave it. Then at this point, we are through with our modeling. Then the next thing that we'll be doing now is to edit our story. So I'll come to building setup. Just follow me. I'll come to building setup. Come to story operation, and then come to this edit story. I want to edit my story. Come to edit story. So at this point, what is the height of my story? The height of my story is 3 meters. So I'm okay with what I'm having here. So I'm okay with all these things. Then what is this? Is the first story bottom level. That's the distance between your soil to this, the difference, or the height difference between your soil and your finished floor level. That's where you have placed your concrete or terrazzo or tile. The distance, that's the height between your soil and your finished floor level. So in this case, I'm having it to be what, 4 feet. I'm having it to be 4 feet. So I'll insert it. If you insert it, you see it will appear here. It will appear here, 4 feet. Then what is the depth of your foundation? The depth that we got from the soil report is what, 1,200. So that's the depth that we got. So in this case, height is okay. The level, these are the level. The rabble, we're okay with it. Then coming over to this point, okay, look at imposed load reduction. I will advise you to leave here. Just leave it as default, because imposed load reduction is normally used for high-rise building. Yes, for high-rise building, because you know that in high-rise building, not all the floors will be in use at all time. Yeah, not all the floors will be in use at all times. So we do imply imposed load reduction. Yeah, because if you apply it, that means you'll be able to save cost. So we do apply it, but that one is mainly applied in what, high-rise building. For example, this is a penthouse. Most times people will be in the ground floor, the first floor, and also at that penthouse. So we don't normally apply it in this low-rise building, but we do apply it in what, high-rise building. But don't worry, once we come to high-rise building design, I will really explain this one very more, because we do apply it by percentage. Yeah, but we not really understand it. So at this point, we are through with everything. I'll click on what, okay. I'll still say okay. Yeah, I'll still say okay. Then at this point, the next thing that I will be doing now is I'll come over to my plan view. Next thing that we'll be doing now is to label our members. Yes, not to label, to label our beam. For example, this is beam 1. This is beam 1. This one is beam 3. This one is beam 22. This one is beam 23. So I want to label this beam correctly and also label my column correctly, so that doing beam detailing, I can be fast. Yeah, because if you do not label it, doing your beam detailing, it will slow you down. So label it. So at this point, I'll come over to my review. Come over to the label members. So I've done for axis before. Okay, I've done for axis before, but if you want, you can still select it. But I've done for it. Okay, let me just select it again. I'll click on this, just select all of them. I'll select all of them. Then I'll come over to this axis and interchange this. And then click on what? Okay. So if you shake now, this is now beam 4, and this is now what? Beam 1. Okay, look at it. Beam 1, and this is beam 2. And if you shake again, this is okay, beam 1, this is beam 2. I don't know, is either this one or okay, look at it, beam 3, and beam 3. Then this is now what? Beam 4, and this is what? Beam 5. This is what? Beam 6. This is what? Beam 7. This is what? Beam 8. This is what? Beam 8. This is what? Where is beam 9? Where is beam 9? Okay, this is what beam 9, this is what beam 9, this is what beam 10. So everything has been labeled accurately and well, so that during your detailing you not get confused. So right now, let's do building model check. Let's do our building model check. So I'll click on this, then I'll click on what? Start. Let's check whether we're having any error in our modeling. So let's check. We are not seeing any error so far. We are not seeing any error. So if you see we did an accurate modeling, yeah, I'll click on what? I'll click on what? Close. So I'll still advise you get this 10 days intensive structural design and detailing masterclass. If this video is as good as this, just imagine when I'm telling you that I explained everything in detail, how that video will look like. So I advise you, this is an investment that you never regret in this life. You will never regret it. You want to be a very good structural engineer? Yeah, start now. I know how I got good. I know how I got good by practicing. I know courses that I bought. Yeah, I know courses that I bought that made me good. I also know people that I worked under that also made me good. So if you want to get good in this, please practice and practice well. Okay, I think that we forgot to apply line load on this slab. We forgot to apply line load on this slab. So you can choose to apply it or you can just choose to ignore it. But let me just apply it. Yeah, because I know in my normal modeling, I'm gonna surely apply it. Yeah, like if this is not a YouTube video, I'm gonna surely apply it. So I'll just use one. I'll just use one. So I'll apply from here to here. Here. I'm having this. Then from this point from this point to this point. Yes, I'm having this. So I've applied the line load. So let's go over to our 3D view. So this is what we have achieved so far. There's one mistake we made in this roof beam modeling. Yeah, there's one mistake. If you see now, this beam now went straight. It went straight. But let's come to architectural plan. So you see the mistake that I made. Let's come to architectural plan. So if you come to architectural plan, this is the roof beam. So if you see this one, it not go straight. It not go straight. Like look at it. It went like this, then offset, then came like this. So that means what we are going to do, we are going to copy this. We are going to copy this enter. I want to move it. So I'll place it in this story 2. So I'll see how it went. So I want to place it at this story 2. Don't forget, please place it in staircase position. So at this point, if you are seeing this roof beam now is covering that our cantilever. Yeah, the cantilever that we're having here, it is covering it. So that means I have to insert a grid line here and here to be able to model this beam. I have to insert a grid line. Remember, I told you before you be able to model any beam or column, there must be a grid line there before you be able to model it. So I'll come over to my ProtaStructure. So if you see, we are not seeing our architectural plan at this story 3. Yeah, we are not seeing it. So if you want it to appear here, what you are going to do is that you come over to your building setout, you come to external reference drawing, you come over to number of story, which is 2. You come and click on 3, then click on what? Okay. Click on okay. So if you can see now, it's not appearing at this point. So what we are going to do now, this one we already have a grid here. We already have a grid line here. So the next thing we are going to is just to insert a grid line at this point. So to insert a grid line at this point, what you are going to do is just offset one of the grid line. So I'll click on it, right click. Once I right click, I'll click on offset axis. I'll then come and place it here. Then I'll escape, right click again, click on property to turn it into a hidden axis because this axis is not really useful to us. So I'll click on update. So it has been converted to a hidden axis. So next thing is that I will copy the properties of this beam. I'll double click and copy the properties of this beam. Then I'll place a beam from this point to first of all place my cantilever length because this one will be the cantilever carrying this long beam. So first of all, I'll model my cantilever. So this is my cantilever. Yeah, I'll first of all model my cantilever. Then after modeling my cantilever, I'll then model this beam. I'll place it at this point, but it should be in alignment with this grid line. So what I'll do now is I'll come over to this point. Sorry, not here. I made a mistake. I will escape. Then I'll double click on this again to bring out this property. I'll click on cancel. Then I'll click on this. Once I click on this, I'll click on this point. Let me take it up. So I'll be seeing this update. So I'll click on update. I'll click on first of all, I'll click here, then click on what? Update. So it's moving outside. That means this is not the correct boundary condition. I'll select this, then click on what? Update. Yeah, so this is what we're having now. So we are good to go. Then next thing, some people can ask, why is that we do not apply a roof load? But let me just apply a roof load. Let me just apply a roof load so you even see that. So in your own, you can equally apply a roof load. So in applying a roof load right now, what I'll do is that I will click on this, like click on what? Edit load. Click on edit load. I'll apply my roof load. Click on continue. I'll apply my roof load as block wall. Yeah, I'll apply it as a block wall. So I'll click on wall load. So once I click on wall load, this will appear. So if you see, it's already 3.47 because of the ones we have applied before. Then at this point, I will not like to use the height of 2,700. This is a roof load, so I'll be using a height of 750 or even 700, but I would like to use 700. I'm using a height of 700 because this is a roof load. So I'll click on this point to apply the load. Then I'll come over to this point and click on what? Okay. I'll click on okay. So this is what we're having right now. So the thing what I'll do now is that I'll just come and select all the beams here. I'll come and select all the beams. I'll click at this point and then hold my shift key to this point. Then I made a mistake. I've not copied the beam. I've not copied the load. So I'll copy it. I'll copy load. I'll click on what? Okay. I'll click on what? Okay. So I've copied the whole load. So I'll escape again. Then I'll click on this. Then hold my shift key, select this. Then I'll right click. Once I right click, I'll click on what? Paste load. Paste load. Yeah, I'll paste the whole row. So look at it. I've pasted the whole row. So this is what I'm having. Sorry, since after inserting this is no longer necessary. Yeah, this is no longer necessary because this is row bin. So this is no longer necessary. So I'll click on it and delete it. I'll delete it. Not delete road. I'll delete it entirely. Yeah, I'll delete it entirely. I'll delete it entirely because I've inserted this. So I'll delete it entirely. So this is what I'm having right now. Then at this point, I'll come over to my 3D view to see what I've done. I'll come over to my 3D view to see what I've done. Let's wait for it. So this is what we have achieved so far. Yeah, this is what we have achieved so far. Hope you are seeing it. This is what we have achieved so far. Let's look for where's the front elevation. Yeah, sorry, this is the back. This is the back. This is the back. Yeah, this is the front. This is the front elevation. Let me also apply roof load on this. Yeah, let me also apply roof load on all this. So I'll come over to my plan view. Then go to story 2. I'll click on story 2. Then I want to apply a roof load on all this. I will not apply a roof load here because I've already applied a line load. So I will just leave here because I've already applied a line load to it. Then I'll click on this. Then if you are clicking on it, please hold your shift key. Sorry, hold your control key. Hold your control key and select select. Yes, hold your control key and select all of them. Hold your control key, select and select too. Yes, hold your control key and select everything. So I'll just hold my control key and select and also select. Then I'll deselect this. Yes. Then I will still hold my control key and select this and also select this. Then I'll still hold my control key, select this. I'm trying to apply a roof load. So I'll see hold my control key. Let me just select this. And let me just select it. Then I'll select this. Then I'll also select this. I'll also select this. I'll also select this. And then I'll also select this. Okay, finally I will select this. Yes, I think we have selected everything. Then I'll click on what? Paste load. I will escape. So let's go back to our 3D view to see what we are having. Yeah, see, we have applied a roof load on all of them. This is what we have achieved so far. But if you still look like here, yeah, this cantilever now, this beam now should pull out just like this. Yeah, it should pull out just like this. So it will cover this. Yeah, this beam should pull out. If you also go to our architectural plan, yeah, you see it here. Look at it. Yeah, look at it. Look at it. And also in story 3, is still pulled out. So in this story 2, it's still pulled out. So we are still going to pull it out. Then I'll come over to my ProtaStructure. I just want to show you before completing everything. Come out to my ProtaStructure. I'll come to my plan view. Then come over to story 2. I'll double click on story 2. So this is what I'm having. That means this beam, I will delete this beam. Yeah, I'm going to delete this beam. So I'll click on it. Right click on what? Delete. I'll delete it. Yes. Then I will not insert a new beam. So I'll double click on this beam now. To bring out its property. So we have a beam running from this point to this point. Yeah, then we have another beam. Okay, I also select this point. We'll have another beam running from here to here. Then we are going to align this beam now. We are going to align it. So we'll click on this. Then we'll click on what? Update. Yeah, so yeah, everything has been aligned. Then I'll come and delete this. Right click on what? Delete. I'll click on delete. Then I'll double click on this again. Once I double click on it, the east property will appear. Then I'll place a slab here. But if you check, there will be no wall load here. Yeah, this will not carry any wall load. Let's go and check so you see. Yeah, okay, we are having this here. So let me just delete this. So I'll do E, enter. So if you see, we are not having any wall load there. So there's no wall load there. Yeah, there's no wall load there. So I'm coming back. This is it. Sorry, my ProtaStructure. So this is it. So there's no wall load there. So we have modeled this thing perfectly. Then coming over to our 3D view, to our story view. Yeah, this is what we are having right now. So this beam now is now covering this. So in your modeling, please be patient. The reason why I'm a little bit fast in all these things is because this is a YouTube video, and I don't really want this video to be too long. Yeah, I don't want it to be too long. Yeah, so that's why I'm really fast. But if it's a personal drawing now, I will calm down and do everything. Make sure that I have a perfect work.
If you are a structural engineer, this is for you. Most structural engineers are taught plenty of theories in school, but here is the truth. Theory alone don't design a safe structure. You have probably heard, just follow the code and it will work. But get this, even with the code, many engineers still struggle to produce professional structural drawing. That's exactly why I created a 10 days intensive structural design and detailing masterclass to show you step by step how real structural design is done in practice, and this course is designed to last for 10 days. Before I show you what you are going to learn, this is the architectural plan we'll be working with, and we will carry out its structural design and detailing. Day one of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about path-based footing detailing. Day 6 column detailing. Day 7 beam detailing. Day 8 slab detailing, and you will understand the governing principles in slab reinforcement, that is how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10, you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan, and finally you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally access to our online engineering community, where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course now.
This video will all be about analysis and design. Yeah, we're going to analyze the column, the beam, and the slab, and design all of them. Even the foundation. Yeah, we are going to design the foundation too. It will all be done in this video. Please don't forget, we have done this. We have done the structural framing of this building. Yeah, we started from the architectural plan. We did the structural framing, and we also did the modeling. If you watch the modeling, you get to learn how we apply this line load. Yeah, look at this line load. You get to learn all of them. Yeah, these are the things you are going to get. You learn once you watch the model. You get to learn all this and how we're able to model this, and we're able to model this and even apply this floating cone, and also apply this hidden beam or stiffener. Yeah, so right now it's all about analysis and design. So in your analysis and design, the first thing to do is that you come over to this tab, analysis tab. You click on it, then you click on what? Building analysis. So let's wait for this dialog box to appear. So look at it. In this building analysis, the next thing you're going to do is to first of all edit your materials. Yeah, I'll come and click on edit material. So I want to start by editing my concrete, the grade of concrete that I will use. So I'll click on it, click on one of them. So the grade of concrete that I would like to use here is what? Grade 20 to 25. So if you check it here, you'll be seeing what? Grade 20. That means the grade of concrete you're using is what? Grade 20. Why? If I click on this, you see here is what? 25. So I want to use grade 20 for this structure. So I'm using the concrete of what? The concrete grade of what? Grade 20. Then I'll click on this, apply to all members, and then click on what? Okay. Then at this point, everything has been changed. Then I want to also alter the grade of my steel. So I'll click on it. I want to alter the grade of steel. The grade of steel I would like to use here is what? Grade 460 type 2. I would like to use grade 460 type 2. Yeah. But in your own, okay, grade 460 type 2. In your own, as me, you are used to concrete, as me, I used to T, or okay, me, not me, I'm used to T, but as me, I used to Y, like the symbol Y. concrete, in your steel, you can just change it to what? Y. Yeah, look, you can just change it to Y, so that once it's printing your drawing, once you are generating your ProtaDetail, everything will be in 2Y20, 3Y20. But me, I prefer to use T. So I'll change it to T because I prefer 2T20. Yeah, it just depends on the one you prefer. Then I prefer this. Then I'll come over to this point and click on what? Apply to all members. Then look at this label diameters. I'll come and click on edit. I'll click on edit. Then for my columns, I want to use only Y16. Yeah, I want to use Y16. I don't want to have any other column, so I'll leave only Y16 checked. I want to use only Y16. Then for my shear wall, I don't have any shear wall in this design, so I'll leave it. For my beam, I also want to use only Y16. Yes, I don't want to have any other one. I want to use only Y16. Then for my slab, I want to use only Y12. I don't want to use any other one, so I'll just check only Y12. I don't want to use any other one. I'll uncheck the rest. Then for my lip slab, I don't have any lip slab, so I'll leave it. For my foundation, I like to use Y16 and Y12. Yes, I would like to use Y16 and Y12. The combination of anyone that passes, it will go with it. Y16 and Y12, because you know that some part is one-story building, while some part is two-story building. So I believe that in those parts, that is one-story building, Y12 should pass. Yeah, Y12 should pass. Already the software gives us Y20, then we'll go with already the software gives us Y16, then we'll go with Y16. Then for our links, I want to use Y10 for our links. So I'll check only Y10. I want to use Y10 for our link. Then this one are for shear walls. Yeah, this one's are for shear wall, but I don't have any shear wall in this design, so I will leave it. So with this now, I'll just come to this point and click on what? Okay. I'll click on OK. I've checked this, and then I'll come over to this point and click on OK. So if you see everything has been properly dealt with or corrected, then I'll come over to foundation. First, look at it. Soil type. You click on it. Then from my soil report, the soil type we're having is what? Sand. Yeah, we found sand at a depth of 1,200. Yeah, and our foundation, the strength of our bearing capacity is what? 200 kilonewton per meter square. That's our bearing capacity. So right now I'll select was sand. I'll click on what? Okay. Then look at foundation, the concrete grade of foundation. I'll select use what? Y20. Yeah, I'll still like to use grade 20. So I'll check this and then click on what? Okay. Then for the steel grade, I'll still like to use this 460 type 2. Then if you click on this, you see everything has been edited. So I'll click on OK, and then I'll still click on what? Okay. Yeah, then I forgot to click apply to all members. Then you click on this grade 500. You click on this one. I'd like to change it to what? 460 type 2. Yeah, then okay. I'll now check this. I'll then click on what? Okay. So this is what I'm having. I've done my setting accurately. Then I'll come over to this one and click on what? Okay. So if you see all the settings I've done they now appear here. They are not appearing here. So right now, the next thing that I would like to do is to go and do my spacing, all the spacing. Now I've chosen the concrete grade, the steel grade, and everything. Right now I want to do for spacing, like the slab spacing and the rest. I'll click on this setting. Once I click on setting, then I'll come over to this. Then I'll come to my I want to go with beam first. Do you want to master structural design in just 10 days? I created a course where I carried out the full structural design of this residential building step by step. In this course, I broke down everything you need to know about structural design, starting from the fundamental engineering principle all the way to the practical detailing. Honestly, it is far more in-depth than anything you will find for free on YouTube. And think about it, if my free lessons are already this good, just imagine my paid courses where I poured out all my knowledge and real-life experiences. This 10-day structural design masterclass is all you need to become a confident and competent structural engineer. And the best part is, it is affordable because I consider that most of you are still students. So click the first link in this video description and access the course. I'll click on beam. Then in this beam, okay, for this design, everything here I want to leave it as default. This is not my main. This is not where I want to go to. So here, this is where I want to go to. So look at it. The minimum steel type we have is what? T16. Why the maximum is T16? Because I chose only T16. That's why I'm having this. Why the minimum hanger bar diameter is what? T16. Why the minimum number is what? The minimum number is what? 2. Okay, what was the hanger bars? Let me just give you a quick explanation. But don't forget, if you want to go deep into structural design and detailing, yeah, I created a course, 10 days intensive structural design and detailing masterclass. the thing I want to explain now is also in that course. So in fact, most of the things I don't really explain on YouTube because of time constraint, because I'm looking at time. All everything are being explained in that course. So I will advise you get the course and know it well. So what is the minimum number? What do you mean by hanger bars? You know that concrete is very weak in tension and very good in compression. And two, in a simply supported beam or in beams, mostly in beams, the bottom is at tension while the top is at the compression. So what it means is that the only place we need to reinforce is just the bottom. That we only need to reinforce the bottom. We don't need to reinforce the top. But we cannot just reinforce the bottom. We still need steel at the top, because we are going to provide stirrup for shear. We are going to provide stirrups or rings to counter shear. So for that reason, if you are providing stirrup to counter shear, that means there should be a bar at the top. So that's why that bar at the top is not really useful, but we call it hanger bars because it is not really useful. We are just using it to hold the bottom bar together and also to hold the stirrups together. So it's not really useful. That's why it is called the hanger bar, and it is at the compression zone. Remember, concrete is very good in compression. But if you want to learn more of this thing, or if you want to understand it the way I explained it very well, because in that course I calm down and explained everything, get the course. Yeah, it's very cheap because I consider that the fact that most of you are students. So look at it, the minimum, okay, ring diameter, we show that the minimum is this, the minimum is this. So everything here, we are good to go. We are good to go. We are good to go. Okay, look at it, the minimum ring spacing. The minimum ring spacing is what, 300. Yeah, from the code. From the code. This is from the code. The maximum, not minimum. The maximum spacing in the code is what, 300. Both in your slab, both in your pad base, both in your anywhere, the maximum. Please don't ever go beyond 300 in your spacing. That's from the code. Yeah. So even if after design you got that the spacing is 400, the code says stick to what, 300. Yeah, you must stick to what, 300. So that's the code. That's from the code. Then the next part that I would like to go here is what, rebar pattern. Then rebar pattern. The rebar pattern that we'll be using here is what, standard pattern 5. Standard pattern 5. Don't worry, you still get to understand this more during our interactive design. So that's the rebar pattern we are going to be using. Then the next one we are going to be using is we'll come to curtailment. Curtailment. Yeah, that's the next part. Curtailment. This bob control. Then I would like to have this. I would like to use this one. I would like to use this one. Then the next one, the next thing that we'll be doing here is what, detailed drawing. I would like to come over to section. Then in this one now, the number of section, I'll click on all beams. Yeah, I'll click on all beams. Then I'll click on span only one. Yeah, I'll click on this span section only. Like to be once, I'll click on all beam and then click on span section only. Don't worry, when we get to detailing, you still understand all this. Then at this point, the next thing, the next place we're going to is steel bearings. You will click on steel bearing. Yeah, steel bearing. This is like this. I would not like it to be like this. Hey, I've forgotten. Yeah, I'll uncheck this. So this is like it. Then this ring now is on this. I would like it to be outside. So I'll click on this. I'll click on this. Yeah, so to bring it outside. So this is how I like my own to be. So it depends on the engineer. Some people like their own to be inside, but me, I prefer what, outside. Then I'll click on what? Okay. I'll click on okay. I'll click on okay. So right now, okay, I forgot to do slab. I forgot to do slab. So I'll come back again. Everything here has been said. Then I'll come over to slab. Then come over to slab. I'll click on what? Labor. I'm more interested in what? Labor. I'm more interested in labor. I want to change this spacing to what? 200. I want to change this spacing what to 200. Yeah, I want to change. I want to even after design. For me, even after design, and the software is giving me 250. And the software is giving me 250. I'll still stick to what, 200. Yeah, I'll still, because most of the time after design, the software will be giving you 250. Me, I still stick to what, 200. Reason is because in this country where I am, which is Nigeria, they tamper with quality. Yeah, people are trying to make gain, they are trying to make profit. So their Y16 is no longer Y16. Their Y16 might be Y14. And also the yield strength that we use, which is what 460. If you go to the lab and check the strength, you might be getting 300. You might even be getting what? You might be getting 380, 400. So it's not up to what, 460 again. So for this reason, even if software should give me 250, I'll still stick to what, 200 to prevent building collapse. But all these things are way detailed in that paid course. So get the paid course and learn more. Yeah. So with this now, I think I'm through with all my settings. So I'll click on what? Okay. Then I'll come over to analysis again. I'll come over to this analysis again. Come over to building analysis. Then right now, assuming our building is more than 10 meters, yeah, we'll apply wind load. But if you see now, if I click on this wind load calculator, it is not clicking. Look at what it's showing me. Reason is because that time when we are generating load case for slab, yeah, we not check that wind load, we not tick it, yeah, we not check it. So that's why it's not appearing. But assuming we checked it, then I will just come out to this point and apply the wind load. So with this. But if you want to learn how to apply wind load, you can equally get the course, because I also explain all of them there, or you check one of my YouTube videos. I've also explained in one of my YouTube videos. So right now I'll click on what? Okay, so right now we are through with everything. I'll come over to analysis, then I'll write to rerun my building analysis again to be sure that I'm still free from errors. So I like to rerun my building analysis again. So at this point, as you're seeing, so number of errors, let's check. Okay, number of errors, look at it. Building model check completed, number of errors 0. So I'll still click on what? Cruise. So right now we are going to be doing what? Building analysis. So we are doing building analysis. So let's wait for it to appear. So at this point, we're having what? Column and wall reinforcement, beam reinforcement, and everything. So we don't have anything concerning steel, so I'm not going to check this. So right now, I'll check this and check this. Yes, sorry. If you do not check any of them and just click on building analysis, that means you want to analyze first. Then after analyzing, you now design. But in this case, I want to analyze and design at once. Yeah. If I just come over to this point and click on this, that means I'm analyzing a rule. I'm not designing, but I want to analyze and design. So I'll click on this and also click on this. Then if you have not run analysis before, if this is your first time of running analysis on that project, you click on this reselect bar. But if you have done interactive design and you want to rerun analysis, but you have done interactive design, please don't click on reselect bar, because if you click on reselect bar, all the things you have done in your interactive design, all of them will scatter. It will scatter everything. So don't click on it if you have done interactive design before. But if you have not done interactive design, just click on reselect bar, then come out to this point and click on what? Building analysis. I would like to use this opportunity and tell you about our paid course, which is the 10 days intensive structural design and detailing masterclass. That class or that course is a course I'll advise you to get, because I really went in depth in everything, in the explanation and in everything. In these YouTube videos, we are constrained by time, because if people look at the rent, they might not really watch it. But if you get the paid course, I explain everything in detail. In fact, all my practical knowledge and all my theoretical knowledge, I was able to explain all of them in that paid course. So this is an investment that I'm very sure that none of you will regret. And two, the thing that is very, very cheap. That paid course comes with a lot. Yes, it comes with my personal that stone bridge 10 template that I personally use.
If you are a structural engineer, this is for you. Most structural engineers are taught plenty of theories in school, but here is the truth. Theory alone don't design a safe structure. You have probably heard, just follow the code and it will work. But get this, even with the code, many engineers still struggle to produce professional structural drawing. That's exactly why I created a 10 days intensive structural design and detailing masterclass to show you step by step how the structural design is done in practice, and this course is designed to last for 10 days. Before I show you what you are going to learn, this is the architectural plan we'll be working with, and we will carry out its structural design and detailing. Day 1 of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests, but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about part-based footing detailing. Day 6, column detailing. Day 7, beam detailing. Day 8, slab detailing, and you will understand the governing principles in slab reinforcement, that is how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10, you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan, and finally you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally access to our online engineering community, where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course now.
So now we are now in column reinforcement design. Yeah. So we are through with the analysis. We are through with the analysis. So now it is now in column design. So it's designing our column for us. Yeah, our column is being designed for. So remember, get the CAD file and practice. Get the CAD file and practice. If you're able to get the modeling of this building, I bet you there's no building that you'll not be able to model accurately. Yes, there's no building that you'll not be able to model accurately. And also get the 10 days intensive structural design and detailing masterclass. Yeah. And also the advice I'll give to every young structural engineer is practice. Practice. That's the only advice I'll give to any young structural engineer. Practice. That's the only advice. Practice at least 30 minutes daily. Make it a habit. 30 minutes daily. You will get good by doing that. So let's wait for it now. It's now in beam reinforcement design. We are through with the analysis. Okay, right now I'd like to explain what is different between analysis and design. Yeah, there are two different things. They are not the same thing. Analysis is a process whereby you are analyzing the forces acting on a member. Like you are trying to determine the forces. You are trying to get and know the forces acting on a member. While design is that you are trying to provide reinforcement to counter those forces acting on that member. So that's the difference between analysis and design. So right now we're almost through. Yeah, we're almost through. Look at it. Building analysis successful. So let's wait for it. So that's the difference between analysis and design. You can get the paid course and learn more of all these things. So I'll just pause the video and wait for it. So right now, this is what is happening. Okay, look at it. Relative story drift. Look at it. I'll explain something here. Relative story drift satisfies the limit. Good. So we are good to go, and we're also good to go. But if you are seeing bad in your own and bad in your own, please, what you are going to do is that is either you go back and increase the section or increase your column section. That's the dimensions of your column. As when you are using 225 by 225, you can go to 225 by 300 or 225 by or 230 by 230, any of them, or 250 by 230, any of them. But increase your column size, or you increase the number of columns. Yeah, you increase the number of columns. That means you go back to your structural framing and add more columns to that building, so it will pass. Please don't ignore this. Yeah, I'll click on okay. So right now everything, let's see what we are now having now. So at this point I'll click on what close. So if you can see, look at building analysis. It has been checked good. That means we have analyzed this building and we have also designed this building. So right now we are going to be doing interactive design. So but first let's check whether our members passed or not. So I'll come over to this display. Come over to display. Come look at visual interrogation. I'll click on visual interrogation. Let's wait for a dialog box to appear. Then I'll come over to this part. Look at design status. I'll click on design status. Then click on what? Okay. So let's wait for it. So if you can see, most of our members are passing. But I would like to explain something to you. Look at if you are seeing lead. Let's check whether we're having lead anywhere. Let's shake. Okay, I think okay. We are okay. All our members pass. Okay. Look at red. We're having lead. Oh, this beam. Oh, this thing failed. It failed. Look at it. It's red in color. So that means when we do our interactive design, you get to understand everything. But if you are seeing lead, that means it failed. If you are seeing yellow, that means it's warning. Green means that it passed. Why this orange means expired analysis. Why white means that you have not yet designed this. So if you look at our slab, they are all white in color. Yes, because we have not yet designed our slab. So that's what it means. So right now we'll be moving. Let me go over to my plan view. I'll go over to plan view. I'll click on plan view. So if you see now, okay, let me turn on my design status again. I'll turn on my design status. We are going to be doing what is called interactive design. Please, even if all your members passed, please make sure you carry out design status. Yes, you see, don't worry. As we start now, you see the reason why you must carry out design status, even if all your members pass. So first of all, I would like to start with this continuous beam. Okay, I would like to start with this continuous beam. Yes, I would like to start my design status with this continuous beam. So I'll explain a lot of things with it. So I'll click on section design. Yes, I would like to click on section design. Let's wait for it to open. Then this is what we're having right now. Remember, I told you, please, even if all your members passed, you must do your interactive design. So listen now, I would like to explain a lot of things. So these are the area of steel. Okay, these are the area of steel required. Yeah, this is the area of steel required. Why the one below is the area of steel what provided. The area of steel provided. So look at here. Here we require the area of steel 146. We require area of steel 146, but they provide 456, meaning that they provided excess, more than enough. That means that's what it means. This one is the area of steel required. So if you see, everything is passing. But I will tell you, we have three main failures in beam. First of all, it can fail due to bending, like bending moment. Yeah, it can fail in the bending moment aspect. For example, I'm having that. Wait, let me click on this. Assuming I'm having layer there, that means it is failing due to bending moment. Yes. Assuming I'm having layer there, it is failing. Sorry, let me. I'll increase by one. Assuming I'm having layer there, that means it is failing due to bending moment. What would I do in this case? What I will do in this case is that I'll come over to this point. I'll click on it. I will increase it. It is still failing. I'll still increase it. So this one now, it is now passing. 2y16 is now passing. Then the bottom aspect, it is still failing. I'll go to what? Increase it. Look at it. It is now passing. Okay, wait. I'd like to explain something. What does it mean? Okay, I told you this is the area. This is the area of steel provided. Look at it. Extra area. That means what this thing means, that we require 78.3. In this case, it means that you have provided excess additional 323 area of steel. What is required is what? 78.3, but you provided additional 300 and what? 83. That's what it means. That's this extra area of steel. So if it is failing here, it means that you have not yet provided enough area of steel. That means you need to increase this thing to provide enough area of steel to counter the moment coming on it. Because if you don't provide enough area of steel, you will not be able to counter the moment coming on it. So yeah, they're telling you provide enough area of steel to counter the moment coming on it. So this is what we're having, right? So this is the first failure that we're having. But I would like to advise you, please don't allow this place to be less than 100. Please don't allow here to be less. This is the area of steel, but don't allow it to be less than 100. Reason is because most of the I'm located in one of the African country, which is Nigeria, and here they tamper with quality. They tamper with quality a lot. For example, their Y16 will never be Y16. Their Y16 will be something like Y14 or thereabout. And also, we used a use strength of 460. That use strength of 460, if you go to the market, you not get the use strength of 460. What they will give you as 460, it might be 400. Like for example, there is one project I was working on. When we bought the steel, we went on a test. We went to test the steel. We bought Y10, yeah, for our stirrups. That's the raft beam, foundation beam, raft beam. So we bought Y10. So when we went to the lab, we saw that Y10 is 8 point something. The diameter is 8 point something. Then the use strength that we used to be 460, when they shake the strength at lab, we are getting 380 something. So for that reason, I will always advise you, please don't allow here to be less than what? 100. To prevent building collapse is advisable. So for that reason, I will increase this thing to 10. Yeah, please follow this instruction. Or else you are in all these European countries where they don't tamper with quality. For example, UK, US, all these European countries where they don't tamper with quality. Please, you still maintain with what is, you still go with what the software giving. But if you are in all the African country where they tamper with quality, please make sure you follow this now. I'm just saying right now. So in this case, I'm having 2y16 and 3y16. So here now I'm having what? Okay, I'm having here 3y16. But if you see, okay, let me reduce this thing because this thing is more, is excess. So I'll reduce it. So if I listen, I'm having 52 and 91. So I'll still increase it back. Yes, I'll still increase it back to what? 3. So in this case, I'm having this. Let me try and reduce this. So if I reduce this, okay, if I reduce it, that means I'm still good to go. I are seeing it, I'm still good to go. I'm also come over to this one and I'll reduce this. I'm still good to go. I hope you are seeing this. It's still above 100. The top one is still above 100. That means I'm still good to go. So everyone is 2y16. So this is why you should do your interactive design, because software will sometimes give you 3y16 instead of 2y16. So I'll come over to this point. I'll still reduce it. So it's still above 100. So I'm good to go. I'll leave it as 2y16. Please do your interactive design. It is very, very necessary. This one I'll still reduce it. Yes, it's still less than 100. So I'm still good to go. You must do your interactive design. I'll still reduce it. It's still less than 100. This web bar is not needed. I will remove web bar. That's why you should do your interactive design. I'll remove this web bar. So this is what I'm having right now. Yes, so here we brought 3y16. Why here we brought 2y16, and here we be okay. Wait, let me move to the extreme. Okay, okay. Here will be 3y16. Wait, we are not at the extreme right now. So let me move to the extreme. So 2y16, 3y16. But in this case, look at. Please do this now. I want to do now. Look at what I want to do. They are giving me 2y16, 3y16, and 2y16. Please don't arrange your bar like this. Yes, it is not that it is not. It's not that it will fail. But look at a proper way of arranging your bar. I'll remove this. I'll click on this. Then click on what? This is light. I'll click on extend lights to lap. I'll click on extend light to lap. I'll click on it. It will extend. Then I'll also click on this one. Then click on extend left to lap. I'll click on extend left to lap. It will also lap. Look at it now. I'm still having 52 and 92. Then I'll come over to this point and what? Increase it. Look at what does this thing mean now? It means that this 2y system will run through. will run through. Then at the bottom, then you now come and provide one additional bar. But if you don't make it like this in your detailing, don't worry, you still understand it more when we get to our detailing. But please make sure you detail like this. Make sure you make your bar like this. Don't use that formal one. Yeah, because we'll be having two Y system that will run straight. It's not that we'll come over to this point, have two Y system, then two Y system will stop here. They will not input a new 3Y system. No, it is not like that. We'll have two Y system that will run straight. Then at this point, now add additional what Y system. Hope you understand. I hope you are following. So this one, you still leave it like this. So this is the first failure, which is the bending failure. You just increase your steel. Yeah, you just increase what? Your steel. Then the next failure that you can obtain is a failure due to what? Shear. Due to what? Shear. For example, let me give an example. Let me know whether this okay. First, wait. Let me explain this area. Let's leave that shear. Let me explain this one. So this area now, this failure now is what? Is failure due to what? Spacing. Due to what? Spacing. Let me increase this thing by one more. So okay, let me also increase it by one more. Let me just increase by one more. So this failure now is failure what? Due to what? Spacing. It is due to what? Spacing. Let me go over to let's come over to our detailed drawing so you understand this failure of phase. So you understand this thing first. So I'm having 19 here. Take note of this. So 19. So let's come over to our detailed drawing. We're having 19 here. Please pay attention. So I'll explain all this thing to you so that once you are doing your design, you know what exactly you are doing. So you not be confused or you not be doing guesswork in your design. Let's wait for it to open. So it has opened. Then I'll look at I'll explain this thing. So that 19 you saw means that the spacing between these two bars is 19. The spacing between these two bars is 19. That's the meaning of that 19 that you saw. The spacing between these two bars is what? 19. But the coarse aggregate that we normally use on site is what? 3/4, which is 20 mm. 20 mm. So even if you are seeing length, even if you are seeing red there, but that thing is above 20. Yeah, you are good to go. But if okay, don't worry, I'll explain. So you have understood that lead means that the spacing between these two rebars is what? 19 mm. So let me go there and explain everything more now so you understand better. So so look at it. Even if you are seeing here, so this is 19, so this is less than 20. Remember, our coarse aggregate, which is our gravel, is what? 20 mm. The one we normally use, yeah, is 20 mm. So since this now is less than what? Since this is less than 20, what you are going to do is that you come over to this point, you decrease it, so it is now 23. We are still good to go, but I'll still like to decrease it again, and I'll still like to decrease it again. What I will now do now is that I'll come over to this bottom one and increase it. Yeah, I input it at the bottom. Yes, I input it at the bottom. Yeah, it will stay past. So right now it is no longer what? Showing lead, but still it is still what? Passing. So once it's showing lead, make sure that it is not less than 20. But if it is less than 20, you reduce it and then come over and put it as a bottom bar. Hope you are following. With this section. Yes, remember, get my paid course. My paid course is more variable. All these things are well detailed there. Everything is well detailed there. So this is another failure that you can see, which is failure due to spacing. Another failure that you can see is what? Diffraction failure. Yeah, if it fails in what? Diffraction. Let me explain something to you. If your beam fails in diffraction, it doesn't mean that structure will fail, or it doesn't mean that beam will fail. What it means is that beam will deflate while carrying the load. Yes, it will deflate while carrying the load. But know that it will deflate while carrying the load. You know that it will now start causing cracks on your block wall. Yeah, it will now start causing crack on your block wall, which will now make the people living in that structure feel uncomfortable because they are not seeing cracks on block wall. So even if it fails, please make sure you correct it. But it doesn't mean that the building will collapse. The only thing that will make the building to collapse is that if you have not provided enough area of steel, or if you do not design against shear wear. These are the two things that can cause a building to collapse. That's if you do not provide enough area of steel, or you do not design against shear. But if it fails in deflection, it means that it will deflate while carrying the load because you have provided enough area of steel. So if it fails in deflection, what you are going to do is that the solution to is that you increase your beam depth. Yeah, look at how to increase your beam depth. You come over to this beam, you come over to this point, you come over to the point, and then increase your beam depth. That if it fails in what? Deflection. Remember, if it fails in deflection, it doesn't really mean that your structure will collapse. No, that's what it means. It means that it will fail in what? It means that it will deflate while carrying the load. Let's wait for it. Let's wait for this thing to load up. So look at it. You just come over to this point. Look at it. Let's come over. Look at this. Where is that? Okay, look at our depth. You just come and increase the depth of that one that failed in deflection. So that's how to go about it. But it is not failing in deflection. I just told you about it so you get to know it. Then another failure that you can experience is if it fails in shear. If it fails, what do you mean by shear? Shear means sudden break or sudden slide. Yeah, that is shear. If it fails in shear. So how will you know that your beam is failing in shear? Is through the spacing. Is through the spacing. If you are seeing lead in this spacing, if you are seeing lead, that for example, as me I'm having lead here. If I decrease this spacing now, you start seeing lead. But as me I'm having lead in my spacing, that means it is failing in shear. Please don't allow your structure to fail in shear, because it means that it will just slide all of a sudden slide. So if it's failing in shear, what are you going to do? Is either you decrease your column wall spacing. Look at it. Right click on it again. Is either you decrease your column spacing by clicking on this. Yes, by clicking on this and decrease your column spacing. And after, even after decreasing your column spacing and it is still failing, then the next thing that you're going to do is that you increase your beam depth. Yeah, that's the next thing. You come over to this point again and increase your beam depth. After decreasing your spacing, and if it is still failing, you now go and increase your beam depth. Hope you understood everything I've explained now. I've wasted time in this, so I'll not really go deep into other ones. But with this now, you can do others. So I'll click on OK. I'll just still do two more because I'll not like the length of this video to be. I'll not like this video to be lengthy. You can get my paid course. Yeah, in my paid course, I'm not looking at time. I explained everything in detail. So I will still like click again. Click on what? Section design. Let me do two. After this one, I'll do one more again. I'll click on say I don't want this bottom bar, so I'll remove it. I don't want, so this is a web bar. I don't want this web bar. So here I'll first of all decrease it. This is why you must do your interactive. Then everything here is 3x16. So I'll first of all decrease it to 2x16. So I'm having, okay, this one is above 100. This one is above. This one is below 100. So we'll see know what to do about it. But let me just leave it like this first. So let me just decrease one to 2x16. I'll decrease it 2x16. 2x16, okay, is now below. That means I have to increase it again. Yeah, I have to increase it again. Then this one I'll decrease it to 2x16. All of them are above 100. I'm okay with it. I'll decrease one to 2x16. All of them are above 100. This is 2x16 already. I'll still decrease this to 2x16. All of them are above 100. I'll decrease it to 2x16. All of them are above 100. I'll still decrease this one to 2x16. So it is failing. So what I'll do now is that I'll remove this one totally. Then I'll click on this one. Then click on extend light to lap. Click on what? Extend light to lap. I'll click on extend light to lap. Then I'll also come to this one, click on this one, extend left to lap. I'll click on extend left to lap. So look at what I'm having right now. Then I'll now come over to this support bar and increase it by 1. So it is still failing. It is still less than 100. I'll still increase it by 1 more again. So I'm good. This is good. I'm good with this. So this is what I'm having. Please do this to prevent building collapse. So this is what I'm having right now. Then I'll click on what? Okay. Then I'll still do, let me do one of the horizontal. Let me do this one. After I'll now come and do this one that failed. Yeah, let me do this one. Let me do this. I'll like click on what? Section design. So let's wait for it to open. Then I don't want this web bar. So I'll remove web bar. Then I'm having this, so I'll decrease it. 43. That means I have to be 3. Then I'll come over and decrease. I'll come to this and decrease this. I'm good to go. I'll come over and decrease this. I'm good to go. All of them are above 100. I'll come over and decrease this. I'm good to go. I'll come over and what? Also decrease this. I'm good to go. I'll come over and then decrease this. I'm good to go. I'll come over and then decrease this. I'm good to go. And also I'll come over and decrease this. It is failing. I will just remove it totally. Then this one I will just click on extend right to wrap. Extend what? Right. I'll extend right to wrap. And then the second one I click on extend left to wrap. Then it is still failing at this point. Then I'll come over to this point and then increase it. Yes, it is now passing. So this is what I'm having. Then I'll click on what? Okay. Yeah, I'm through. On your own, you can do the remaining or you get the paid course. Everything is very detailed there. Then I'll come over to this one. I'll click on this. Right click on what? Section design. I'll click on section because this one, if you see that, okay, look at it. It is failing in what? Share. It is failing in share. So I'll click on this. So let's look at it. Is failing in, okay, it is still failing in share. Remember, this spacing is already 80, so we cannot do anything about it. So what we're going to do now, we are going to increase the depth. If you can remember, this is that hidden beam that we introduced. Yeah, remember I told you it's just to carry the column, and we told that I don't really need it in real life. It can really sit on slab. Yeah, it's just because ProtaStructure will not be able to carry out analysis and design if I don't input a beam under a column. So that's why I inputted that hidden beam. So in this case, what I will just do is that I'll just come over to this beam and then increase it. I would like to increase it by 175. Yeah, I would not like to go too much because I would like it to flush with the wall. So I would like to increase by 175. Then come over to this. Okay. Sorry. Wait. I would like to increase it by 175. 175. You click on another thing. Oh, this is not 175. This is not 175. Like 175. Then you click on another thing. you click on another thing. So look at it, 175. Then I'll now come over to my what? Reba. Come over to my Reba. Look at it, 175. It's still failing. It's still failing. So what I'll do now is that I'll also come over to my beam. I'll increase it to, let me increase it to 250. 250. Then I'll click on this. Then click on Reba. It is now passing, but I know 200 might have passed it. 200 might pass it. It might pass in 200, but I just increased to 250, so I'll be faster. But inside, I'll still use 150. Yeah, because I told you that this thing can sit on slab. Yeah, inside, I'll still use a stiffener. I'll make it a slab stiffener. I'll still use 150 aside. So I'll click on okay. I'll click on what? Okay. I'll click on okay. So with this thing now, on your own, you can do the rest because of time. Yeah, because of time. Or you get the paid course. All right, click on what? Section design. Click on section design for coding. Let's go to coding. Let's deal with coding. So first of all, utility ratio. This utility ratio is very important. It should be less than 1. So this one is less than 1. We are good to go. 225 by 225. We are good to go. 4y16. We are good to go. So all the software, this source is what? Is okay with us. You first of all check utility ratio 2y16, 2y16. You can see, click on this red bar and then click on interactive design again to see this. So let's wait for it to appear. Look at it, 4y16, and 2. Please make sure, look at this now. Short column. Okay, make sure that this thing is less than 1 and this thing is less than 1. This two. Okay, I like to explain something to you. We have two types of column. We have a short column and a long column. Yeah, get the paid course. Get all these things. Remember, it's just as I'm doing. If I remember, I will explain. But if I forget, I might just see. But all of them are well detailed in the paid course. So we have two types of column. We have a short column and we have a long column. Short column fail by squashing or crushing. They fail by crushing, like they fail by all of a sudden. Why long column? They fail by buckling. Yeah, the long column, they fail by buckling. That means they will buckle or they will bend to one side. Why short column? They will just squash. So this column now, the software is telling us that it is a short column. So make sure that this thing now, make sure that this is what? Less than 1. Yeah. If this is less than 1 for long column, what it means that it will buckle while carrying the load. Yeah, for long column, it means that it will buckle or it will bend a little bit while carrying the load. It doesn't mean that it will fail. It only fails if you have not provided enough reinforcement or you have not used enough syrup or enough links. That's when it will fail. But if it fails in this area, it means that it will buckle for long column while carrying the load. Why for short column? What it means that it's not that it will crush, but it will look as if it's crushing. That means you start seeing cracks on your concrete. Yeah, you start seeing cracks on your concrete. Remember, those living on it will not really feel good there. So it's advisable to make it less than 1. Yeah, even if make it less than 1. It is because there are some situations where we see that we cannot really make this less than 1. Then there are some principles that we do apply. Yeah, but that one is for senior engineers. If you are a young engineer, please don't apply those principles till you get enough experience. So with this now, I'll just click on what? Okay. So make sure it's less than 1. This is what I'm having. This is what we're having right now. Then I'll also come over to this point and then click on OK. So I would like to shake one more column, and I will be done because of time. I'll shake one more column because of time. Then on your own, you can get the cat file and then go through all of them. So this 2y16, utility ratio is 0.5. I'll click on what? OK. So right now, what I will do is that I would like to go to my building analysis and also explain something using those building analysis. I would like to look at the building analytical model. So I would like to go to my building analytical model and then explain some certain things because I'm here to equip you with the right knowledge. So I would like to explain some certain things. Do you want to master structural design and detailing in just 10 days? I created a course where I carried out the full structural design of this residential building from start to finish. In this 10-day structural design masterclass of this residential building, we carried out the structural framing, modeling, analysis, and design every structural members. We analyze the forces acting on them and design reinforcement to counter those forces. From there, we move into foundation detailing, part-based detailing, column detailing, slab detailing, even staircase detailing. We also sectioned and detailed our staircase and slab. And finally, I showed how to print and present your drawing professionally. This course is highly in-depth because I poured out my knowledge about structural design into it. Honestly, it's more in-depth than all the free structural design videos on YouTube. And think about it, if my free lessons here on YouTube are already this good, just imagine my paid courses. This is all you need to become a confident, competent structural engineer. It is an investment you will never regret in this life, because remember, the greatest investment with the highest return is the one you make on yourself. And the good thing is this course is highly affordable, because I consider the fact that most of you are still students. The link to this course is in this video description. It is the first link you will see. Go and enjoy every bit of the lesson. Do you want to master structural design in 10 days? This course will get you there. So this is what we're having in our analytical model, but this is not my main point of interest. My main point of interest is this solid model. I would like to explain some certain things with you using this solid model. So please listen and listen well. So coming to this, let me zoom well. Coming to this solid model, look at it. The ones on blue means that they are carrying a load of about 319 kilonewton, while the ones on lead mean that they are carrying a very low load, which is as low as 28, 0.8, 57. That means the ones on lead, they are carrying a very low load. And if you look well, you see that it is these ones at the top, that are carrying, that are on lead. Yeah, these ones on top, they are the ones on lead because they are carrying a very low load. What they are carrying is mostly roof load. Yeah, they are carrying mostly roof load. Why these ones beneath? Why these ones under? They are the ones that are blue in color. Look at them. They are the ones blue in color because remember, okay, they are carrying a very high load. Let me tell you, for load transfer, this column now, okay, let me use this column now will carry the loads from slab coming to it. So okay, this for this column now, this beam, all the beams surrounding it will transfer its load to the column. Yeah, to the column. Remember, the slab will transfer its load to the beam, while the beam will transfer, while all the beams on this column while all the beams connected to this column will transfer its load to this column. Then this column now on top will now transfer its load to this bottom column, while this bottom column is still carrying the load from the beams surrounding it. Do you understand? So that means this bottom column is carrying the load from the column on top, and also from the slab from the slab and beams it is being connected to. So that's why load transfer is being transferred downward. Like if you are designing, we design from the top downward, because after designing the top, that's manual design. After designing the top, you transfer each load to the bottom. After design to the one below. After design the one below, you transfer each load to the other one below. So that's how it is done. So that's why mostly the ones on blue are these ones under. Yeah, they are these ones under. Because they are carrying the load from the second floor and the first floor. Yeah, they are carrying the load from second floor and the first floor. So what I will do now is that if these ones on blue should pass, if they should pass under 4y16, that means the rest will pass under 4y16. So what I will do now is that I will just come and check on this. Look at this one. This one carrying the heaviest load. This is the one on blue. This is the one that the blue is very thick. So I'll just check this column. Once I check this column, I'm through. But on your own, please check all of them. It's just because this is a YouTube video. So that's why I just want to be fast. So I'll just check only this one. Look at this one. This one is in our front view. Okay, this cantilever. So let me go and locate it. So I'll come over to my plan view. I'll come over to my plan view. I'm still at study 1. That means it is this column. Look at it, is this column. So I'll click on it, right click on what? Section design. I want to shake this column. If this column should pass, that means I'm good to go. Okay, look at it. It's passing 2y16, 4y16. It's 4y16 and the utility ratio. If you see the utility ratio have increased. Before we are seeing 0.4 and 0.5. Why this one is what? 0.63. Yeah, because it's carrying it's carrying a load. It's carrying, let's say, a heavier load. Yes, it's carrying a heavier load. So the utility ratio now increased, because the more the load, the more the utility ratio. But please don't allow your utility ratio to be above 1. So I'll click on what? Okay. So right now, the next phase we'll be going into now is what? It will be going into our what? Slab design. Yeah, we will be designing our slab. What we'll be now is slab detailing. Yeah, we're going to detail our slab. But first of all, let's just come over to 3D view. So this is what we have done so far. This is what I've been able to achieve so far. Yeah, this is what I achieved so far. So wait, I would like to turn on, I would like to go, okay, let me go back to my plan view. Yes, let me turn this to my just normal. Yeah, I'll take it back to normal. Yeah, so I'll click on okay. So this is it now. This is where we are now. So I want to start my slab detailing. So to do your slab detailing, you come over to modeling. Then you come over to slab strip. You click on it. Once you click on it, look at this is S direction and this is Y direction. S direction means in S direction, Y is what? In Y direction. So I want to deal with S direction first. So these are the boundary conditions. Don't worry, while you are applying this, you're going to understand all these boundary conditions. So but first, this first one is for cantilever. Yeah, this one is for cantilever. Why this one is for the end of a beam. end of a beam that has no slab continuation. Yeah, for example, this area there's no slab here, so I'll use this boundary condition because there is no slab here. Why this one is for a continuous beam or a continuous slab where there is a slab continuation. For example, this beam now, as me I want to stop here, I will use this boundary condition because this is slab, this is a slab, and this is a slab, meaning that there's a slab here and there's a slab here. Why in this one, this is a slab and there is no slab here? In this case, that's in this case, this is a slab here and there's no slab here. Why in this one it's just a cantilever? This is a cantilever, so don't worry, you get to understand. So I want to run a slab strip across this now. So if you look, I'm having a cantilever here and a cantilever here, so I'll pick this and then this, then I'll run it. I'll click on this. Once I click on this, I'll hold my control key, click on my control key and click on this one. So if you see, it has provided reinforcement for us. T12 at 200. Remember, we use our maximum spacing as 200, so that's why I having 200 here. So T12 at 200. But even if you don't change your, even if you don't use maximum spacing at 200, if you're having 250, please still use 200. Yes, because of all this, because of lack of quality. Yeah, because of quality, in this African country, they do tamper with quality, so still use 200. So in this case, we have done for this. Let's do for this one. This one, there is no slab here. Yeah, there's no slab here. There's no slab here, and also there's no slab here. That means these are boundary condition. This and then this. Yeah, this end of a beam. This end of a beam. So I'll hold my control key from this point. I'll hold my control key. You hold your control key and drop it at this point. So you have provided reinforcement for this area. Yeah, you have provided reinforcement for us for this area. Then in this case, look at what we're having. In this case, look at what we're having. Here is a cantilever. Why here is a cantilever? Why here is just a beam? Remember, this is a staircase region. This is a staircase region. Then in that here is a void. So what I'll do now is that I will click on my cantilever, then the end of my beam. So I'll start from this point. I'll hold my control key, hold your control key, and drop it here. It has provided reinforcement for us. So this is how you are going to do it all around. This is how you are going to do it all around. This is how you are going to do it all around. Okay, let me show you in a case. Let me show you in a case where you are going to use this. Yeah, where you are going to use this boundary condition. For example now, assuming we want to master structural design in just 10 days. I created a course where I carried out the full structural design of this residential building step by step. In this course, I broke down everything you need to know about structural design, starting from the fundamental engineering principle all the way to the practical detailing. Honestly, it is far more in-depth than anything you will find for free on YouTube. And think about it, if my free lessons are already this good, just imagine my paid courses where I poured out all my knowledge and real-life experiences. This 10-day structural design masterclass is all you need to become a confident and competent structural engineer. And the best part is, it is affordable because I consider that most of you are still students. So click the first link in this video description and access the course. I want to show you something. I want to design only for this area. Yeah, only this beam. Now I want to show you where you are going to apply this. When you are going to apply this. So in designing this, what I would do now is that, remember, I want to design only this cantilever beam. So I'll click on my first boundary condition is cantilever. So this cantilever. Then my second boundary condition, since I want to design only this, will be this. I'll click on what? This. I'll click on this because there's a beam here and there's a beam here. So I'll click on this. Hold my control key. Hold my control key to straighten it. Then you click on it. Look at it has provided reinforcement for it. So in this case now, as me, okay, remember we applied a line load here. So as me, I want to design only this inside one without designing this cantilever. What I'll do is that, what's the boundary condition for this area? I'll click on what? I'll click on this. Then what's the boundary condition? Because remember, I don't want to include this place. So what's the boundary condition of this place? It will be what? Continuous slab. Yeah, it will be continuous because there is a slab here and there's a slab here. So I'll click from this point. I'll hold my control key and drop it at this point. See, it has provided reinforcement. Let's check. It's still T12 at what? 200. Yeah, so this is how to go about it. So this is how you're going to do every single thing. Okay, let's come over to Y direction because I know we have not done enough. We will not really do Y direction. So I want to do Y direction across this. So what I'll do now is that across this whole one, I'll click on what? Y direction. I'll click on this Y direction. So what's the boundary? Here is a cantilever, and Y here is also a cantilever. So I'll pick cantilever. So I'll come over to this point. I'll zoom, drop. Sorry, I'll escape again. I'll escape, then I'll zoom, drop. I'll always say escape again. I'll zoom, drop it at this point, then zoom out. Hold my control key to straighten the line. And drop it. So if you see, it has provided reinforcement. T12 at 200 spaces. So this is how you are going to do it all, and this is how you're going to do it, and make sure you design everything. But since majority of what I'm seeing here is T12 at 200, I know that what I'll be using here is T12 at 200. So that's what I'll be using, T12 at 200 for all this, T12 at 200. So I'll be entering into foundation analysis right now. Yeah, with what I've explained so far, you can just finish up, or or you can get the paid course and learn better and learn better. Yes, you can get the paid course and learn better. So with what I've explained so far, you can finish up the rest. So what I'll be doing right now is what foundation design. So to carry out your foundation design, what you do is that you come over to story 00. That's where you carry out your foundation design. Story 00. So this is our foundation design. At this point, what I will go to do is that to carry out the design of this. But first, before you carry out foundation design, please, there are two settings I would like you to do. First is that you come over to this analysis tab. Click on what? Building analysis. Yes, come over to analysis. I want to show you something. Click on building. Let's wait for it. Then click on this edit road. Edit road. Let's edit material. Then come back to foundation. If you did not change the things that are here, please make sure you change it. For your soil report, is it sand or is it clay or is it silt? Make sure you specify, and don't make sure you change all these things. If you are through with here, you come here and click on OK. Then come over to this point and click on close. Then come over to your setting. Once you come over to your setting, come to building, come to foundation. You come to foundation. So what is the soil unit weight? The soil unit weight is constant, which is what? 18.00 kilonewton per meter cube. So that's our soil unit weight. The allowable soil stress, this is a constant that is gotten from the code. Why the allowable soil stress? That's the bearing capacity of the soil. In this case, this building I'm working on, the allowable soil stress, which is the bearing capacity, is what? 200. Yeah, it's 200. That's the place where this building will be constructed. Why the soil vertical subcharge coefficient? This one is gotten from, if you want to know more about this, you can click on this and read on Joseph Voice. Look at it, read on Joseph Voice. Or if you don't really know anything much about it, leave it at constant. But as I'll advise you to always leave this as constant, because this man Joseph Voice have done a lot of research. So, and I've concluded and came to a conclusion that the universal or the constant one should be used is what? 500. But if you really know much about it, that's if you really know much about soil and foundation, you can really go in and then change it to lower limit and upper limit based on the one you prefer. Yeah, so with this, but I will leave it at what? Constant. Or you can go and read more on Joseph Boy, because he wrote a textbook on foundation. Yeah, that's soil. Then read more on it and get more knowledge on it. Then what is our laying concrete thickness? The laying concrete thickness is just as grinding. Yeah, the weak concrete. Okay, what's laying concrete or what is grinding? Grinding is just the weak concrete we lay first before placing our reinforcement. Reason is just to prevent rust. It's just to prevent rust, because you know that if you start placing reinforcement directly on soil, it will come in contact with moisture, which is water. It will not result to what is called rust. And to remember, rust, it leads to the degrading of the steel. So we used to place first of all a weak concrete, which is the laying concrete. So what is the thickness? I want the thickness to be what? 50. I want the thickness to be 50, which is what? Center as well binding. So the reason is just to prevent moisture from attacking our rod or our reinforcement. Then what is the strip footing cantilever? We are not dealing with strip footing, so I'll leave this. What is the default part footing form? I'll choose what? Square. I prefer to what? Go with what? Square. Then coming over to this point, this one's leave it at this point. I leave it at default. Then what is the minimum footing width? I would like to go with 1000. What is the minimum part base depth? I would like to go with 300 and not 400. I like to go with 300. So I will change it to 300. What is the maximum steel bar spacing? Yeah, the maximum steel bar spacing, I'll still like to leave it at 250. Then what is the size increment? What do you mean by size increment? For example, if they design with 1000 and 1000 should fail, what is the next dimension that they should check out for? Is if you choose the size increment should be 50, that means the next dimension that you check out for is 1050. But if you choose the size increment should be 100, that means the next dimension that they will check out for is what? 1100. For example, as me are using a footing size, assuming footing size of 1500 failed, and you say that the size increment should be 50, that means the next footing size that they will shake is what? 1550. And if 1550 fails, that means they will leave it like that. But if you choose a size increment of 100, that means the next footing size that they will shake is what? 1600. They will increase it by what? 100. So that's what you mean by size increment and also depth increment. Yeah, I would like to leave this. I like to leave both of them at what? 100. If 300 should fail, they should go to what? 400 and not 350. So what is this one? What is concrete cover? I like to use a concrete cover of what? 50. Don't forget, this is foundation. In foundation, our beam, our concrete is coming in contact with soil. Yeah, and to remember, soil. If rain should fall, soil will become moist. So if you don't have enough concrete cover, that means it will attack our steel, it will attack our reinforcement, and it will now make our reinforcement to lose its what? property or what quality. So for that reason, we're always using enough concrete cover once it comes to once it comes to foundation, because it is in contact with soil. But if it's superstructure, that's all these coding beam that are not in contact with soil, we normally use either 25 or 35 based on the structural engineer. So it's based on the experience. So in this case, look at the part. I say use top bar. I will not like to use top bar, because the reason why I'm not using top bar, because this is a part based footing. The only part or the only time that we need top bar is when it is a combined footing. If you're having a combined footing, that means you're going to use top bar. So let's just wait. If you send combined footing here, that means I'll show you how to apply top bar and the principles behind that top bar. But if we do not see it here, that means you should get the paid course, because I know I explained about top bar in the paid course. So with this now, yeah, minimum steel bar and distribution bar. So y system. So we are good to go. We click on what? Okay, we have done our setting. Then the next thing to do now is that I'll come over to this. Once I click on it, click on what? Insert part footing. I'll click on insert part footing. So let's wait for it. It's rolling. So look at it now. It has designed. So they gave us that the part footing should be got 100, 1000 by 1000. We are okay with that. The depth is what? 300. The concrete cover, which is what we shows, is what? 50. Then you can choose to relabel your footing. You can see to label your footing. You can call it base type 1. Let me say that's BT. Okay, let me turn it to capital letter. So you can just try to name it BT1. But me, I always like to leave it at default. When I get to detailing, I will change everything. You get to understand, because I'm going to do some of the detailing. But if you still want to learn more of it, get the paid course. But I'll still explain. Yeah, I'll still explain almost everything here, because it's just that sometimes I'll forget to say some things. But in the paid course, I make sure I say everything. So with this now, you can just come and shake up these ones. Then this one you can just save it, analysis. Then these are the materials that we chose. Then this one is for, okay, this one is the size increment that we chose. That's the settings that we made. This one is the column load. Yeah, the column load. These are the load coming to the column. Yeah, this is the column load. These are the load coming to the column. In case you want to design it manually, or you're doubting what the software gave you, yeah, you can come from here and also here and get your column load. Then this is the labor. So this is our labor. So in case you want to apply top bar, in case you want to apply, okay, let's go over to 3D view. Let's wait for this to appear. In case you want to apply top bar, what you're going to do is that you click on this and you check on this. So these are the two ways to apply top bar. You check this. So these are 3D view. Let's so if you want to apply top bar, you check this. Look at it. Let's move up again. Look at it. That it has applied top bar in one direction. If you also want to apply in the other, in another direction, you also check this. So the top bar is not applied in both directions. But we don't need top bar, because this is a part footing. It's only in combined footing that will apply top bar, because there will be a moment. Yeah, because you know that in combined footing we're having two columns. We're having two columns, and two, they're having different load. So one, it might try to tilt to the one with a heavier load. So that's why we do provide top bar to counter those moments and everything. But don't worry, if we see anyone, I'll lead it. I'll not explain so you understand. So like this, and I'll click on what? Okay, we have checked everything. So I'll click on okay. We are good to go. We like the design. So I'll right click again. Let me right click again. Sorry, I'll right click. I'll right click on what? Path footing. Let's wait for that logo to appear. So once I'm having this 1000 by 1000, you can check everything. I'll click on what? Okay. So I'm good to go. Yes, I'm good to go. I'll click again. Click on insert part footing. I'll click on insert part footing. Let's wait for it to appear. So 300, 1000 by 1000. So we are still good to go. The reason why we are getting 1000 by 1000 is because we have a very good soil bearing capacity. Yeah, the soil bear is 200. Yeah, 200. And 200 is a very good soil. It means that it's a very good soil. It means that if you go to that site, there is a probability that you'll be seeing stones there. Yeah, there's a high probability that you'll be seeing stones there. Yeah, so once we have stone, it makes the soil to be more rigid. So that means it is good. It will be able to carry more load. So that means 200 is a very good soil. And if you go to that side, from experience, you'll be seeing stone. Yeah. So with this now, I'll pause this video and insert all the past bits, because I don't really want this video to be too long. So I'll pause the video. I'll click on okay and pause. So right now we are done inserting all the part footing. Yeah, all the part base. We are done inserting all of them. So let me come over to my 3D view to see what I've achieved so far. So I'll click on my 3D view. So this is what I've been able to achieve. Look at it, everything well done. Let me come over to the front view. Yeah, this is the front view. So this is what we're having right now. So look at it, everything. So now what we'll be doing now is to export this to ProtaStructure, to export this to ProtaDetail. Yeah, we have to export this to ProtaDetail. So what I will do now is that I'll click on this drawing and report. Then I'll click on ProtaDetail. I will click on it. Let's wait for it to load. So you are asking me, do you want to save the changes? I'll click on yes. So let's wait for it to load. This might take a while. So everything I've loaded, so you have two options. You can click on start by generating a new drawing, or you can click on auto generate detail. You can click on any of them. But in this case, I would like to click auto generate detail to generate everything. Okay, yeah, to generate everything at once. So I'll click on auto generate detail. So it will just generate every single thing at once. So I'll click on what? Draw. Yeah, it depends on the one you want. Sometimes I used to click on the generate it one by one, but since this video is already taking too long, I want to click on auto generate detail. If you want to know how to do it one after the other and do it accurately and perfectly, you can still get the paid course, or you can still go with this auto generate detail. So let's wait for it to generate everything. If you see they are saying adding floor plan, so it's generating. So this might take a while. I will stay pause. Look at it has appeared. Yeah, it's appearing small, but I will stay pause this video. So right now everything has been generated. So you can see it. Everything has been generated. So the next thing that I will be doing now is to export this drawing. To export this drawing. So I'll click on this export. Right click on what? Export. So at this point, I'll now come and look for where I will save the file. I will save this drawing. So I'll click on this change directory. So let me just locate. I would like to save it here, just anywhere. I like to save it here. So I would like to save it. Okay, see Sarah. I would like to save it at this. Let me just save it here. I'll just click on OK. Then I'll click on what? Export. So let's wait for it to export. Look at it's loading. Look at I've been seeing it's loading. So it's exporting. It's exporting. So once we are through, that means we are through with this video. We have come to the end of this video. Don't forget, you can get the CAD file and practice on your own. Yeah, you can get the CAD file and practice on your own. Or you can get the 10 days intensive structural design detailing and masterclass. Yes, that course is designed for you. It will really help you. It will really help you. So look at the drawing here. Look at the drawing one. So look at it here. This is where I saved it. So I cannot double click on it. It will not open in AutoCAD. But that will be done in our next video, where we'll be doing our foundation detailing, our path-based detailing, our column detailing, our beam detailing, our slab detailing, our staircase detailing. In fact, all the detailings and how to print your drawing professionally. But don't forget, if you want to learn everything in detail, get this 10 days intensive structural design and detailing masterclass.